Good morning, everybody. Welcome. It's another day, another beautiful day in Finnish summer. Did everybody have breakfast already? Got your coffee? Oh, there's so much energy in this room. I mean, wow. Today we'll be going the same way as yesterday. So there will be 3 team sessions, and there will be Q&A after each session. So remember to go to Slido and add your questions during the session. So we'll get your answers afterwards. So the first session, I have a little hunch what to expect, but not really. So this is going to be a surprise, and I mean, I love surprises. It's going to be Deno and Friends. Oh, no, sorry. It used to be Deno, now it's Dino. Yeah, I expect it soon to be Dino, right? Okay. We're going to have a joint talk. So Joe and Luca, welcome to the stage. You can introduce yourself better.
Hey, yeah, thanks for having me. Joe's going to be on a bit later talking about, I'm going to be here this morning talking about JSR. Oh, I don't know how this mic works. 1 second. Okay, there we go. Can you all see my screen? No, not yet. Who do I have to pester to see my screen? There we go. Okay, cool. JSR. So, good morning, everyone. I'm Luca. I'm a software engineer at Deno. Deno is a JavaScript, TypeScript runtime that Joe will tell you more about later. It's not super important for this talk, though. I'm a delegate to TC39. You may have heard TC39 was going on at the same time as this conference here in Helsinki. We spent the last 4 days, or 3 days, deliberating how to make JavaScript better, well, hopefully at least. And I think there's another panel later with a bunch of TC39 folks that are going to be talking about how we standardize JavaScript. I also will do a lot of work on WHATWG and W3C specs, like the fetch spec or the URL spec. And I'm a chair of WinterCG, which is a community group at the W3C that works on making APIs or making sure that web APIs work well between different server-side runtimes. So making sure that you can use fetch in Node and in Deno and in Cloudflare Workers, and it works the same way as in browsers. But yeah, today I'm going to be talking about JSR, which is a new JavaScript registry. I'll tell you more about that in a minute. But let's talk a little bit about the background. So if I asked any of you today, how do you publish a JavaScript package? Probably everyone, most of you would answer NPM, right? You write some code, you set up a package JSON, and you publish it to NPM. But it's actually not that easy to do this in 2024. You are probably writing TypeScript, so you have to first take your TypeScript code, compile it to JavaScript and declaration files. You have to then set up your package JSON with different export conditions for CommonJS and ESM and the TypeScript declarations. Probably if you're doing this, you won't have go-to-definition that works for your consumers because TypeScript has like 3 other options you need to set up to make that work, and they all like are challenged to set up. As a consumer of NPM packages, you often have to deal with like big packages because NPM is not very smart about the way it downloads code. It just like downloads a tarball and stores it on your disk, and maybe half of that tarball is just tests and README files, but doesn't matter. They're still on your disk. It's going to use up that space. And then finally, like NPM, even though some people may tell you otherwise, it's Node's package manager, NPM, Node package manager. And that means that it makes a lot of assumptions about Node, like that you are running in Node with Node's resolution, and you have a package JSON, and you have a Node modules folder. And this doesn't really even work well in the browser. So for browsers, we have all these very complicated build tools that that emit some code that can then run in the browser, because NPM packages can't run directly in the browser. So really, I don't want to deal with any of this. I want to just be able to publish my code without having to do all of this stuff. But why is it even like this, right? Why is it so bad? It's not this bad when you're making a website or when you're like downloading a code editor or when you're, I don't know, even publishing a package in the Rust ecosystem. Why is it so bad here? Because the NPM registry is sort of done innovating. NPM is owned by GitHub, which is owned by Microsoft, and it seems that they're not interested in really improving the NPM registry. And this is really unfortunate because NPM sits in between everybody that wants to consume JavaScript packages and everybody that wants to publish JavaScript packages, which is like literally all JavaScript developers, right? So everybody that wants to use JavaScript in some way has to go through this bottleneck that GitHub and Microsoft have decided are done, right? And they're done in not a very great way. And you can see this on like the NPM website. The NPM website is the exact same it's been 5 years ago. The last two things they added were this tiny little TypeScript icon in the top left there, which tells you whether there's types for your package, and this code tab, which has been in beta for 3 years and still does not put the file that you're on in the URL bar, so you can't share it with anyone else. Why? And this is really strange because like the entire ecosystem around NPM has been evolving. Package managers popped up left, right, and center. Yarn, PNPM, Yarn really pushed NPM to fix their speed of installation, showed that it's possible to install much faster. PNPM showed that using some very smart deduplication, you can save a lot of bytes on disk by sharing node modules folders between projects. And NPM started adopting these things in the CLI, but they never had competition on the registry itself, so they never improved there. And this is particularly concerning because JavaScript is a very, very dynamic ecosystem. Like, you may know this joke. There's a new JavaScript framework every week, and it's true. Like, we publish libraries all the time. And this is like the JavaScript ecosystem is known for this innovation. And yet, the NPM registry is just stuck. It's not keeping up. So how do we fix this? We somehow have to innovate the registry, and we can't innovate NPM itself because, again, NPM's stuck. Nobody wants to touch NPM. NPM is not open source. We can't do it ourselves, right? GitHub has to do this, and GitHub doesn't want to do it. So we have to do something other than NPM. And the way to innovate is to sort of radically simplify the user experience. And the way you do this is first you have to figure out what you're even trying to simplify. So let's think about like the two different groups of people that care about a JavaScript registry. The people that are consuming code from it, so the ones that are building applications and websites, that are downloading libraries, and then the people that are publishing code to the registry. And they care about slightly different things, but it's a shared, they have this shared overall vision of things should be relatively simple. But like consumers, they really care about having an easy way to find packages that are high quality, whatever that means. They want to have good documentation for their packages. They want to make sure that when they find a package, it'll just work in their editor. They get type completions. They want to make sure it installs easily in their runtime and that it also works well with their runtime. They probably care about supply chain security in some way, right? They don't want their package to just install some random stuff onto their system. And they want to be able to audit whether the package was actually published by the person that said published that package. They care about good debuggability. They don't want to be debugging through like minified JavaScript files, but rather through preferably the original TypeScript source code. And NPM really isn't very good at most of those things right now, unless a publisher puts in a lot of care. And that's unfortunate because publishers want to minimize the amount of effort, right? They want to just write some code. They don't really want to spend the majority of their day trying to configure the tsconfig file, your package JSON, and like all the tools you need to sort of set up your package in such a way that it does all these things that consumers care about. Publishers want something simple. They want something that reduces boilerplate. They want wide compatibility for consumers without having to like figure out what that means, right? They don't want to care about like CJS versus ESM. They just want to write some code and publish it. So let's talk about JSR. JSR is our solution to this. It's an open source, completely open source JavaScript registry that was sort of incubated at Dino, and we have launched to the JavaScript ecosystem, and can be used sort of like a drop-in replacement for NPM. So let's talk a little bit about how to fix these individual points here. Firstly, we already have a tool that can make consuming packages really nice, right? Like we have TypeScript. TypeScript, when you write your code in TypeScript, will give you types. And types are great because types can allow you to generate documentation, like using TypeDoc or something like that. But they also give you really great editor completion. So when you import a library, you can just like search through that library by just trying things out in your editor, and then the auto-completions will tell you whether that'll work or not, which is really, really nice. But yeah, there's a problem with this, namely that everybody has to transpile TypeScript right now, because that's what you do on NPM, right? You can't publish TypeScript directly. You publish JavaScript files and D.TS files, which means when you're publishing, you first have to transpile all your TypeScript. This adds a couple of problems, like it makes it very hard to audit your code because there's this opaque step somewhere that takes all of your source code and then mangles it in some way and outputs some new code, which sort of breaks the like supply chain security, like trust chain that you want. And it also adds significant complexity for publishers. Like if you've ever talked to anybody that publishes a large TypeScript project, they're going to have some horror stories about like how they had to use project references and declaration maps and all these crazy things to get their TypeScript to emit correctly. So what's the solution to this? Your registry just understands TypeScript. You just publish TypeScript to it, and the registry deals with it. There's a bit of a caveat here, though, which is Node, the most widely used JavaScript runtime outside of browsers, doesn't support TypeScript. So you can't just like upload TypeScript and then download it for a Node project, because Node won't know what to do with it. So for this, we need to still at some point turn that TypeScript into JavaScript. But we can do this in a single centralized location inside the registry where a trusted transpiler can take the TypeScript code and turn it into JavaScript. And this gives you some nice benefits for supply chain security, but it also means that publishers don't have to deal with this. They just upload TypeScript, and then for users that need JavaScript, JavaScript pops out on the other side, and they don't have to deal with it. So it looks like this. You're writing some TypeScript files. You write a little jsr.json file. This is like your package manifest. It has a name. It has a version. It has some exports. But there's no like import, require, and types in these exports. These are just like very simple name in your import specifier to file mappings. And then it goes into JSR. And then JSR will generate a bunch of things from that. It will have a way for you to import that package in a bunch of different runtime environments, in Node-compatible environments like Cloudflare Workers or Node itself. But you can also import them directly in Dino, and that will give you some other benefits, like Dino understands TypeScript. So when Dino is importing something from JSR, it'll actually not pull down the transpiled JavaScript file, but it'll pull down the TypeScript source code directly, which gives you a bunch of nice benefits during debugging. And then additionally, because you're uploading the original TypeScript source code, we can just take that source code and generate documentation from it. So JSR just generates documentation for literally every package you publish to it. And it's on the website, and you can search through it. I'll show you more about that in a bit. But just creating a new registry isn't really good enough, because most people already use NPM. And if you just create a new registry, and everybody's already using NPM, and it requires them to like republish all of their packages onto that new registry before they could use it, nobody's going to use it. So we don't require you to do that. JSR can just import packages from NPM. You can also use JSR packages from any project that already has NPM set up. So if you're in a project that has a Node modules folder and a package.json, there's a command you can run that will install a package from JSR directly into your Node modules folder using your existing package managers. So like pnpm, yarn, even the npm CLI itself can install packages from JSR. Yeah, and this means that JSR is like very good at catering to different runtimes in their preferred format. So what I mentioned earlier, when Dino pulled something from JSR, it downloads it in TypeScript. When Node pulls something from JSR, it downloads it in JavaScript. JSR is really good at this. You publish some clean TypeScript source code, and then JSR will know what all the different tools will understand and give them a different result that is optimized specifically for that runtime. And JSR also has indicators on the website that a publisher or an author can use to say, hey, this package works really well in Dino, this package works really well in browsers. So a user at a glance can just really easily figure out, hey, I can use this package in my Node project. JSR is also really secure and auditable because of this publishing of TypeScript, plus some other things. One of the really cool things I think that JSR does is every time you publish something from CI, and actually when you're publishing from CI, you don't need to have some authentication token. It just like knows about GitHub Actions, and you can go to the website, link your GitHub repo, and then publish directly from GitHub CI without having to set up any tokens. Every time you publish from CI, it logs something to a public transparency log. And that transparency log says, this user at this time from this repo published this package to JSR. And this is like a cryptographically verifiable way to see that the code that you're using is actually was actually published by the person that you think published it, and not by some malicious third party. JSR can generate documentation from your TypeScript. You just write tsdoc or jsdoc in your source code, and JSR can generate this nice HTML view of all of your functions and your packages directly on the website. JSR can even link directly to MDN or your runtime's documentation when you have things like a uint8 array or maybe some built-in API from your runtime. Another thing that's really cool, because JSR has so much information and like very raw information about your package, like the amount of documentation you have and the sort of amount of types you have in your code, we can generate a score from these things. And we can like in a very glanceable way tell you this package is very good. It has a lot of documentation. It's probably easy to use because of this. And this makes it really nice for users when they're searching through a bunch of packages to quickly say, hey, these ones may be doing the same thing. This one has a lot more documentation. I'm going to use the one that has more documentation. And there's a lot more, right? Like I mentioned earlier that NPM's files tab doesn't let you link to specific files. JSR's files tab does. You can yank individual packages. So if you're publishing something on a Friday evening, and then you get a flood of bug reports that something's broken, you just go to the website on your phone, click on the yank button for that version, and then the problem will be deferred until Monday, right? This is very nice. You can view dependencies, dependents on the website. You can do symbol search. So there's a search box on the website. You can open a package, type a name or something into that, and then you can see whether that package exports that function and see all of the documentation for it. So let's try it out. What time are we at? Perfect. So let's start by figuring out how Chrome works. There we go. OK, so let's go to the JSR website. This is the JSR website, jsr.io. You can see I'm signed in. And the first thing you're greeted with is a giant search box to search for packages. So let's search for std bytes, which is a part of the Dino standard library that helps you manipulate uint8 arrays and similar structures like that. So when I click on a package, the first thing you see, or actually, let's head back to the search. The first thing you see is in the search, you have the runtime indicators here. So you can see that this package works in browsers, it works in Dino, it works in Node, it works in Cloudflare Workers, it works in Bun, and it's a 100 score package, which means that there's documentation, there's good types, it's published in a secure way. Like you can hover over this and see it's built and signed on GitHub Actions. I can click on this transparency log button, and this is very small, but like there's a cryptographic signature in here that tells you that this was actually published from GitHub Actions and like what repo it was published from. You can see all of the symbols that are exported. So there's a concat function. This concat function concatenates multiple uint8 array buffers together. There's some usage examples here. This is like nice documentation, right? I can click on this uint8 array. It takes me to MDN to tell me more about what a uint8 array is if I don't know that. I can go back over here and see the list of all the different exports that this package has. I can see all the different versions. I can see all the dependencies. This package has no dependencies. I can see all the different packages that depend on this package. I can see the score. These are all the different like indicators that go into whether you have a 100% score or not. Yeah, that's like sort of what JSR looks like from a consumer side on the website. I'll show you how to install a package in a bit, but let's go on to writing some code. Let's publish a new package. So I have a editor here with a TypeScript file, and I intentionally haven't written like any tsconfig files or anything like that, just to sort of like go through the entire process with you. So our first step in writing a package is figuring out what we even want to write a package for. And what I'm going to do is I'll write a package that has a function called detect that tells you which runtime you're currently in. So it'll return a string that's either Dino or Node or browser, depending on whether it's running in Dino or Node or in the browser. And it'll actually also return null if it couldn't figure out what runtime it's in. So I can just start writing my code here. You probably all do this 100 times a day. So let's write some types for this function. My detect function can, as I said, either return Dino or Node or browsers, or well, browser or null. And then we add some conditions to check whether we're in a certain environment. So if Dino is in global this, if there's a Dino global, then we're in Dino. If there's a process global, then we're in Node. If there's a document global, so the like HTML document in global this, then we're in a browser. And otherwise, we return null. OK, that's our package. It's a very, very complex package, right? So let's start by seeing whether this works in Node. As I said earlier, Node can't run TypeScript files, so I'm going to have to pipe this through TSC or something to check whether it works in Node. So I guess I'll do that, TSC index.ts. And I run this, and it outputted comment.js, right? Bad default, but I guess fine, we'll deal with that. Let's add module. I don't know what the different options are. Module ES next. OK, probably that's ESM. Yes, it is. Great. OK, so now we have JavaScript source code. That's great. Let's try to use that in a Node project. So I have I'll create a new little file here, main.js, import detect from index.js, and console log detect. And then I run that file through Node. What is it? Oh, it wants an ES module. OK, it has an ES module. Well, anyway, I have to create a package JSON file. Yeah, I don't know. I'm not a Node developer. I'm sorry, folks. Here we go. OK, I need to call the function, though. There we go. And we're Node. OK, I hope you can all see that. Oh, no, you can't. There you go. Now you can see it. We're Node. Let's also try it in Dino. So in Dino, I can just open the REPL, import detect from index.ts. Dino can just run TypeScript files. And let's call detect here. And we're in Dino. OK, so our package works. Let's publish it. So if we were to publish it to NPM right now, we've generated JavaScript so far. We would now need to generate some d.ts files. We'd probably have to generate source maps and declaration maps. But remember, we're not publishing to NPM. We're publishing to JSR. So I'm actually going to get rid of all these files and just create a JSR.json file. And what do I put inside this JSR.json file? Well, I go to the website. And I click over here and click Publish a Package. And then I'll have an interactive flow that walks me right through how to publish a package. I'll select a scope. All packages on JSR are scoped. There's no top-level name squatting on JSR. All packages are inside of an @ scope. And I have to give it a name, runtime detector. And I click on Create. And now I have a new package on JSR. And I have instructions on how to publish it. So it tells me I have to create a JSR.json file with these contents. Let's do that. So the contents here are the name. This is the name of the package on JSR. The version that I want to publish, currently publishing 0.10. And then the exports. Exports is the files that you want to expose in your package. And I don't have a mod.ts file. I have an index.ts file. So I'll change that. And then I can publish. And I have two options on how to publish. I can either publish from the CLI using like an interactive flow, or I can publish from CI. For now, let's publish from my local terminal, and then maybe if we have time, we can publish from GitHub later. So I copy one of these commands. If you have Dino, you can just run Dino publish. Otherwise, you run npx JSR publish, and press Enter. Oh, I have to download something, and here we go. Oh, OK. Then, OK, this is what it did. I ran npx JSR publish, and it sent me over to this website, and this website is asking me to interactively authenticate. So remember, JSR doesn't do authentication tokens that are stored on your system because that has a lot of security issues that come with it. So instead, every time you publish something, it pops up a browser window where you're logged in with your GitHub account, where you can click on Approve. And when you do that, you can see on the website how the publishing is going. Take a couple seconds, and there we go. The package is published. So if you now go to @Luca runtime detector 010, you'll see this package. But you can see this is not great so far. We don't have any docs. We have a super low score. But you can already see my detect symbol is here. And we already have some very basic documentation that was generated from the types. So the documentation really gets better as you improve it yourself, right? Like as you write comments on your code, the documentation improves. And you can see this because if I go back to my terminal, or my editor rather, and I add a comment on my code here that says, I don't know, this function detects which runtime you are executing in. Returns the runtime you are in, and null, the runtime could not be detected. Excellent. And then I bump the version, and I run npx publish again. And I click on Approve. And wait a second. And I click on the symbol now. I have more docs. I'm sorry, the screen's cut off at the bottom there, but OK, yeah. So you can just gradually improve your docs, and you can see that actually just adding docs for this function took my score from a 29% to 58%. Docs is like the majority of the score. So if you have more than 80% of your package documented, you'll get full marks on docs. If not, if you get less, if you have 10% of your package documented, you'll get like maybe one part of the, or well, I don't know. If you have 1 of 10 symbols documented, you'll get like 1/10 of the score for it. But there's a bunch of other things I can easily do to improve my score. They're all listed out in this list over here. So one of them is the package has a description. Right now, if I search for this package, it won't show up with a description. So I can change that by just going to the settings and saying, this package, or well, detect which runtime you are executing in. Save that. Took my score to 64. Great. Runtime compatibility. What browsers? What does this work in? It works in browsers. It works in Dino. Works in Node. And it doesn't work in Cloudflare Workers and Bun because it can't detect those. So I'm going to mark them as not supported. And save changes. And you can see this shows up in the works with up here now. And my JSR score has gone up to 76. What else can I do to improve my score here? So has a README? Yeah, I can add a README. So one of the things that JSR gives you a score for is having a README, but the other one is having an example in your README, because we think it's really important that when you drop on to a package page, you can immediately get some idea of what to do with this package. And an easy way of doing that is usually by having an example that you can look at and see, hey, I can import this thing from this package and use it. So let's do this. Runtime detector. I feel like I'm going to write the same thing over and over again. This package detects what runtime you are in. And I'll add an example for how to use it. So import from Luca runtime detector. And the function was called detect. And let's log that out. And this could print out Dino, for example. And then what I do is I will bump my version again and run npx JSR publish. Click on Approve. Give it a couple seconds. And it's published. And now I have a README, and I have 100% score. OK, so published a package. It's on JSR. It has 100% score. But how do I actually use this package? So you can use it in a bunch of different runtimes. We have this nice little drop-down over here that shows you the different runtimes you can use it in. If I'd selected Bun as one of the options in my works with, then it would also show up here. But I didn't. So let's start with how to use it in Dino. I can go back to my symbol, and it'll show me exactly. I can Dino add this package. I have an empty little Dino project over here. There's nothing in it. It's a Dino JSON file and a main.ts file. I run Dino add. and that's added the package, and then I can import that. So this is what the Dino.json looks like. And then I can import that and run detect. And you can see I have docs, right? It pulled the docs directly from JSR. If I click on this, I'm in my TypeScript code. This is not JavaScript code. This has comments on it. This is my original TypeScript code. And you also see I don't have a node modules folder or anything like that. That's just how Dino works. Dino installs everything into a global cache directory. You don't need to deal with folders local to your project. And I console log this detect function. And if I run Dino run main.ts, Dino can run TypeScript, remember, logs out Dino. Cool, this works in Dino. Let's try Node. So what package manager should I use? What's your favorite package manager? I see a very enthusiastic audience this morning. OK, fine. I will use Yarn, because nobody answered. So this is a Node project, empty package JSON. I just have type module in here to make sure this is an ESM project. And I can just run yarn DLX. Yarn DLX is like npx, but for yarn, JSR add Luca runtime detector. And this is going to add my JSR package to my package JSON, install it into my node modules folder over here. And you can see in my node modules folder, there is now actually a JS file, because remember, node requires JS files. There's also my TypeScript source code, though, and you'll see why that's important in a second. So I can do the same thing over here, import my code. I can head back here, copy the symbol, and paste that in there. And then console log detect. Oh, detect. And yeah, my types also work here now. And because of the way that JSR transpiles your code, if I click on this detect, it actually also opens the TS file, right? So when you're debugging, because of the way that the source maps work, when you're stepping through things in the Chrome debugger or in the Firefox debugger or anything like that, you will be looking at the original TypeScript source code for these packages. You won't be looking at transpiled or minified JavaScript, which is really nice, really, really nice. So let's see if this works. Node index.js. It does. You can't see it, but it does. It executed in Node. And if I was running in a Vite project, I could just import the same package in a Vite project and try it on a browser. It would work too, but I don't know if I have enough time for that. I have time? OK, then let's try that. So let's go. I will delete all of this stuff in here and run npx. No, what is it? npm create Vite. Yes. And we're going to say this is a vanilla project. We're going to use TypeScript. And hello. Oh, Vite project. OK, so we have a Vite project, brand new Vite project. And I can do the same thing in here. I don't know what package manager this is using. Let's use npm to showcase that works too. npx JSR. Oh. Wrong project. npx JSR add Luca runtime detector. Press enter. And this is installing. And you can actually see it's using npm install under the hood. And my node modules folder now has my package inside of it. And if I head into this Vite project, actually, let's start it up first. npm dev. Oh, npm run dev. Vite's running. Let's see that it's actually running. It is. And I head over here, and let's just replace this Vite plus TypeScript with Vite plus detect. OK. Great. Vite plus browser. OK. Project works in Vite too. Excellent. So yeah, that's publishing to JSR. I didn't have to deal with tsconfig files. I didn't have to deal with any build tools. Things sort of just worked. And I have a really nice page now that has a score, or sorry, that has has documentation for my package. Oh, this is the old version. Has the runtime indicators in it, has README, all these things. This is like a nice homepage for my website now that I can share with folks. Yeah, and this also works as if you have a larger package. So the STD packages that I showed you earlier, there's like 40 of them or something. And some of them have like hundreds of symbols they're exporting. And this will scale to that. Like you will see documentation for the 100 symbols. You have search. So if I type detect in here, you can see my detect module shows up in the search. Yeah, that's that. Let's head back to my slides. OK, so I wanted to show you real quick how this documentation generation works, because I think it's kind of interesting. I don't know if this is large enough to see, but this is what your code looks like on the left. These are equivalent, right? So the code on the left generated the documentation on the right. And the way this works is that we interpret the JS doc comments on the left, and we sort of map them to places we put into the HTML on the right-hand side. So if you have some description on your symbol, we will put that in the HTML there. If you have an example, we will render that with a nice title in a code block with a little thing that you can open and close. If you have a lot of examples, this little uint8 array down here that's clickable and links to MDN actually is coming from the TypeScript types. And this little text over here that's describing what the source parameter does is coming from this @param function in my JS doc. So did we succeed in making the experience better? I don't know. That's up to you to judge. But I think I don't know. I think it's quite nice to use. Yeah, I could show publishing from GitHub. Let's see. Oh yeah, I still have 10 minutes. OK, I'll show you real quick how the publishing from GitHub works too, because I think that's kind of cool as well. So let's init a GitHub or a Git project and head over to GitHub, github.com. And create a new project, or new repository, rather. Runtime. What did I call this detector? I'll create this in my personal account. Create repository. OK, and then I will git add, git commit. Oh. Actually, can I do this? Yes, I can. I need to plug in my SSH key to publish to GitHub. OK, so I push my package to GitHub. Great. So now if I want to publish from GitHub, I can head back to JSR. And where is that? Over here. Head over to the Publish tab. And say I want to publish from CI. So the repo that I was using is Luca runtime detector. Click on link. And it's now linked to this repo on GitHub. This is the one we just created. And it gives me a GitHub Actions workflow file that I can add. And you can see there's no tokens I have to set up, right? This just works without any tokens. Where's the project? Here we go. So workflows. No, what is it? .github/workflows publish.yml. I paste that in there, and let me increment my version. So I'm going to publish 0.13, and I'll add some docs in here to show this is actually coming from GitHub. Coming from GitHub. And publish from CI. Let me commit that and push that to GitHub. And if we wait a second, GitHub Actions will trigger. And we'll start publishing my package to JSR. So we wait. How are you all doing this morning? Still very quiet. I can imagine. It's like 9 in the morning. I also didn't want to get out of bed. I'm happy you're all here, though. OK, we've published to JSR. Again, didn't have to set up any tokens. I can click on this link, and published from GitHub Actions. I have the little checkbox now. So if I go to my score page, you can see I have all of the checkboxes, including the hash provenance, which is the one that you get for publishing in a way that is verifiable for supply chain security. Cool. So yeah, that's publishing from GitHub. Also very easy, in my opinion. Let's head back to the slides. So that's all I had to show about JSR today. We'll have a little bit of a Q&A at the end after Joe's talk. But yeah, if you want to try out JSR, just head to jsr.io. If you want to publish a new package, jsr.io/new. And there's already a bunch of different packages on there that were at some point or another also published NPM, like Hono, the web framework, or Orama, the search engine, Neon, the Postgres database driver, valabot, the TypeScript type, I don't know, like input verification library, I guess. Launch directly a feature flag system. Yeah, you can find all those on JSR already. So thanks everyone for listening, and I'll see you all in a bit.
Thank you, Luca. Well, this is embarrassing. I thought this would be a joint session. This is how I live my life, constantly confused and embarrassed. Yeah, so like Luca said, we're going to have a Q&A after Joe's talk. So use Slido with the code FF2024, sli.do if somebody's new here. Yeah, let's give it up for Joe.
Excellent. Thank you. This is my kitten pickle. As we do a smooth transition from Luca, from the sublime to the ridiculous. I am nowhere near as confident as Luca, so I will not be doing live coding. Get my slides up here. Excellent. OK. So I'm going to be talking today about building a code editor in your browser. My name is Joe Franchetti, and I am a developer advocate at Dino. And yeah, we're going to talk about building a browser code editor. But why might we want to do this? Why might we want to build a code editor in the browser? Aside from it being just a cool project, there are quite a few reasons why you might want to make a code editor in your browser. If you work at a company that has APIs or offers other tools to developers, it's a great way to really improve your onboarding experience. If you offer in-page code snippets that developers can actually test out and use your product immediately without needing to set up their own local environment or swap tabs or things like that. An embedded editor within your documentation will allow readers to try out your code immediately. And an in-browser editor can really just offer a sort of hands-on experience for your readers. So they'll be able to modify code samples, see immediate results, and gain practical experience of your code. And if you're running a low-code or a no-code solution, like we saw Toddle yesterday, you may find that occasionally your users require just a little bit of extra functionality or versatility on top of the product that maybe your product doesn't offer them. So allowing them a safe way to run their own code just gives them extra freedom to build on top of what you're offering without them having to find a new tool or a new product, for example. But running code written by other people presents us with a problem. We can't trust code written by just anybody to execute on our websites. Allowing third-party code execution can introduce security vulnerabilities. We might potentially be allowing people to run malicious scripts, to steal data, to inject harmful code, and it's just going to compromise our users' security and privacy. So we need to prevent malicious code from wreaking havoc on our own databases. Not only that, but we need to, if we're going to be running third-party code, we're going to need to provision resources to run this code, which is going to need CPU, it's going to need memory, and that could potentially impact the load pages of our own website, our own products. So in order to build a system that's going to run third-party code, we'd likely end up needing to provision a huge amount of compute. We'd need to install something like Kubernetes on it. Then we'd need some management APIs to make sure that only the correct shape of code is allowed to run and it is allowed to be deployed on our cluster. Then we need to make sure that the container instances are secure. We'll need to make sure that we don't run out of storage. And we're going to end up needing to employ an entire ops team, really. And the truth is, building your own managed runtime is a couple of $1 million worth of problem, which is, quite a significant barrier to entry for most people, just to make a cool interactive experience on the web. So with all of this in mind, how are we going to build an in-browser code editor, and what do we need to do so? So in order to make a sandbox that is going to run server-side code, we're going to need a few things. So first of all, we're going to need the end-user app. So imagine something like CodePen or JSBin or many of the other in-browser editors that you've used before. And then we're going to need something to host our app on so that users can actually go to a website and use it. And finally, we're going to need some sort of application platform to run that third-party code on. So something like a serverless functions runtime. And I work for Dino, and we have some products that try and solve these hard engineering problems for you and help you building these kinds of applications. But what is Dino? So we had a brief introduction from Luca earlier. Dino is the open source JavaScript runtime for the modern web. It's built with web standards, built with Rust in Tokyo, and V8. And Dino natively, as you saw, supports TypeScript out of the box, so you can write your strongly typed code, and you can catch errors early without having to do any complicated tsconfig setup. Dino also has a whole load of tools included for formatting, for testing, for linting, and it just really streamlines your developer workflow. And you might have heard of Dino. We've been around for a few years. Dino was written by the same author who originally wrote Node, but he wrote it after looking back at a decade worth of Node real-world experience. And his aim was to level up the JavaScript ecosystem. So he's trying to sort of narrow the gap between the browser and the server side by allowing TypeScript to be a first-class citizen. We also play really nicely with your modern web dev tools. So we're going to be building our solution out using Dino as the runtime. We're going to use Vite as our web dev server. And we're going to, of course, use React as our UI framework. And you might be thinking, like, OK, fine, you work at Dino, but why would I want to add Dino into the mix here? And the answer is this. Not only is Dino great for running TypeScript code and running it fast, but it's complemented by a whole load of other tooling that I will talk about. And it gives you development extra utilities to make running the whole thing through Dino not only easy, but also hopefully a delightful developer experience. So I mentioned that we have a bunch of other tools. The easiest and fastest way to deploy Dino apps to the cloud is to do so with Dino Deploy. You might not know, but we're not only a runtime, we also build some really awesome tools for the web. So Dino Deploy is a web hosting solution. It's kind of similar to Heroku, very similar to things that you will have used before. And it's a worldwide platform that provides great JavaScript and TypeScript hosting. Instead of running on virtual machines, the applications are powered by the Dino runtime, and they run on efficient V8 engines, which makes the deployment process super fast and super lightweight. And finally, for our serverless functions, we are going to use this thing called Dino subhosting. And subhosting is a set of capabilities that's built on top of Dino Deploy, and it's designed specifically for securely running code written by multiple different users in a hosted and secure sandbox. It supports JavaScript and TypeScript. It's optimized for fast deployment. And we're talking cold start times in milliseconds here. I'm going to avoid doing a massive sales pitch, but the cool thing about subhosting is that it's built for people like you. So it's built for the tool builders, the site builders who want to offer serverless functions to your own customers. But you don't want to have to worry about the infrastructure, the scalability, the DevOps yourselves. So let's build our app. The first thing we're going to do is we're going to set up Dino. If you've ever used Dino before, I'm sure you've done this before, you can install it using curl. If you're on Windows, you can use Chocolatey. And if you have used it before, Dino's constantly changing and updating. It's probably more familiar these days than if you tried it a few years ago. So we're going to set up a basic Dino project, and that is no more work than just typing Dino init. And much like creating a node package with npm init, Dino is going to create a Dino JSON file, which is going to have our dependencies, our metadata, and importantly, some tasks, which are Dino's version of NPM scripts. So you can see our task here. Dino, we really care about testing, so you'll notice that Dino has also generated an example unit test there as well. Dino has a built-in testing framework to make your testing easy and fast and delightful again. So that's the 60-second intro to Dino. Now we're going to configure our repository to use Vite and do some actual web dev. So like I said, we're going to use Vite, we're going to use React, so we're going to install those dependencies, and we do that with the Dino add command, and then we're going to also edit our Dino JSON file and add a task called Vite start. So if you have a look here, you can see that Vite start task is doing Dino run -a, which is just going to give us all the permissions that we need. And then we're adding an extra compatibility flag in here, which is our node modules dir, which is just going to make sure that the node modules directory is present for any child dependencies that require it. When our next major release is launched, this will actually no longer be required. You won't have to do this anymore. And to set up the architecture for our app, we're going to make a client directory, you can see that on the left here, and a server directory. So in the client directory, that's where our Vite app is going to live. In the server directory, that's where our server-side APIs are going to live. That's where our Dino server-side code is going to go. So let's set up Vite config and configure Vite. So we need to make sure that Vite is looking at our client directory, so that's what we're doing here, and we're including React, React DOM, and we're correctly configuring our JSX runtime. Now, when we run that Dino's task, our Vite start, Vite is going to get executed by Dino and is going to be ready to host the React app that we're going to build. For the sake of brevity, I'm not going to tell you how to create a basic React app. I'm fairly certain everyone in this room already knows how to do that. There's nothing unusual about it. You just need to put an index.html and an index.tsx file in the root that uses React to get started. But let's have a look at some of the components that we're actually going to build out. So this is what we're going to build. It's a very basic editor. I only have 45 minutes here. If you're going to build this kind of thing yourself, then you can start to look at fun things like syntax highlighting and all of that. But for now, we're just going to put a text area in where the users can type in their code. We're going to put a button in so that users can execute their code. And then what we've got at the bottom is an iframe, which is going to display the output of the code that is being run. And then we're going to need some API functionality to create new code sandboxes every time the user clicks that Run My Code button. And our API code that we're going to write is going to call the Dino subhosting APIs in order to create new instances. So our users can see the effect of their code every time they make a change and they click Run. So let's have a look at building out that app. I hope you can all see that. So we're going to use React Router. We're going to create a single-page app. And this is our edit code component, which is going to present the text area. So hopefully you can see that down at the bottom here. We've got our text area, we've got our button, and then we've got a component called deployment viewer there, which is just the thing that's going to contain our iframe. So when the user clicks on the run button, it's going to deploy their changes. We'll call the backend API that we're going to write. And it's going to return us a URL that's going to be displayed in that iframe component. Each subhosted function that we create, so each time the user edits their code, it's going to get its own distinct URL. So we're going to be able to change what is displayed in that iframe every time they click on that run button. The only other thing of particular interest in our React app is this API client, which is responsible for doing all of our fetch requests. So there's a few functions in here. So the first one that we're going to look at, so this one loads our sample code. Then we have another function which is going to deploy our project, and it is responsible for both creating and updating the code sandbox. And then finally, we have this, which is going to wait for the deployment. So this is going to poll to see if our running function is ready. And we do this by getting the deployment API, by calling this getDeployment API here. But we've not built any of these APIs yet, so let's do that next. So when we deploy this application, we're going to need something to host it. At the moment, we've got Vite that is doing our hosting locally, but we need to make sure that Vite and our backend APIs play nicely together. So we're going to add a couple more tasks into our Day.2 that when we're doing our CI, will build the static assets required for our React app. So we're going to create a Dino server-side app that we can actually deploy to host our React app. So we have also a main TS file in our server folder, and we're going to add a task to startup that is going to start that up with our. We're going to add a task into our Dino.json that is going to start that main TS file. And then when we deploy, we're going to use our Dino server-side app to host the backend API that is going to be called by our React app. And our main TS file is going to look like this. So this is the entry point for our server-side backend API. This file uses a web framework called Oak, and you'll see here that we're importing Oak using the JSR package. So in this file, we're initializing Oak, and we're asking it to route the static files from client dist, which is going to be inside of Dino's current working directory. So you can see that here. And when we run this app, after we've compiled our React app, it's going to act as a web server and serve the React app. We've already set up our Vite config, which is going to proxy the requests from /API back to this server. And all of this configuration means that we can use Vite as our dev server locally, and any requests to /API will get directed to the routes that we make available in our Dino app. But in production, our Dino app is actually hosting our static assets and our APIs all together. So the server-side API has a bunch of functions that we're going to use to implement the features that we mentioned earlier. So we are going to get sample code, deploy project, and get deployment. You'll notice that each route is mapped using its verb, and it's got its own path, followed by a function which is going to handle those matching requests. And finally, you can see we've got a route static files from helper that is going to make our React assets get served correctly in production. So let's build out each of these functions now. A nice first example of how to use Oak is to build our get sample code. So all this handler does is it's going to load a file from the file system using Dino's file system APIs, and it's going to return the body as a JSON object. And here you can see how Oak works. You need to assign the response body on the context object provided as a function. So let's have a look at something more interesting now. Let's talk about what deploy project does. And this is what is going to do most of the work for creating our sub-hosting instances. So when this API is called, the first thing we're going to do is check if an ID has been passed as a parameter. If we find one, we're going to presume that we are updating a project that has already been created. So our user has already typed some code in. They've already created a project with an ID, and now they're updating it. If we don't get an ID, we are going to use the Dino API to create a new project for us. And once we've got a valid project ID, regardless of it being new or already existing, we're going to work out what content we need to update the project with. So if our API has received some code in the body, we will use that and presume that that is the code that they have typed into our editor. Otherwise, we're going to default to some sample code. So if they haven't typed anything in, we're just going to give them a little bit of sample code which is going to help them create a project from scratch. Once we've got our project ID and our code, we're going to create a new files map, which can contain as many files as we like. But in this example, we're just going to use the one file, which is our entry point, which is our main TS. And then we ask our client to deploy our project, passing it that file map. And finally, we return the project, the deployment, and the subsequent deployed URL data back to our web UI to actually update and load the iframe. And in order to keep our HTTP API handlers pretty simple, I've created this Dino subhosting client file. This is just an abridged screenshot of what this does, but what I want to show you here is that all this file is really doing is sending a request to Dino's subhosting APIs using fetch, which of course is built into Dino. And each of the functions on the subhosting client represents a Dino API call. So all we're doing here is we're validating the status codes, we're adding some nice TypeScript definitions to the subsequent response objects as we return them. So let's talk a little bit about subhosting and what it actually does. So subhosting is just a collection of APIs that allows you to create projects. Projects will be owned by your organization. So if you set up an account, you'll have an organization. Your organization can create projects. Your authentication credentials allow you to create as many projects as you like. So if you are offering serverless functions to your customers, you might want to do so on a project-by-project basis. Projects are kind of like an organizational unit within Deploy, and deployments share nothing between each other, even when they belong to the same project. And you can see so this is a screenshot of the API documentation. You can see some examples of what you can do with each endpoint here. So we've got list deployments, create deployments, get organization details, that kind of thing. So if you have multiple tenants or customers or users in your code sandboxing system, you'll be able to capture billing information per project because the analytics are reported at a project level. So you'll be able to bill each customer individually. And for the sake of this demo, each user's sandbox is going to be a separate project with each edit resulting in a new deployment, and each deployment has its own URL. In a real-world scenario, if you were building this, you would want to add in some functionality which was going to delete all the deployments as users make changes. But what you're going to really be doing here is a project per user kind of organizational pattern. And for those of you who are interested in the implementation details of subhosting, subhosting is quite an interesting and innovative approach to this idea of shared compute. Dino deployments are deployed into separate V8 isolates, and each one gets its own distinct sandbox instance of the V8 engine to run in. Each isolate has access to a virtualized file system and a fully sandboxed runtime, and each isolate has a separate state, and objects from one isolate can't be passed to another. So this is how we're doing that security. This is how we're keeping each user's details private. And on top of that, Dino subhosting uses two VPCs, one for routing incoming requests and another for isolates to access the internet. And this is how we ensure security of network traffic. So we've built our project. The next thing that we need to do is deploy it to somewhere so that our users can test it out. And Dino Deploy is an online tool which is very similar to any other GitOps CI-based tools that you've likely used before. You register your Git repo, and then you will choose which project you want to deploy, you can fill in a couple of options for how you want to build the thing, what you want to call it. The important thing is to make sure that we put our Dino task build task into, it's already gone, into the form option for the build task. and we deploy it, and it goes live. Awesome. So, fingers crossed, everybody pray to the demo gods. Here's one I built earlier. Let's see if we can get our demo up and live. Here we go. Stunning UI work, I just want to say. So here is our demo sandbox. So what I've done here, as I mentioned, if the user hasn't entered any code, we will give them this just little demo bit of code. If I click on Create Interactive Sandbox, we set them up with a text area where they can type in, and it's actually run the code for us. So I can now type in hello future frontend, and if we run it, hooray. Okay, so we can see we are running the code live. You can see the URL that is being returned. So this here is just an iframe with its own URL. But we can actually do some more interesting things here. So let me, where is my cursor? Did I lose my slides completely? Oh no, they're in that other tab, I see. Live demos, never the best idea. Okay, so yeah, so you can see what we're doing here is we're running our existing code using this thing called DinoServe, which is a nice lightweight HTTP server. And it all just sort of works out the box. But the cool thing about subhosting is that we can actually install packages. We have a package restore that just magically works when you're using JSR and Dino. So let's try a slightly more complicated HTTP server. So this time we're going to use Oak, and we're going to do some routing. And I'm not going to type this, I'm going to copy paste it, because I do not trust myself to get this correct. So what we've got here, we are importing Oak, and we're importing Oak's router. We are just going to send this little object here at the home route, but we could change this, we could add more routes in here. So now if we run this and we cross our fingers again, hooray! So we got our foo bar returned. And that's super cool. Like, we didn't have to install anything. That import was just done for us. It just works. As I said, you could potentially create other routes. I haven't set up this demo to be able to visit other routes. But if we open that URL and went to those other routes in the browser, we'd be able to see the output at that URL. And it's super cool. Let's jump back into my slides very briefly. So all of this code, this is all open source. I would love for you to take this and run with it to build your own cool things. It was an absolutely whirlwind introduction, I know, to Dino, to deploy, and to subhosting. If you do build something with this, I would love to see it. So you can get me on any of the socials at This Is Joe Frank. That QR code is a link to the slides, which also has all of my speaker notes in it, which has all of the links as well. So yeah, do take this, do make something cool with it. Thank you so much for listening. And we have some Dino and JSR stickers up here at the front. So do come grab a sticker when we are done. But yeah, thank you so much for listening.
Thank you, Joe. While our main organizer is setting up the Q&A for us, I have a question for you. Are you NPM or Yarn? NPM. Okay. Yarn? Oh, minority. I mean, I'm a consultant, so every time I go to a new project, it's you don't know what to expect. A few years ago, I went and okay, I'm starting a new project. I'm like, yes, I use Yarn. This is great. And then NPM. NPM. Oh, true. Sorry. I mean, in my world, there's only 2 options. Don't embarrass me more. I will not let you speak. Sorry. But anyways, I was super excited using Yarn, and then somebody comes, okay, why aren't you use NPM? I'm like, fine. In the future, I will use. Then I go to another project, and I'm like, okay, now I use NPM. Everybody's happy. And then there comes a designer, like, I suggest you use Yarn in the future. I'm like, okay, cannot win. So, but nobody asked me to use NPM. NPM.
I'm afraid.
Okay, sorry about that.
That's all right.
If you're using Dino, you don't have to use either. You can use Dino itself. Dino is a package manager too.
That's the real question we should have asked. Actually, I should have asked right at the beginning, how many of you before you entered this room had even heard of Dino or knew what Dino was? Oh, look at this. This is nice. Are you being truthful with me?
I'm sure they are. Okay. I'm just gonna go straight to the questions.
Sure. Yeah.
No nice chat at all, because there's a lot of questions and a lot of votes for this one. How can I be sure that the code I transpiled correctly on the JSR side? Large TS projects can have quite a complex build process.
Yeah, that's a great question. So there's a couple ways you can do this. In the docs, there's some configuration that you can use to transpile your TypeScript to JavaScript locally and like try out your code with that. Alternatively, if your code is written for Dino, for example, then you could just run the TypeScript and Dino will execute it. And we're actually currently working on a feature that will allow you to take a project that you would publish to JSR and sort of build the package tarball that we would use for NPM locally, so you can try out with that using NPM link or something like that in your local project. So we're still working on some things there, but there's ways to do it.
Yeah. And can you run a private JSR registry? Because often, I mean, that's kind of the case that you...
Yeah. So you can self-host JSR. JSR is completely open source. I actually forgot to link to that, but yeah, if you go to github.com/jsr-io, everything's open source there. The backend, the front end, the JSR CLI that you saw me use earlier. So you can self-host it and run it internally in your team. There's still some work to be done to allow sort of pass-through registries where you can have a private registry that can fall through to the public registry if you don't have a package on your private registry. But well, that's something we'll work on. JSR is still pretty new, so still things to innovate on. But yeah.
Yeah, there's a lot of questions related to this JSR. I think we're all happy seeing.
I'm more than happy for people to ask JSR questions. I would love to see more people using JSR.
Yeah, but actually there was, let's go a little bit to Dino side as well.
I mean, to be fair, Luca is also Dino and probably will be able to answer questions better than I can, having been Dino for a long time.
Nice. So how long do the Dino subhosting sites stay alive, and are they just temporary?
No, they are not temporary. They will stay live infinitely.
Until you delete them. Yep.
Yeah. When Dino is pulling packages from JSR, how does it manage different TS configs of each package, which may have conflicting compiler options like decorators?
Yeah, so that's actually a very simple answer. There's only a single TS config file you can use to publish to JSR. And the reason we do this is because, so first of all, emitting TypeScript to JavaScript is actually a very standardized procedure at this point. Like, there's only like 2 options that can impact that, which is legacy decorators and whether you want to emit const enums or not, which both of those we don't do, and instead you can use either standard decorators or non-const enums. Yeah, so when you publish, well, I don't know, you probably didn't see it during my, I mean, maybe you saw it roll by during the publishing step, but we actually check your TypeScript source code during publishing to make sure that you're not using any of those options. But yeah, we're doing this to sort of like make sure everybody's using the same configuration.
And how well JSR packages work in NPM ecosystem? Does Dependabot and Renovate handle bumping JSR packages?
So if you're using a tool that can handle private registries, because in reality, JSR behaves like an NPM private registry. If your tool supports that, it'll work with JSR too. So as long as you support private registries, it'll work with JSR. So you can even pull packages from JSR into things like Azure Artifact Registry or JFrog Artifactory or something like that. If you have a private registry for NPM, you can just add a backend for JSR in that and pull them directly into those tools.
Nice. OK, so we don't come to a clean table. So what would you say, is it like worth switching to Dino in a bigger projects or migrating?
I mean, I think if you're using TypeScript, it absolutely is worth swapping over. We will be releasing, our next major release is going to be full node compat. So that'll make your swapping over even easier.
That's nice and easy. I say, yes, you should, always, always.
So the answer is like, Dino has all of these built-in tools, right? Like, there's a lot of, if you switch over to Dino, there's a lot of configuration that you can probably remove. Like, if you have a complex TypeScript compiler pipeline or something like that, Dino has TypeScript built in. Dino has a very fast JavaScript transpiler built in too. So like, if you're using ESBuild or TSC, both of those get subsumed by Dino. If you're using ESLint, that gets subsumed by Dino. Dino has a linting tool built in. If you're using Prettier, that gets subsumed by Dino. Dino has a formatter built in. If you're using a testing library like vtest or Jest or anything like that, Dino has a built-in testing library, gets subsumed, right? Like, all of these things are just built into Dino. So if you're switching an existing project over to Dino, probably there'll be some code some small amounts of code that you have to rewrite. We have a lot of compatibility, but there's always edge cases, right? But the majority of things that you can do is like delete on dependencies and just use built-in tooling, which is really nice because like we have a VS Code extension that has all these things built in too. So like if you're using the Dino VS Code extension, you'll get like formatting in your editor automatically, and like you get a nice panel on the left-hand side for testing that shows you all of the tests you have in your project, and you can like click on one to run it, and it shows you the output directly in the editor. And yeah, I don't know, it's kind of nice.
I think there was you had a really nice sort of visual representation of that when you did your Dino demo, and then your node demo, which just fills the entire left-hand column with bump, which you just don't need.
Yeah.
Okay, but is there a case when you wouldn't use Dino?
Sure. Like if you're, I don't know, if like you don't have to. If you prefer having a lot of dependencies, or I don't know.
You really hate dinosaurs?
You really hate dinosaurs. No, like obviously there's. Dino, we try to be very compatible with Node. There's some things that you cannot do yet. Like if you go into like real deep dark of Node's VM module, probably you can't use Dino. If you like, I don't know. It's very few things. Like Dino supports a very wide array of Node compatibility. Like even things like Node's native add-ons are supported in Dino. So yeah, try it out. If it doesn't work, open an issue and we'll fix it.
Yeah, let us know.
Okay, back to JSR. What entity controls / hosts the JSR registry? Is it commercial, or if not, how is hosting funded?
Yeah, so JSR is hosted on Google Cloud. It's funded. We are like the people that pay the bills is Dino, but we have intentionally architected JSR to be like very cheap to operate for us. And the reason for this is because we don't really see, and like Dino there's no monetization in JSR. Like this is not something we intend to like charge for. Like it's not just we don't intend to charge for it, we will not charge for it. And the reason for that is because like it needs to be as easy to use as NPM, and NPM does not charge to publish public packages, right? And like I think one of the big problems with the NPM is its funding model. Its funding model is GitHub. GitHub pays for it, and if GitHub has no incentive to improve anything, or sorry, GitHub, it's not open source, so there's nobody that can like host NPM itself. GitHub has no incentive to improve anything. You can't pay GitHub to improve anything either. Whereas JSR is open source, you can send PRs. It's sort of like a community project. You can open issues in our issue tracker. You can look through the source code. And I'm sure at some point we'll get to the point where where other companies will also chip in, like other large companies will chip in if they start using JSR. But yeah, there's no like monetization story behind JSR. It's like an open project that we're really like, yeah, it's just like a for good project, I guess. Dino makes its money elsewhere. Dino makes its money through like deploy and sub-hosting and these kinds of things. We don't see JSR as a like monetization strategy.
Yeah. It's part of Ryan's goal to make the JavaScript developer experience more pleasant. Like it does feel a little bit like it's kind of stagnated, and he's desperately trying to sort of pull it into a modern era.
Okay, what are the most popular packages in JSR at the moment? And what big libraries are planning moving there? React?
Yes, so probably the biggest packages on JSR is the Dino standard library. It has a lot of packages. It's very widely used throughout the Dino ecosystem. But yeah, I showed some of the packages earlier from people like LaunchDarkly or the Hono, for example, is published to JSR. And yeah, I don't want to commit anybody else to publishing to JSR because that just seems very rude. But like we've been in talks with many people and helping them to publish to JSR. Like there's a lot of other SaaS companies that we're working with to get their packages published to JSR. So you can expect a lot more of that. One of the Preact maintainers works at Dino, and once JSR is sort of ready for it, may also consider publishing Preact to JSR. And so like there's definitely like the problem with the registry is that like nobody is going to publish everything on the first day, right? That's just not how things work. So this sort of evolves slowly. JSR has only been around since March, maybe?
Yeah,
March.
yeah.
So like very recent. So yeah, I don't know. You can go to the website. There's actually like a list of, on the left-hand side of like highlighted packages. And you can like click through there. Maybe there's some you know in there.
And we are slowly seeing the number of packages. It's moving up and to the right.
Yeah, absolutely.
So we have high hopes for the future.
Yeah.
Nice. Okay, this like I don't know how if anyone else struggles with documentation. I feel like it's very painful and gets old really fast. Mm-hmm. But how do you measure the quality of a documentation in JSR?
Yeah.
Is this sorry, I'm gonna just finish. Is the score based on just the raw amount of documentation, or do you use other metrics as well?
No, so the score is based purely on on the amount of documentation you have. Like, or rather, it's not even the amount. It's like whether a certain symbol has documentation or not, and then the percentage of exported symbols that do have documentation. So it's possible to game the system. Like, absolutely, you can add a comment that just has a little X in it on all of your symbols, and you can do that. But that's sort of like, I don't know, why would you do that? Nobody's going to download your package if you do this, so don't do it. Okay,
back to you, Joe. Oh, Oh, it got lost, sorry. I just had a question, sorry.
Right.
Oh, does Dino support Node APS like FS, or does it have its own FS implementation?
So Dino does have its own FS implementation. Yeah.
But it also supports, like you can import Node.fs or, yeah, like any NPM package that uses Node's FS library will just work. And you could just like import Node:/fs as well.
Okay. Yeah, and how does Dino hosting support scaling? Is it easily configurable to speaker machines?
Yeah, it's a serverless environment, so it'll just scale up with usage. So if you send it 1,000 requests, it will scale up to handle 1,000 requests. And if you send it 1,000,000 requests, it'll scale up to handle 1,000,000 requests.
Okay. I think we're gonna finish up soon because I think people want a little break and there's gonna be coffees
And
as
they
well.
have to come get the stickers.
But one more, can you publish from private GitHub repos?
I don't know. Try it out. Maybe?
Send a feedback if you can.
Yeah, I don't remember. You have to try it out and see. Yeah, no idea.
Okay. Well, thank you so much. I'm sure we're gonna all jump to JSR after this session. Thank you, Joe and Luca. Let's give it up for them one more time.
Thank you.
Thank you.
Everybody,
Grab
get stickers.
Okay, before you run, remember to take the stickers. I think we're gonna keep them there. We're gonna have now a half-an-hour break, right, Juho? Yes. And then we're gonna have a second session. It's gonna be about green computing. That's it. Enjoy your break.
Testing. Joo.
Hello, hello, hello. Welcome back from the break. Next theme session is about green computing. Very interesting topic. Our first presenter is Jari Porras. He's a professor. It's such a hard word to pronounce. Anyways, and TV's selection for IT Influencer 2023, even though he will not mention that because he's a very Finnish man. But I'll give the stage for you, Jari, and welcome him.
Thank you, Tuuli. And believe me if I say that pronunciating this professor is much easier than acting as a professor as such. It requires so many things as such. So let me say a few words about myself. My name is Jari Porras. I'm a professor at the LUT University. The slides here are using the LUT or LUT University's slide deck as such, but I'm also having a position in the Aalto University and in the University of Huddersfield in the UK as a visiting professor, mainly because of these kind of green and sustainable computing topics as such. But let me start with the few things of my past. I'm not a software engineer as such. Although I have been enjoying a lot of these talks over here concerning all the technical things and so on, but I will challenge you a bit later on those things. The important part over here is kind of what I want to show is my research path and interests that have kind of changed during the years. When I was doing my PhD studies and a bit after that, I was basically working on parallel computing, parallel and distributed computing. And in parallel computing, the goal is to make things run as fast as possible. So taking a second away of certain things while using 100 processors and how to do that kind of a thing was the key thing. And that kind of resembles of today, what I'm talking of, this kind of green coding or sustainable software and so on. So in green coding or energy efficient coding, the same thing. We want to make something as small as possible. It's not now time. It's now considering how we can really reduce the energy. Okay, I might not have the answers for you to that because that particular topic, green coding, is just about to emerge, and then there is some research, and I will be. My topic is more about the academic perception and some experiences concerning that. And our next speaker, Ben, will then give you some hands-on experience how to calculate things. I'm mainly talking now what has been there and how we see as academics this particular field and so on. Two other things here in my background I want to say is that the Finland was 2021 the Finnish Ministry of Transportation and Communications published the first ever strategy for ICT sector. It was a climate and environmental strategy of the ICT sector with the idea of considering the climate impacts of our sector to the climate. And it started to work 2019, around the time when the COVID started, and then we were working remotely, and the actual strategy was published 3 years back, around 3 years back now, and there has happened a lot of things after that, and I believe that now it's time to look at the next kind of get a summary what has happened in this field and maybe update the strategy as such. I was one of the university representatives in that particular working group. The other thing that I want to mention is that there is this kind of Sustainability Design Alliance or working group in which I'm together with some international researchers. If you are looking at any scientific papers on this topic, most of those people are in this particular alliance. And if thinking of software engineering, we kind of have this what it is called. It's Karlskrona Manifesto for Sustainable Software that has similar kind of rules like Agile Manifesto has for agile software development, but for energy efficient coding as such. And then the third thing is that currently I'm running a European Erasmus Mundus Master's Program, SE4GD, that stands for Software Engineers for Green Deal. Green Deal itself is a European act for trying to make things better or considering the climate as such. So, on my talk, sorry this is a bit of academic as such, showing the agenda and so on, but I will be starting with motivating why we are doing this kind of things. Then I'm having two things that I want to present as kind of, it's not hands-on, but it's kind of an experiment what I wanted to do, going a bit to some uncomfortability zone as such, looking at the green coding, what has been done in that field, and then also some academic experience that we were doing on that thing, and then some final thoughts for you. So, my question, yesterday when I was listening to the other presentations, I already had my presentation ready, but then I decided that, hey, I need to change this a bit, maybe asking some questions. Why are we doing these kind of things, or why we all should be doing all these things? And I have three reasons. Okay, the first one is, of course, this is the only thing that we have. We don't have planet B at the moment. We need to take care of this. Oh, it doesn't show the picture well. It says Blue Marble, and this is the first ever picture taken from planet Earth, 1972, by one of the Apollo flights. And this is the only thing that we really have. We need to take care of this thing, and I believe at the moment that we are not taking care of it. This is the second thing. 2013, LUT decided to be the first university in Finland to take the sustainable development as the goal of all our actions in education, in all the research. And I have to say that I really didn't know what we are up to. All those things what they were saying in the strategy were complete strange things for me. They were talking about waste and water and so on, and that didn't resemble at all to me. And then I started looking that, hey, what can we software engineers or IT people really do on this topic? How can we contribute? And the third one, this is more this day, and this goes to all the companies basically, is that some years back I was thinking that if there would be a similar kind of a regulation like we had the privacy regulation, GDPR, some years ago, that there is a huge fines if you are not doing this and that. And I was thinking that if we would get a similar kind of a thing for sustainability or for these climate things, that would be good. And now we do have that. We have the CSRD, Corporate Sustainability Reporting Directive, that basically asks all the companies to report their carbon emissions. Okay, it doesn't give any or say that there is any penalties because we don't have any baseline where you need to be. But still, every company needs to report all their carbon emissions. And now you are thinking that, hey, this doesn't really consider the software companies. Yes, it does. If you fit into those categories that will be there this year, the biggest companies need to already report all the carbon emissions. And that does not only contain the scope 1 and scope 2, basically the facilities and the energy used, but also scope 3, which means that all the services what we are using and all the services what we are providing. So we need to be able to calculate somehow what are the CO2 emissions. I have to say that I have been really pleased that quite many companies have actually been doing this for a long time. I took here a couple of examples. Nokia has a separate tab in their web pages that says sustainability. And if you go there and then look what's under that, you find out that there is some sustainability report or ESG report. And soon you will be seeing those CSRD reports over there. Elisa has similar kind of a sustainability. Then I also took Digia. Digia is the sponsor of this event, so I also took that. They have a little bit different word, and unfortunately this is Finnish. It basically is responsibility. There are different names for this sustainability. Some are calling that responsibility, some are calling that sustainability as such. But my question here is that who of you has considered sustainability while you have been developing software? Few hands up. That is really good. And I would say that that's a good start. Let me just open up a few words before I go to the actual things that I have to say. You probably have heard of these terms: sustainable development, sustainability, green. Okay, this particular session is supposed to be green coding, green computing. Okay, there is computing, coding, software, etc. But if you are adding those sustainable things there, the sustainable development was defined by this so-called Brundtland report, 1987. That was a UN working group that was looking at how are we going to evolve. Imagine 1987, when we were already thinking of that what needs to be done. And of course, in that particular definition, it's saying that we have certain things what we are doing these days. What is happening? Now there is some interference somewhere. Hopefully you can hear me. Basically, in sustainable development, the idea is that we have certain resources now. We are using those, and we should take the future generations into considerations. Okay, that was pretty general, but they defined in that particular place those three different dimensions: ecological, economic, and social dimensions as such. I will say a few words in the next slide before getting to the actual stuff. Sustainability itself is a kind of a general term. You can use that for basically anything. Sustainability itself is kind of ability to or capability of endure, keeping on a certain level. It can be if thinking of the economic ways, or let's think about this conference. Sustainability of this conference could mean that we can have this year after year after year. And providing some inputs that way. So basically that's very general. And then when we are talking of green, we are usually looking at the term that is referring into this resource usage, something that is efficient, energy efficient, resource efficient, workforce efficient. Basically you can also use green over there, but in our kind of a talk, when we are referring to green something, green software, green coding, we are meaning that we are trying to make it energy efficient. Very quickly, this 5 dimensions of sustainability. Okay, the 3 first ones, the ecological, economic, and social, they were defined in that Brundtland's report as such, and those are usually referred when we are talking of sustainability. The Karlskrona group or the Sustainability Design Alliance group, we have been using actually 5 different dimensions. 4th dimension is individual or human. Sustainability meaning that if social is more or less kind of social as a whole, what is the impact? Then with the individual we can think that what is the impact for an individual as such, as a worker in a company, as a citizen of the country as such. And then something that is and should be interesting in this particular event is that we are also thinking of this kind of a technical sustainability, that whenever we are doing some software or any kind of a system or service, how are we maintaining that? How sustainable we can have that? And we can think that, and that is definitely linked with if thinking of the energy usage, we can link that to the ecological or environmental dimension as such. All right, let's start looking at the IT sector. I'm starting from the IT sector and going into the software sector later on. So we have aviation versus IT. What's in common in these two? What? Connecting, yes. I'm not looking for that. I'm looking for some sustainability thing. Pardon me? High energy use and yes, this is already in the Green Deal. Basically, the emissions of these both fields are approximately the same. And the IT sector is growing like hell. Even though that the energy efficiencies of different networks are coming down. For example, Google said already years back that now they are carbon neutral. And still the energy usage has increased past 5 years like 200%. So even though that you say that you are carbon neutral doesn't mean that you are using less energy. You are just using it different ways. And because we are consuming much more. Quite many of you, how many of you have been kind of blamed that, hey, you are flying here? Quite many of you actually flew here, but been said that you should not be flying. Quite many, I guess. How many of you have been blamed that you should not look Netflix? Okay, I know that some of you have. Maybe if I would be a teenager, the teenager's mother would probably blame that don't look so much Netflix. But if thinking of these two sectors, they are the same. We have the same impact to the climate as the aviation sector. This is one of my favorite quotes that I want to give, and that kind of starts my talk of the software part or the IT part is that like the performance, reliability and security, sustainability does not just happen. We need to plan. We need to be able to aware and we need to take that into account whatever we are doing. It was nice to listen those presentations on the previous days here. One example comes to my mind is this ChatGPT clock. And thinking of the energy usage of that, if generating, you know that the ChatGPT, whenever you are using AI, you are really using a lot of energy. And think about scaling that with thousands of those clocks around the world. Okay, now I don't know how the clock is working and what is behind there. But the idea is that you are really increasing a lot of energy usage by using that. Then there was other question that, actually quite many tools that are presented here that, hey, this is nice to the developers. Now it's easy to do this one, and now this is already synced to another machine. I start thinking that, okay, how much energy does that make that you are syncing? One single packet over there doesn't necessarily take too much, but when you are scaling that up with several millions of people, then of course the energy usage is increasing. So whatever we do, we should always also think about not only the end users, not only the developers, but behind there we should think how and where are we using the energy for. This is one. It still doesn't show the bottom line of that slide, but the idea here is that actually if thinking of these services what we are using, we normally see only this end, the end user end, the device what you are using the service for. And quite many talks here already said that, hey, we are moving things to the cloud, so we are really energy efficient as such. But you have to remember that there is the end device. You can use the mobiles, the desktops, whatever devices you have. You have the network in between, and then you have the computing somewhere. And just remember that the cloud is just somebody else's computer that is running your computations. And if thinking of these things, when we are thinking of the energy usage, we should be thinking all of these parts. And Ben will have an example of that later on in his talk. Okay, in Finland, I just have a couple of slides of this climate strategy that was published 2021. There was a vision that in this Finnish ministry that Finland wants to be a leader in the use and development of this ecologically sustainable ICT solutions. And then, of course, getting the awareness and the knowledge and then start doing things like that. I could say a few words about, and then probably if there is any questions later on, I can say what happened after this. What happened after this strategy was published 3 years ago. I don't be going into that, but just showing you that they actually in this strategy, there were 6 sectors that were defined, what and where ICT can help in saving energy, or where should we look at. ICT infrastructures is one, and I have to say that after this strategy was published, there has been a lot of things happening. For example, the use of the heat provided from data centers, how to use that in the benefit of the local residence areas, etc. So that has taken a lot of big steps as such. But then there is the second part, the climate and environmental friendliness of the data economy, and this basically behind that word data economy is basically software and services. First looking at considering the software and service design and development, how much energy we are using for that. There is a special attention to the energy aspects in software and service procurement. You have to admit that if there is some procurement process and the customer will ask that, hey, you need to fill this and that kind of energy efficiency, then you would probably need to answer to that. If it's not there, then you are not answering to that particular question. So that is one, and then there is the environmental benefits and of these particular ICT solutions as such. And then there was 4 other parts that I won't be going. Now I start looking at the software part and the academic perception into this, and although I think you have started hearing this talk about green IT, green software, or sustainable software for the last few years, it has been around for years. One of the first articles that I found related to this IT sector and energy usage was already from 2002. Actually, there is even older articles, but still 2002, Lawrence Hilty was publishing this kind of a sustainable development and information technology and environmental impact assessment. That's one of the first papers that start talking about these things. And so I decided to do a literature review that, hey, what has been done in the area of green coding, green programming? What can I find from there? Okay, yesterday we had a nice talk of this tool, AI tool, Elicit, that should make things easier, because when I was doing my literature review, I just went one database and found 1,870 articles, and then went through all of those to see what's there. Okay, quite many of those were not really related, because if you have a search query that has green programming and coding, you get a lot of stuff. But actually, I also tried the Elicit tool. AI tool yesterday evening, and I got this kind of a summary of the 8 most important papers, and just noticed here that these papers are all from 2009, 2010. I did some experiments that this is exactly the same search query that I put into the database and to the elicit to find out things, and basically it found this. Okay, I still don't know how to use it. I tried it for a couple of hours, tried different kinds of search queries, tried to find my own papers. Didn't find, well, actually find a couple of those, but was looking at how to best use that particular tool to make these things. Because if you are doing these academic literature reviews, those are really require a lot of work. Just like I said, I found 1,870 articles in the Web of Science database that basically combines articles from different locations. And I selected, based on the title, 78, and then I read the abstract, and 58 was in my final set of papers, and I started doing some categorization that, hey, what kind of things in green coding they have been really focusing on. And here is a couple of examples of those articles, like challenges in development of green and sustainable software for software multi-sourcing vendors. These are a couple of these kind of things. There is software lifecycle things. I tried to select the newer papers from 2000. Okay, 2016 is rather old, but actually 2018 is kind of continuation of that particular work. And then there is a couple of others. There has been a lot of work, for example, ranking programming languages by energy efficiency. And when I actually did this categorization of those things, if thinking of the whole set of papers, I looked at this devices, network, and cloud, or under the cloud there was edge and then fog, always kind of the backend kind of stuff. I had a bunch of papers over here, but then there was what I was really interested in, that how are the papers looking at software engineering as a process, kind of the organizational level as well as the software, what kind of things you can find from there. There are some keywords over here. I have a couple of slides that are opening up a bit of those things, but I just want to emphasize here, this is not in any of those slides, but in one of the papers there was this kind of a table that was saying that my applications have requirements about energy usage. I was asking you in the beginning that how many of you have been, okay, I asked about sustainability, but I actually meant energy efficiency. And if looking at the requirements, mobile environment, surprise, surprise, is really a focus there, because mobile environments are usually pretty restricted environments where you need to do your work and you need to kind of consider that. Whereas if you go, actually I'm surprised that the embedded is rather low here, and data center is the lowest one of these. But 3 slides of the actual results. The first level is on organizational level, and I have a couple of, actually the same author has been writing these papers. The first one was 2016 paper, was looking at developing those green and sustainable software and what kind of success factors there are for the vendors. And there is a table of the success factors that is given here. And they listed those that for example, green software design and efficient coding is one, etc., and so on. But they did another survey or another paper that actually has a literature-based part looking for challenges. That's the topmost figure. And then the middle figure is they made also a survey for more than 100 companies of how they see the challenges of the green and sustainable software development. And they basically used the elements that they found from the literature to ask that how important do the companies see these particular things on that. This only shows that why companies doesn't necessarily yet do these things as such, but I won't be going into those results so much. The other area of papers was on kind of software engineering on these processes. There is this George's paper of software development lifecycle for energy efficiency that actually is also a systematic literature review, and it shows the upper picture. They have categorized a lot of things, tools, etc., that can be used for energy efficient coding as such. So if you want to read one paper, this is a good paper for that particular thing. And then the other paper, Sustainability in Agile Software Development, that is also the process. And this particular team was having some practitioners and seeing that which one of the places in a Scrum Agile approach, the sustainability or the green or energy efficiency should be taken into account. And those green bullets are the ones that were possible by the companies to consider the energy efficiency. Out of these, they emphasized actually that the interface between the product owner and the stakeholders is really important. The product backlog is important because if you can then prioritize those things that save energy is one, and then I think the sprint backlog was one thing that they were emphasizing. And then when going into the coding level, there was several categories in my data, but I selected a couple of papers. This as an examples. The first paper is on the impact of code smells on the energy consumption of mobile applications. Okay, once again, pretty kind of narrow environment. You are talking about mobile applications, but they were looking at different code smells on a set of Android projects and finding out that which one of those code smells really affect to which kind of methods or functions what they have over there as such. The picture is just nice, but doesn't really have a content. The other one, the Pereira's paper of ranking programming languages on energy efficiency. You can see the bottom level here. This has been done by quite many groups, these kind of things that they have been looking at how much energy different programming languages on the same topic are using, how much time, which one of those are time consuming and which are not, and then how much space do they need. Okay, once again, different developers and different companies like different kinds of environments, and then somebody was saying that there is every week a new JavaScript approach. So really don't know too much about that, but I just know that somebody has been doing this kind of energy efficiency calculations, that which one of the codes are best. So basically outcome of this first part is that if you want to do the green coding or energy efficient coding, it's a commitment. You need time for that, and I guess that also it's not only a commitment from the developer, but it also needs a commitment from the top layers. Methods and processes are still developing, thinking of customization, etc. here, and then metrics and measurements are needed, and then none of these papers really focused on any tools. Tools are missing. They're probably not completely missing, and as such, we actually made another experiment. We wanted to create a green coding course for our university, and we had this impact exchange project together with some Malaysian friends, and we actually had a hackathon to create this kind of a course. And then we tested that for a 2-day hackathon, that what we got out. So basically, students were asked to, first of all, there is this kind of a challenge level. First and the last bullet over here is focusing on that. We can select any SDG or sustainability challenge, what we want to look at. And then the middle 3 ones are mostly the implementation, the solution for the challenge, and what can we do over there. And the students basically selected different front-end, back-end technologies. We required that, hey, there needs to be mobile web and cloud deployment of those things, so that we can figure out that, hey, how can we is there any green development tools that help us to do these things, and how would they, after doing these things, how would they measure, and how good are those measures or metrics that they can use from those tools. And once again, a nice picture over here of different kind of tools. Sorry, I don't have the. If you go to codecamp.fi, that's our hackathon platform or wiki. Over there, the Impact Exchange, under the Impact Exchange hack, you can find all the material what the students did, and they basically evaluated. They did in the hackathon. They've made a solution by using the technologies that they selected, and then they tested some of these tools that they found for how to measure the benefits of doing things over there. And there are different levels over here. For example, on a design level, there is certain things. On a coding level, there are certain tools. Measuring, there is certain measuring tools. Ben will be describing you one. Analysis tools, and mostly these analysis tools are like the Aalto Green Page Analyzer and Beacon, etc. They are kind of looking for the websites and so on. And then of course there are also some dashboards that provide you some information of what you have been doing. But if I wrap up this part, is that there are many tools. And if I'm thinking of the software as such, there is 2 things into which you use energy. One is computing or doing your calculations. The other one is transferring data. The transferring data is pretty easy to capture, whereas measuring the computation is much more difficult. And there has been some attempts to create measuring frameworks, hardware, software types of approaches. There is a couple of papers given here. Some are already more than 10 years old, showing some approaches. And the last figure over there is of our Midvidi metrics for the green digitalization project together with the Turku University. And this is the measuring environment Turku, where they aim to measure both front-end and back-end energy consumptions. But there is not a general tool as such to do those things. Some final thoughts from me. The software, first of all, we need to take our responsibility. We need to think about that. There is a lot of research done on how to consider energy efficiency or sustainability in requirements. I didn't want to bring it here. There is that kind of a literature. I wanted to focus mostly on the green coding part. I would say that these metrics and measurements still need to be developed, and more and more I have seen this thing. I'm happy if the company who is doing a product can guarantee that the next version of the product doesn't use any more energy than the previous one. Of course, you need to be able to measure that thing, but you should be able to do things always a bit better than the previous way, not always so that the size of the program is increasing. There is actually a lot of research concerning the term sufficiency. What is sufficient in sense of computing and UI, etc. And I would say that the energy efficiency or sustainability, if thinking on a larger perspective, should be considered as any kind of any quality attribute. And just want to bring here 3 articles or papers or books that I can recommend reading. First one is by my good colleagues Patricia Lago and Birgit Bensenslatter, is this kind of a paper that framing sustainability as a property of software quality. The second one is the Janne's. Janne was a speaker here last year talking about the green coding and Janne's book on green code. Janne is already also here today. This is a really nice, I would say, higher level thing, but really gives some kind of a patterns and approaches how you can improve the energy efficiency as such. And then there is a book. This is already a couple of years back, but there is software sustainability that gives a wider perspective of software sustainability as such. I really recommend looking for all these things. And for example, the Green Code book can be found for free from Exo web pages. Final thing, this is what I have been discussing with companies a lot, that I have been giving some guidelines as such, and I just wanted to take these, even though that these are not exactly to the green coding. First of all, company needs to have values. You need to really appreciate that this is the sustainability. This is the energy efficiency what we want to achieve. The second one is you need to talk through to different people what does it mean. So that it doesn't happen like me when the LUT was announcing the new strategy. I had no idea what those things mean. It took me 2 years to go through that hey, this is what it means to me and this is how I can contribute. Okay, awareness, understanding and interest. It doesn't have to start from the management. Senior developers who have good ideas, you know what is the good ways of doing things. I don't think this is a rocket science. Anyway, if you are doing a quality code, that should also be energy efficient as such. And then finally is developing those processes that somehow take the sustainability and energy efficiency into account. That's it. If it's there, if you really make that as a requirement, then you start looking at it. All right, now I went pretty long, but I was saying that I have a South Karelian wife, so I don't get to talk too much back at home because she's talking all the time. So I usually use all my possibilities of talking when there is somebody to listening to me. Thank you.
Thank you, Jari. You will have more opportunities to talk when we have the Q&A after the next talk. Remember to post your questions to Slido, sli.do, FF 2024, just as a reminder. Our next speaker is going to continue on a subject. He describes himself as a president of whiteboards. I have no idea what that means, but I hope he will tell us. He's also a senior developer at Astro. Right, so let's give it up for Ben Holmes.
All right, and it looks like y'all can hear me, or it sounds like y'all can hear me. Hello, everyone. It's good to see y'all in Finland, and the talk that I'm giving is going to be a continuation on some of the ideas that Jari was already talking about in green computing, talking hurricanes, hammers, and HTML, or in practical terms, actually measuring the carbon emissions of the websites that we build. Now, to introduce myself a little bit, I'm Ben. That's my face, but bigger. And I'm a senior developer over at Astro, which is a web framework for building content-driven websites. So if you build homepages, blogs, docs, that's the kind of thing we specialize in. So it's definitely something I'd recommend. I'm also a content creator, which he was mentioning, president of Whiteboards, because I do a lot of whiteboard explainers over on YouTube and Twitter and other places. And that is my handle if anyone wants to follow me after the talk. And crucially, I'm an American. I was told coming over here that y'all are very rambunctious and try to crowd the stage with questions. So I ask that you calm down, save the questions till the end, and then we'll get to them. OK, it looks like we're good. All right. So the key takeaways that I want y'all to walk away with. First off, we're going to talk about the 3 main energy consumers if you break down usage of a website. And we'll talk about the standard page weight model that gets represented a lot when you use carbon emission tools. Also, like bytes transferred, data transferred. You may have heard that term before. And we'll actually talk about the flaws in this model, since it's a very early area of research, and there's a lot of gaps and assumptions that go into actually figuring out energy usage. And we'll try to improve on this by modeling out energy usage across data centers and user devices a little bit more effectively with the code that we write. And all of this is an invitation for y'all to explore this area of research. If you see holes to poke in any of our presentations, that's probably expected, because it's a very young area of research. It's called future frontend for a reason. This is very forward-looking. So we'll leave y'all with resources and hope that you expand on those with the things that you build. So the motivation for me in doing this talk, since I am no climate expert, at least starting this talk, was this website that's made the rounds called the website Carbon Calculator. You may have seen this before, but I can show you right here. This is, oh, shoot. Let me join this network right here and see if we can get that pulled up. 1 second. All right. There we are. The, oh, is that not going to show my display? Interesting. All right. That might be an issue. I thought it was going to share everything. Which desktop is that showing? Sorry about this, y'all. We only tested the PowerPoint, and we didn't actually look at the code demo. Always unit test everything. All right. Let's look at displays. And we'll see right here we have a built-in display. And, oh, interesting. OK. So we have VP. And we have that. Can I change the main display? I cannot do that. All right. If we change this over here. Sorry about this. Does anyone have a good joke? Are any Finnish people good at jokes? Any hands raised? OK, not yet. I'll keep going then. Preset. I'll choose Apple Display. That does not
I can tell a joke if you want me to kill time.
All right, go for it.
So this is an old joke from Soviet Russia. A man goes to buy a Lada. It's the Russian card they used to make. It's about year 1985. So he goes to the Lada dealership and goes, "I would like to buy a Lada. I've been saving this for a long time." And they go, "Yes. Let's see. We can deliver this on Wednesday, 2nd of February in 1995." And I goes, 10 years? It takes me 10 years to get a Lada? Goes, yeah, that's the way it is in Soviet Russia. And guy goes, "OK, but is it going to be the morning or the afternoon?" And the dealer goes, "What does it matter?" "Well, I have the washing machine repairman coming in the afternoon, so I'll be busy that day."
Nice. Nice. That is probably going to be the highlight of my talk, actually. That's the best joke you're going to hear all night. And we got it working. There we go. OK, so this is what I was trying to show you all a little bit earlier. This is the Web Carbon Calculator. And it's a very simple tool. It just takes in whatever page URL you might want to visit. And if you hit Calculate, it just goes off. It tells you a fun fact. And then eventually, it just kind of loads results based on the website that you're visiting. Looks like it disconnected me from Wi-Fi while we were doing that. Cool. One moment. Let's see if we can get that again. Refresh. And if we calculate, that should go off to the cloud, compute a little bit of information. And then as soon as that comes through, it gives you a rating based on whatever website you pop in. And apparently, my personal site gets a rating of B. I guess that's B for Ben, which is the best score that you can get. And you see it's 73% of all web pages globally, cleaner than those. This is an approximate usage of CO2 to display that web page once in someone's browser. And it appears to be running on sustainable energy because it detected what host that I was using. And it gives you all sorts of fun facts to put this into concrete terms, like saying it's equivalent to 4,000 cups of tea, all sorts of fun facts that you can bring to product managers to improve the performance of a website. It's meant to spark a conversation. But if you're like me, you might be a little bit skeptical reading this. Like, I just put in a URL, you know nothing about my infrastructure or my servers, and you gave me the exact energy usage. That seems like there's a lot of approximations or other things. I'm curious how that works. It's also something that we use at Astro ourselves. This is our Starlight documentation site, which is a tool for building documentation. And one thing that we tout on our landing page is actually the green usage. We say they are eco-friendly docs, because when you compare energy usage using that tool I displayed and compare it against other popular code-based, markdown-based frameworks, it seems like we're at the top, because we just ship plain HTML. We don't ship any scripting or other resources unless you opt into those. So if you just use the base case, type in your information, then you'll notice a very low energy usage. And on paper, that sounds great. Less compute means less energy. But what goes into actually getting those numbers? And how accurate are those numbers really? Well, let's dig into that a little bit. Tracing down what the carbon calculator is, it's created from the Sustainable Web Design model. And this is created by the Green Web Foundation, which is a nonprofit that builds open source tooling and research and blog posts, all sorts of things detailing the space of green computing. And they break down energy usage into three main metrics. These are the three that I alluded to. User devices, which accounts for about 54% of energy usage globally. Pretty significant figure, since there are just so many devices in the world. And the rest is accounted for by the infrastructure. The networks that are shipping your code around the internet, and the data centers that are running your compute and managing your databases. And if we split these apart, we can actually break down the energy usage of each of those. And before that, I should at least do some ground setting. Of course, data centers, that's where your app's going to live. We're talking about cloud services whenever we say that, AWS, Google Cloud Platform. Or if you're hosting on a CDN, you might also consider the usage of Cloudflare and other proxies that you have set up. Depending on your infra, that can be a very complicated piece of the pie. Or if you're just deploying to AWS US East, it's a very simple one to calculate. And then network, as you know, this is going to be your Viasat, your HughesNet. I had to Google what Finnish network providers were. I hope that's right. AT&T, you know these. This is actually transferring things from point A to point B. And user devices are going to be, a wide range of devices, from the most power-hungry desktops to the smallest mobile devices. And all of those have very different energy profiles that you might want to consider. Like, if you get a lot of mobile traffic, some things matter more than others. If you get a lot of desktop traffic, you have a different set of concerns. So there's all sorts of weights to consider. And when you actually want to measure energy usage, you're going to consider bytes transferred, otherwise known as page weight. This is what the Sustainable Web Design model might nudge you to do. And it's pretty simple on the face of it. You might take all of the bytes that you're transferring over the wire. In this case, maybe we have 2 gigabytes of assets sent in a given day, or all at once if you have a really huge Three.js application across all of your assets. And then you multiply that by the cost per byte. And that's something we're going to break down. And those are going to be the cost factors in energy usage across each of those 3 metrics: data centers, networks, user devices. And if we wanted to calculate that cost, we could take each of our components and calculate 2 big metrics. The first one is operational cost. Operation is literally operating expense in business. It's what it costs to keep the lights on. So all the compute running on AWS in an EC2 instance that you spun up, that's going to be the operational cost. Also a SQL server or other components. And then embodied is going to be the manufacturing expense. This is what it costs to actually build the server rack that AWS is using. It's not a cost that you incur, but as CPU needs increase, of course, they have to make more servers. So you probably want to factor that in at a macro scale to say, if we increase the CPU usage of every website tomorrow, embodied costs are going to go up as well, because we got to go make more servers. And this gives you a nice total for that component, and you can divide all of that by all the bytes that have ever been transferred on the internet in the past year. It's crazy that this number exists. I don't know how you compute that, but Sustainable Web Design seems to think you can. So in their metrics, they take all the bytes transferred ever and divide that against the kilowatt hours being consumed, and that gives you a factor that you can use against all your bytes transferred. This is going to be kilowatt hours per gigabyte for that component. And then you can compute that for each of the 3 other components to plug into a model. And I've shown some color-coded averages to show the scale of these. Of course, mobile is going to be a lot higher because the embodied expense is a lot bigger. There's a lot more turnover in all of the iPhones that we're using year over year. Amazon is going to stretch a server rack to its absolute limit and maximize its usage. But someone who owns an iPhone 12 Pro, they're probably not doing very pro things. They're just buying a nice camera and then maybe switching it 2 years later. So the embodied expense is going to be a lot higher for those people, embodied being manufacturing. And each of these factors can scale up and down depending on what resources you have. If you, for instance, use a green host instead of a standard host, then your data center cost might be lower. If you don't know what a green host is, it's not a concrete term, but it often means carbon neutral if you're working with Google Cloud Platform or Cloudflare. Each of those actually have options in their dashboard to say, I want to run this job on a clean host instead. So if you have cron jobs and you don't care about where they run, you don't care about network latency, you just want them to be efficient when they run once per day, you can ship those to a green host, and you can reduce your emissions a little bit. And you also might have a little variation in the network, depending on the location that you're serving. For example, if you're serving traffic in India, that's going to use maybe 3 times as much energy as serving that same traffic to Europe or to the United States, because the infrastructure in that country is running on much less sustainable energy compared to Europe or other places. And the last one, user devices. These are going to vary based on mobile versus desktop, as you might expect. Mobile devices are more solid state and efficient, so depending on your users, that can scale as well. So let's make it a little bit more practical. We'll take those 2 gigabytes that we were sending over to Wire earlier, and we'll push those through all of the metrics that we have. So it's a simple multiplication when you're using their model, where you take the 2 gigabytes, you multiply against this factor, which is kilowatts per gigabyte, and then you get an approximate amount of watts that are being kicked out every time the data center processes those. Same goes for the network, same goes for user devices. You can take all of those values that you computed, add them together, and you get a rough estimate of how many kilowatt hours are being consumed end to end when we're shipping all those assets every day. Now, I'm going to stop and ask a question. Who flew to get to this conference? Who flew? Oh, a lot of people. OK, you over there. Oh, sorry, keep your hands raised. I was actually going to call on people. Yes, yes. How long did it take you to fly here? Like how many hours, roughly, travel time? 8 hours? OK. Someone else. Yes, in the front. 3 hours? All right. 2. OK, so we have 8, we have 2, we have 3. You can put your hands down, sorry. That's a pretty wide range of different flight times. But that doesn't make sense to me, because I ran the numbers, and I thought everyone took 12 hours to fly here. Because I used the page weight model to compute this, and I thought, OK, how many bytes do we have? Well, we had about 300 attendees, so that's 0.3 kilohumans, maybe. And then we took how many hours the conference is. We have workshops and other pieces. That's about 40 hours per kilohuman. And then I multiplied those together, and I got 12 hours. You telling me this isn't right? Tell me there's something wrong with this model? Well, I'll admit, when I actually ran that, it felt the same way the Finnish language did to me for the first time. It seemed like gibberish. I don't understand what this is. I don't know where this is coming from. And that's because, to sum it up very concretely, destination is not the same as journey. We were all going to the same destination, Helsinki, and we all are transferring the same bytes ourselves, but the journey to get there is going to vary a lot between all the transfers that we take, the origin that we're flying from, the flights that we're going on. all of that can dramatically change the amount of energy usage we use. You know, Yari was talking earlier about how aviation is a major factor as it is for IT. So we know that there's something amiss here. Bytes transfer may not be the best scaling factor. And the experts kind of know this. Debugbear is a web monitoring service that offers a whole lot of calculations, including core web vitals, lighthouse scores, which you might have worked with. But they don't include the CO2 calculations. And they wrote a very extensive post on why that I recommend you read. But a big takeaway, none of these metrics and their findings are meaningfully correlated with page weight, which is a very dramatic stance that actually does have some weight to it, some page weight maybe. And you know, we'll break that down by each component. Data centers, for example. This is a playlist that I was listening to while preparing the talk. It's a great house playlist if you're a programmer. But you can look here, you know, if I'm keeping it really simple, and I say, to display all this playlist on the page, I might do a simple SQL query that gets everything in the playlist where the name is that. But what if there's other factors? Like, what if we forgot to index the name field? Well, we transferred the same amount of bytes, but now the kilowatt hours are probably going up because that SQL server is operating for a bit longer. And then what if we're joining with other tables? Now it's getting even longer. And what if we're filtering by US-only tracks? The kilobytes actually went down because we have fewer tracks that are being rendered in my browser. But the compute definitely increased further still. It doesn't capture the work on the server to look at the output. And there are actually different reasons this doesn't scale super well for network activity. There is some nuance here, but from a researcher at Zurich, there was this notable study on typical network devices. Looking at those in isolation, you find that the actual amount of traffic on the network is almost independent of the traffic load, which means if you're looking at this power graph here, looking at no utilization of the network to maximum traffic on the network, and then looking at the power draw on the other axis, you see that it's a pretty shallow slope. From 0 to 1, there's a pretty constant rate of activity. That's because it's consuming about the same amount of energy to just keep the network running, but as you increase the load on it, it's not really going to scale up. So it's a bit dishonest to say there's this one-to-one relationship between the bytes that you're sending across the network and the energy that you're consuming. So it might be overrepresented in our model. And as for user devices, bytes transferred is somewhat of a proxy of how much compute the user's device is going to do, but not all bytes are created equal. You probably know that a really inefficient JavaScript program that says while true is going to consume way more energy than a 100 kilobyte JPEG that you're just rendering in the browser, or 100 kilobytes of HTML. So the bytes matter, but the weights of each one should probably be considered as well. And devices aren't created equal. We already discussed mobile devices are a bit more efficient, so treating all traffic as the same can be a bit dishonest. And there's different factors on these devices as well, because mobile devices are really smart about CPU usage. They don't use a lot of CPU by comparison. But funny enough, the most important factor on mobile, because CPU is really efficient, is the display brightness. If you crank the display brightness on a phone, you might have noticed that it dies quicker. And that also translates to energy usage. You're going to be ripping through the battery faster if you crank up the brightness. So in a funny way, this might be a reason to add dark mode to your website if you needed a reason other than accessibility. At least for OLED panels, it does reduce energy usage pretty dramatically. But for other aspects of your website, CPU might not be the thing that you're tracking. So there's definitely some nuance that we want to think about. Now, one credit that I will give to bytes transferred and embodied is the actual usage on a phone. If you look in the last 10 years throughout the mobile computing revolution and kind of the JavaScript revolution as well, the weight of a mobile page has gone up almost 6-fold. And there's a correlation between that and maybe the turnover of the devices that we have. And a practical example, if you ship a massive 3JS demo, you might pull it up on your grandma's Amazon Kindle and notice that it's really chugging and failing to render. Or if you pull it up on a feature phone or an older Android device, that's not going to render well either. And there's this kind of cat and mouse situation where people are building more and more intensive software, which is requiring people to constantly replace their devices. Sometimes to just get the newest features on the latest iPhone, but also to just make sure things in the browser stop locking up on them, or other excuses that I've heard family members make. I've got to buy a new phone because it's locking up, and I can fix it. No, I'm going to go buy a new phone. That's not really a great problem to have, and it's something that we as web developers can at least try to solve on a macro scale. So with all of that in mind, looking at data centers, looking at network, user devices, how can we measure? Ask the same question again. Well, we probably want to use the best metric for each step, best scaling factor that we can think of. If we look at our approximations, maybe we add some new weights to each of these. First off, for data centers, you might want to consider CPU time instead. Not the perfect proxy, nothing is, but if we wanted something that scales close-ish to 1-to-1, we might measure the amount of milliseconds that are running in middleware for each of our server operations. And there's been some meaningful research on that. Yari was mentioning earlier about a study on code smells, and if you resolve code smells, there's a meaningful correlation to energy usage. That's kind of true across the board. If you think about it, if you make your backend faster, more efficient, it's probably going to consume less energy. So let's try to use CPU time to figure out that weight a little bit better. It measures performance, user experience, and climate in a decently accurate way. As for network, you might want to treat that as constant when you're designing your app for the first time. Since it is fairly constant usage with today's data center racks or network racks, it's probably best to just kind of exclude it from your model, not worry too much about how you are affecting it. But it is still a factor you might want to consider on the macro scale. And for user devices, you may still care about bytes transferred, what we talked about earlier. But try to weight it based on the type you're sending out. If you have a JavaScript file that's very intensive, you might weight that higher in your calculations compared to a JPEG, compared to an MP3 file. And sending it across the wire, you might hit very different measurements. Like that is 3 times the metric that we had earlier for data center usage because we were looking at CPU time. And that difference might be enough for you to look through your calculations and decide, oh, it looks like data centers are accounting for over 50% of my usage. Maybe that's somewhere I want to start. Make my backend faster, and then I'll worry about the bytes that I'm transferring afterwards. It helps you focus your efforts after you're in the door. And again, that could give you a different value so that you know where you got to focus your debugging efforts. All right, let's try to do a little code demo. You can see right there, there's a link, wtw.dev/climate. If you want to see the source code in its completion, this is a link to a little GitHub repository. So if you want to look at the middleware, all the code comments, I'm also linking some resources in there. You can definitely head over. I'll highlight that link again at the end, and we'll try to code it live so that we can also see how this experience works. I'll open up my editor right here. And this truly on brand is an Astro website. We're going to be checking this out over here. This is a very simple website that's just meant to be a soundboard generator. So, in the middle of a Zoom call, someone's falling asleep and you want to hit an air horn button. That's this purpose. You can upload an MP3 and hit play. And building this, I wasn't really thinking about energy usage. I was just thinking about, let's just go build something cool. And I tried to plug some of these ideas into this app to see what we can get with CO2. And I have a metric up top for CO2 usage, which is going to be a rough estimate. I'll walk through all the constants that we're using and anything that is something I'm more or less confident in. Heading over to our middleware function, this is where we're going to measure all the usage for our app. So you can see right here we have a lot of constants. We'll explain those, don't worry. But this is where we're defining the middleware, and this is going to wrap around all the requests that go out from this server. So we'll start by clocking the start time, say this is the millisecond timestamp when we started calculating things. Then we're going to run our server logic, and then we're going to roughly compute how much CO2 went out trying to run that job. And we have a little bit of database writing so we can persist these metrics, show them visually. But these are the 2 functions right here. Get the server CO2 and the client CO2. So to implement this, we can first start by getting the amount of time that has elapsed. So if I wanted to get performance.now, for example, we can subtract from the start time, and that'll give us how many milliseconds went by while we were running on the server. Then the number of hours would be a little bit of division to get there. And then for the actual usage, we can compute the kilowatt hours. This is where things get a little bit interesting, because how do you figure out the amount of kilowatts that a CPU used? Well, you got to know the hardware that you're on, first off. We're assuming that we're on AWS, we're on US East, and to get the kilowatts, we're going to take this metric right here from a pretty intensive reverse engineering study. This is linked in the source code if you want to check it out. But this went through an EC2 instance and really drilled deep on how much a CPU is going to use. I just took the number for the memory-intensive task, since JavaScript is a more memory-intensive language, and I put in a fudge factor of about how much of that CPU our job is going to run. Since we're on serverless, it's very hard to predict how much a serverless job is going to take from its host machine. I know Yari does not approve of a fudge factor number, but this is my demo. OK, trust me. You can probably improve this if you actually know your serverless bill, though. That will tell you your CPU usage. Plug that in here if you're able to. And we can take that kilowatt hour right there and return it based on the actual amount of CO2 that we are using. And this is going to be multiplied by the amount of grams of CO2 AWS pumps out. Believe it or not, there is a spreadsheet that has been provided in this open source community over here. Google Cloud Platform provides this from the platform. AWS, we had to reverse engineer it. But I say we. These talented developers were able to do so. And it gives you a rough conversion from kilowatt hours to the CO2 that data center would pump out. Since we know where we're hosting, we can do that. If you don't know the region that you're hosting in, you might want to ignore CO2 and just keep things in terms of kilowatt hours. They'll give you the exact same amount of information. We're just doing this because, well, CO2 is the direct measurement that we're trying to go after. So we can be accurate, let's be accurate. All right, and now we get a little graph in our UI that's showing us server usage. It's not scaled, so let's look at our client usage to make sure we also have that metric. I'm going to take the amount of bytes that we're sending over to Wire and multiply it by the amount of kilowatts a gigabyte might consume. This is coming from Sustainable Web Design, and they're just giving a global average of how much CPU a user's device roughly uses. Super rough. If you have analytics, you can definitely improve that number, but a global average is a good starting point. And then we can take that and multiply by another factor from Sustainable Web Design to get that CO2 number. So if we plop that in here, now we get a rough average of, OK, this is how many bytes were transferred, this is the server usage, and we can see a ratio to compare everything that we're working with. Now, let me try uploading a few sounds here. If I, upload, that sound effect, that one, these will go up to our server, and you get some CPU usage trying to upload those. And something you'll notice when you hit play on each of these is you'll see a little spike in activity as we're downloading the bytes and playing the audio for the first time. It makes sense, but I wouldn't expect to get that cost every time I visit. You'll notice that we are getting a spike on every visit, but these are static files. Why are we getting a spike on every file? Interesting. Well, I did forget what a cache header is, apparently, so that helps me debug that issue. If we head over to this file, this is where we're serving everything out of a bucket, all those audio files. And looking at that energy usage, I was able to debug, maybe I should put a little cache header in here so that I'm not wasting valuable resources for repeat visitors. This is saying just cache it forever, because this audio file isn't going to change over time. It can only be created or removed. So that's a pretty safe cache to add for our purposes. You'll still get a spike for the initial visit, but once the cache is registered in your browser, you should now see that there is no spike. So there you go. Nice way to use a debugging tool and figure out where your energy usage is coming from. There is one other demo I can give. I know we're running a little bit long, but what's that? We're good on time? Sweet. All right, well, I will go normal pace. So the second thing that I wanted to talk about is, well, yes, we are able to cache things effectively, but what if you upload something really, really big? Or honestly, something moderate. Here I have a 15 megabyte file that's about 4 minutes long. It's an opening track. And it looks like this website just lets me upload 4 minutes, and it's totally fine. Well, let me go ahead and hit play on that. And oh my god, that's a lot of bytes. And you'll notice as things are playing back in my browser, it is still an ongoing stream of audio. And that doesn't play well with cache headers, I've learned. So if I refresh this and hit this, Even though it's cached, it's not able to cache the resource until the whole audio file has streamed through. So not only are we allowing a lot of bytes to go back and forth over the network, we're also letting you kind of bust caches by having long files you probably aren't going to play to completion. Luckily, we have a very defined scope for our app. We know that this is a soundboard builder to play air horns and 5-second snippets. So we probably shouldn't allow really large audio files. If we head back over here, we can update our backend to maybe impose a byte limit of some kind. I have a very strict limit that I put on here, 500 kilobytes. So if any user tries to upload a really big file, we probably want to bounce it back to them and say, send something smaller, compress it as an MP3, do something, because we probably don't want to serve this. So if we say, if the byte length, which is something that you can get on a file upload, get the byte length, if that's greater than 500 kilobytes, then probably just return some sort of response. In Astro, you can update the status code while you're rendering something, which is kind of cool. If you wanted to show like an error message, we can set the status and then react to that status inside of our page. And I'll put everything else inside of an else block, because we don't want to persist in the database if something is too large. And you can see down here, I have a little banner that's going to pop up whenever that status is 213, which is, or sorry, 413, which is a status code for invalid resource. If I refresh this again, and I try to upload that same file from earlier, you can see now, file too large. There we go. So now we're blocking bad bytes being sent over the wire. Another case for looking at the bytes you're transferring so you can actually figure out how to make your website more efficient. OK. That is the end of my practical demo. I'll try to leave y'all with a couple resources. Again, if you want to see this code and you want to copy it into your own Node.js backends, this is a pretty generic JavaScript tool. You can go to www.dev/climate. If you head over there, this will redirect you to the actual source code for what we just built. You can walk through the entire repository and try it locally if you want. No API keys necessary. And you'll see all sorts of embedded links for sustainable web design, which is the model we've been alluding to. Shout out to Sustainable Web Design for having a very clear breakdown of how their algorithm works. All those calculations I ran are this math table. They tell you absolutely everything about each component, where the numbers came from, how to multiply it yourself. So if you want to go back to algebra class and practice things, there you go. And we also have a couple other links in here. The Medium article for reverse engineering AWS, pretty useful. And the cloud footprint, which is our timetable for all energy usage across cloud providers. It's something you can plug into your own setup if you know the hardware that you are using. OK, I think that's everything I wanted to get through. I will leave the floor for Q&A. Thank you so much. Appreciate it.
Thank you, Ben. Yeah, let's have a quick Q&A because it's going to be lunchtime soon. But are you, Ben and Jari, are you going to stay here today if people want to ask more questions afterwards?
I will too.
Until the after party, so you have plenty of time for your questions.
We'll be here.
I think often I feel like green computing is talked in organizations in a higher level, but it kind of feels sometimes as like a greenwash. As a developers, how often do you talk about like how green is your code? Is there any like, requirements for environmental requirements? No? Oh, no. Oh, no, we come nowhere. OK, let's start talking about AI, emissions of AI. And obviously, I guess we know it has been calculated of like emissions for the AI and ICT sector in general. I'm sure cryptocurrency is one of the bad guys, but yeah, how do you feel about this?
If I start, one thing that I didn't talk in my presentation is that when you are thinking of those emissions of your solutions, That's the footprint. That's the emissions that your solution itself does. But then there is always the other thing that is called handprint, that what kind of things you can actually save by using that. Now, if I'm thinking yesterday's example of this AI alarm clock, I don't see too much of a handprint over there. That's mainly footprint. But if you are changing something that then saves in other places, like you have a GPS navigator, it has some embodied carbon emissions, but it helps you to drive shorter distances, etc. So it has a handprint and as such, improvement as such. So although AI takes a lot of energy, we will see that it also has some positive effects.
Oh, that's a surprise. How about you, Ben?
Yeah, I mean, I agree that, AI is going to have practical use cases, unlike crypto was something that I just saw come and go. But AI is in the stage of let's put it on everything, and then we'll scale back once we actually know where it's most applicable. And it is nice to see AI pushed into consumer devices because people are immediately hit with, it took 10 seconds to run that query, and that's not going to work for me for this practical use case. And AI people are going to be forced to say, let's use more efficient languages, let's use different models. Maybe don't use AI at all and just use an algorithm for this piece. So consumers are kind of this forcing function to make things faster. And as I was kind of trying to demo, the efficiency of something can be correlated with the energy that it's putting out. Not perfectly, but it's a good proxy. So I think pushing it really aggressively into people's hands is going to force it to be smarter and a little bit faster. But until then, it is being applied to too many things probably, and I hope that does scale back depending on need.
Yeah. Do you think we can trust emission reports, from the big actors like AWS and whatnot?
If I'm answering to that, I was discussing this with Ben already before. And quite many of those tools also that my students found are showing some CO2 emissions. And some tools help you to reduce your emissions by moving it to a cloud that is more green. Mm-hmm. But the fact is that our current energy usage is growing more than the increase of green energy. And if some company is saying that, hey, we are using only green energy, then somebody else is not. It's a zero-sum game. And I don't like that somebody says that we are completely carbon-free because we are using green energy as such. I would love to see, like in Google's case, that, hey, what is your energy usage now? How many kilowatt hours? What it is or what was it 5 years ago? Now it's 200% more. So and then you still say that you are really running green. I wouldn't say. I would rather look at the energy usage and then the depending where you are really running the service. Of course, it has a matter, and if you can have then the possibility when you have optimized your energy usage, then run it in the place that is most greenest energy using place. Some cloud in some Nordic countries, like in Sweden, they have a lot of hydropower over there that basically gives them green energy. Then that's the way of doing it. But for me, it's kind of a greenwashing.
Mm-hmm. So you mean measuring things in terms of like the kilowatts being pumped out instead of CO2?
Yes.
Gotcha. Yep.
Yeah, we talked yesterday a bit about edge computing. Is edge computing better than centralized data centers?
Yeah, it's a tough one to pin down. It's why I didn't use like Cloudflare for the practical example. Because, yeah, if we know we're running hardware on this AWS region, we can probably figure out how much that CPU is going to affect the wattage that's being used. But if you spread that out over like any, usually a CDN is what it is, which is not necessarily a more efficient server, but it's usually one closer to a user. And the goal is to reduce like the actual network latency to get from where the thing's computed to where the user is. But as we were kind of talking about, network usage isn't a massive factor. It's more the amount of compute that's going on. So I would think there's some benefit to, like Edge has a restricted runtime where you can only ship certain things. So it kind of forces the developer to make things super efficient because they can't even deploy to production with a certain bundle size or a certain CPU amount. So it does force you to have better practices. But once it's on that machine, it's probably running it about the same. You'd have to actually look at the providers to know. And I didn't get metrics on like CDN and edge providers, so I wouldn't know how that part works.
I have one example on this edge computing. Yesterday, I think somebody was saying that there is no need for edge computing because the user experience of using the clouds is fast enough, if I remember that correctly from yesterday's presentations. But some years back, one of my students was doing an experiment where we were looking at offloading some computation from your mobile into some resource that is close by. We can call that edge as such. And in the end, selecting a suitable computational platform for the problem was actually more energy efficient, and it was even faster than doing everything on your device in your mobile phone. Even when we were considering and calculating all the energy that was required for the data transfer and the computation in that server and mobile phone. But it depended a lot because mobile phones, we found out that even if you have different models from the same manufacturer, it depends a lot of the hardware configuration that they have, what kind of a processors, memories, and whatsoever they have, what kind of a communication chips they have. Somewhere more efficient, somewhere not. It was really complex case.
I think since this is a future front-end conference, there's a lot of front-end developers. But developers in general, what would be like the first concrete steps that we can take? Or is there like anything, I mean, I'm a developer, I get the design, and then there's a video, I'm like, no, I'm not gonna do it, it's too much. But is there some like actual things that no, we can do?
Yeah, I mean, I hope there's at least one thing. I mean, there's so many different pieces. I do definitely appreciate services that tell you, PlanetScale is one example, where they're a SQL provider. And every week they give you an analytics metric of, these are all the queries that were run, these are the ones taking 200 milliseconds, these are the ones taking 20. And you should probably optimize the one that's taking 200 milliseconds. That's a really great call to action to say the first step to optimizing this thing is going to be going to the database level, optimizing that query so that all of our traffic can be rendered faster. And that's usually how I end up building apps, is starting from the lowest part, usually the database, then looking at making the server more efficient, and then making the client more efficient. There's no need to walk one way or the other. I just tend to work with a lot of server-driven apps. So just looking at those metrics and knowing how much cost there is to compute certain things, you'll notice all sorts of places where you're just writing really inefficient code that should probably be improved. So that's where I usually like to track it. Because also on the server, it's something that you own. You know the hardware, you know the SQL server that you're running. It's more controlled, it's more approachable to like get a metric you could bring to a product manager and say, we sped up users by this amount, and it's going to improve usage in our analytics by this much. It's really like, boom, here's the cause and effect. And the client part is a little bit more gooey because you got to open up your browser dev tools to figure out how efficient is this React app, which is getting better, but it's a harder piece to figure out.
Yeah, anything you want to add, Jari?
So the question was, what kind of a green steps can the developers take?
Yeah.
First, I would like to recommend that look at the Janne's book. Janne has a nice high-level kind of what was the word, Janne, that you were using for was it waste or what kind of a waste we are basically using for, and then there is some guidelines. But the other thing that I want to actually mention is that the responsibility of doing things is actually, I would say that it's distributed to many players. I really hope that the cloud providers would develop their kind of approaches in such a way that the developers can see much more data from there, because they are providing the platform, so the platform itself could provide you much more stuff. And then, of course, I had pretty nice discussions here with the company representatives, is that within the companies, within the developers, there are always some senior people who kind of give those guidelines and so on, and creating this kind of guidelines, how to make things as efficient as possible. I would say that it's already there. Now just considering that if we can measure any of the energy usage and then also consider that, and creating those guidelines is one way forward.
Yeah. Thank you. Juha, looks like we're running out of time. Okay. Juha has a plan.
Yeah, let's see if I can get this connected.
No more demonstrations of those wooden things?
Yep.
So first of all, if you want fish or cauliflower, there's lunch waiting for you. But what we do now, because we have 1 hour lunch hour, we will continue the discussion for 15 minutes because you're on the stage. And if you don't want to stay for the extended discussion, you can leave now. If you want to stay here for the extended discussion, well, stay. So now you can leave or stay, depending on how hungry you are, or if you want to eat the fish before others.
And we will remember this if you leave.
Let's see if we can get the screen.
What's up?
Up.
Looks right, I think.
Just a moment. Yeah, it's doing something funny. I will fix it. Sorry.
No.
I don't know.
Things should be mirrored now. Yep. So I wanted to show you what we did with our site. So we are A+.
Wow.
Have you tried the other carbon calculators for the pages?
Not yet, but I mean...
There is quite a many of those that are
yeah.
calculating, and some of them are really giving similar kind of results. Some of them are considering different things. You only looked at this web carbon calculator, right?
Yeah, that was my entry point.
Yeah, before I leave the stage, I just wanted to mention that if you want to learn how we optimize the website, just you go to the blog and read the post. So it's simple techniques and from front-end perspective. But I think I will vanish, and you will totally you have to do your thing. Not done yet.
HTML is fast. Who knew?
Oh, this was way too fast for me. No, just joking. I'm actually interested always when, well, back in the day when testing wasn't like taken, you know, like, how do you say, by default. We had to kind of sell to the business owners that, okay, this is why you want to pay for testing. But how about like this green point of view? Like how, okay, maybe there are like some like, you know, concrete measurements, like you can measure that, okay, you will be saving for this, but I mean, like, I feel like sometimes the business owners or the someone who's paying the bills might think that, okay, this is, you know, extra, you're spending extra time of like creating requirements, or, you know, how could you sell or help us sell this idea?
So your question is, how do you sell that you invest in making things as efficient as possible. I would say that Motiva at the moment is creating this kind of a green criteria for software. And in our previous Midvidi project, there was basically the customers and the producers working together in such a way that how can we measure things that can be put as criteria in a procurement document in such a way that when there is this kind of a competition that we want to have this kind of a software, then there can be some criteria that can be measured in such a way that we would not be comparing apples and bananas as such. So Motiva is working on those things these days. And I have to say that it's not me only who is working on this. Tieke in Finland is really active. We have a lot of companies working with us, and of course, if the companies are really interested in working with universities, then I really encourage to contact us, because the master's program that we have, we are working with companies and doing different things with the companies, and we always need some cases for the students.
That's interesting. Ben, what do you think? Is there like a greenest framework to use? Is there like a way to introduce better ways or greener ways to do things without doing like some major changes?
Without doing major changes, that's the big one. Because the easy answer is just use Astro for everything. And there you go. But asking for a framework rewrite is a lot. And it's usually best to focus on high traffic areas or very specific areas where you know something can be improved. I know that at my last company, we were using a client-side application for everything on an e-commerce site, but we were also using it for home pages and call-outs for new products that were linked straight from Instagram and other places. And when you're coming from those high traffic regions, it really matters how quick that page pulls up. And if you're trying to spin up a Create React app that gets a 10 on Lighthouse scores, it actually was a 10, it can definitely hurt conversion for people that are visiting that product and they want to go buy it. So if you focus it on, okay, there's this one product showcase, we're launching it tomorrow, and we really want this thing to be snappy. We're going to just use like the most bare bones tools to build that piece. Astro is one option. There's also Hugo, Eleventy, all these other static site builders that can just take your content, maybe render with React, and just flatten it to straight HTML being sent over to Wire. The difference being, are you running a bunch of scripting to make the web page load, or are you running very little? And how much analytics are you gating in front of it? There's a lot of analytics cost. I know that Partytown is one really great tool that just kind of runs your analytics in a worker in the background, but it keeps everything the same way. So it's a very simple refactor that you can just toss on and go off to the races. So scoping things down to where you actually want to make those improvements and doing very minimal refactors to get there. Try to keep what you have.
Let me add here, although I don't go into that level, but just saying that now that the companies start considering doing this energy efficiency and measuring things, even though that you had the comparison of different providers as such in your place, but at the moment the companies do not have these figures. And if you open up things and say that, hey, this is how we are measuring, this is our measure, and then you are showing how you are advancing on the next version, that, hey, we have improved 20% of our energy usage and so on. That's one way of doing it, as long as we don't have these, let's say, metrics that fit for all.
And obviously, I think we all know that videos are really, really bad, but I think images are quite, basic thing on the web, and especially if you have like web stores, how are you going to sell something, without images? But the question is that what's the best way to make the image-heavy websites greener?
Yeah, I mean, it's going to come down to image optimization most of the time. There's all sorts of services to do that. By image optimization, I mean, can you, compress things? Can you serve in optimal formats like WebP or AVIF? And can you do it in a backwards compatible way? usually by having multiple formats generated, and then the browser can choose the smallest one that it's able to render. There's tools that automate that process. There's really low-level tools like a 11D image, which is, you would think, would be scoped to their framework. It's built into a different framework. But it's this very general-purpose JavaScript tool that just takes in an image and generates new files for you. It's just a one-to-one. You can run it across any images locally, and it just kind of works. It's actually what Astro recommended for a long time when we didn't have image optimization, was just go use this tool. It's really simple. But you can also use Cloudinary and other CDN-based services that can let you upload images, and then based on where the user is coming from and query params you add, it can also make that optimized. So those are two options that come to mind if you're in like the JavaScript space.
Not only the figures and videos, but some of those carbon website calculators, they also go through all those different categories, scripts and ads and whatsoever.
Yeah.
And for example, the Aalto University made this kind of I should have the link somewhere, but a website calculator that was basically breaking up everything and then showing that, hey, this is where you are doing bad and this is where you are doing good. Mm-hmm. And quite a many pages. They went through, I think, 500, 1,000 Finnish city and company websites, and then they have a very good kind of a comparison over there that whenever you are driving through all those websites, you can see that how you actually fit there and where is your pain points.
Gotcha. Is there any specific website that?
I'll give you the link. I
Yeah.
just don't remember it right now.
I'm going to read an actual question
Sure.
for the final one. It seems like most of sustainability gains are to be had at the data center or hardware level. Are there any concrete changes that should happen in software?
Yeah, there is an assumption baked in there. I'm not sure if data centers are like, oh, yes. Is that a little bit better? That's a lot better. Yeah, there we go. But yeah, I know that, I'm trying to remember the question. So what was the second piece of that?
Sorry, I lost it too.
Okay, it was data centers.
Yeah, it seems like most of
Software.
sustainability gains are to be had at the data center or hardware level. Are
Right.
there any concrete changes that should happen in software?
Gotcha. Yeah, so first off, to like dispel any confusion, when data centers are being presented, there's operational and embodied, and those were kind of the two sides of the coin. And when you divide it up, there's some usage that just goes into the raw hardware, manufacturing it and running it, and then there's also a big cost that goes to software. So I wouldn't say that like most of the gain should happen at the hardware level, although yes, it would be great if every data center could find carbon neutral technology or lower network latency, all of those pieces. But there are so many improvements that can be done at the software level, reducing your compute times, improving your SQL, improving your image optimization, reducing your JavaScript size when you're shipping off to a client's browser, all sorts of pieces that sort of go into that. I don't know if you have perspective on like which pieces are more or
I'm not
less.
sure if I got the question correctly, but for me the software level is where you think of the solution itself, and it depends. Basically, whatever you are doing in the software, like yesterday we had this really nice case where you were syncing all those devices together. My question is it okay? It's nice that you can do it, but is it necessary always to have that? Because if you have that kind of an operation and you are syncing it to 10 different devices and you use only one, then there is 9 extra ones. So I think there is a lot of things that we can consider at the software level, that how do we want to operate, what is sufficient, what is necessary, what comes to the user experience, what is for the energy efficiency as such.
Thank you. I'm sorry, I have to ask this bonus question because a lot of our speeches are like, okay, TypeScript is quite the default nowadays. But when we discuss about how what's the effect on like which language is the best for the environment. I think TypeScript is quite low on that chart. Do you have any, opinions on that?
I mean, compared to JavaScript, there actually was a research study I remember reading. I didn't include it in my talk, but it was comparing, or it was an attempt to compare, language energy usage per computation. But it's really tough when you do, contrived, here's a for loop that iterates over 100 things, and we ran it a bajillion times, and that's how efficient the language is. Usually not. Depends on what the language is actually doing on the hardware. So TypeScript to JavaScript, since TypeScript compiles away, it's going to be about as efficient as JavaScript when it gets to the server and when it gets to the user. So if there's any worry of adding TypeScript to your web development flow, I don't think there's anything there. But for backend compute, I mean, it can definitely depend. I know if you're using WebAssembly to make sure something like Rust is able to run in an environment, WebAssembly itself has a big bundle size, startup time, compilation cost that can offset some of the benefits that you're getting. So you do need to be a little bit skeptical about those improvements. I know that just reducing the amount of time you're using someone else's hardware on AWS, if you wrote that function in Go, it's returning in 50 milliseconds instead of 500, and it's running in the same location, same hardware, everything else is constant, you are going to get an improvement, probably. I mean, if it's introducing bugs because people don't know the language, that's a problem. But if everyone's experienced, they can build good code, you can definitely get a benefit if you know how to hold the tool.
Yeah, so basically saying that it's not so black and white to just see
I
the
said
charts.
so many caveats.
Yeah.
There's so
Jari, do you
many.
have anything to add?
Not really on that level, just thinking of those different languages from the developer point of view versus the energy efficiency point of view. Some languages and then frameworks that you are using might not be energy efficient, but they are developer friendly compared to doing everything in assembler as such. But my background is on parallel computing, and there you actually needed to know what you are doing, not use the tool to do that, all that thing.
Thank you so much, Jari and Ben. Let's go to eat, and we'll be back in 45 minutes. Thank you.
Thank you.
Thank you. Oh, right. I don't know if we keep these.
Yeah, just relax. We're only starting in a couple of minutes. All right, party people. We will be starting in just a couple of minutes. So I'm just speaking to this microphone so that people in the hallway will hear that we are starting, and they'll be heading over to the room. Please don't listen to me. I have nothing to say. There is no content. If I could sing, I would probably sing. If I could tell in jokes, I would. But I've already used the two ones that I knew, and they didn't work out that well. So I'm not going to chance it on the third one. Yeah, just 1 minute, 2 minutes, and we'll get started. Thank you. Okay. This is the disembodied voice of your host. Why can't you see him? Why can you only hear his voice? Oh well. He's coming here. You can see him now. Okay, folks. We are going to begin our a real treat for you. We have a session with the TC39 committee members. And we'll be running this set as follows. I will soon introduce you to a host for this session. Rob from TC39 will be hosting this event. But before that, Daniel Ehrenberg made a specific request, which I now must fulfill, because when Daniel Ehrenberg asks you something, you have to do it. These are the rules. So he asked me to tell you a joke, which I just read, and now I need to deliver. So here's the joke. I'm sitting at my computer writing JavaScript, and I keep always thinking, this is terrible, but the problem is I can't remember what this refers to. Thank you, Daniel. Thank you for this material. And now, without further ado, let me hand over the microphone to Rob.
Hey. Welcome, everyone, to our section now that is focused around JavaScript standards. TC39 is actually in town this week, and you'll get to hear all about it from Ujwal next. So we've taken this opportunity to join up with the conference here, and so yeah, very happy to be here. We're going to start this session with some talks, and then we'll have a panel. So please have a think about any questions that you would like to ask us later. So please, first joined by Ujwal here, who works at Igalia. Please come up. Who's here to introduce TC39 and how we work.
Hello. Yeah. Okay. So let's set this up. Better. And Oh, there it goes. Oh, yeah. No, I don't think I have network. What? Where did he go? Yes.
See, just because you are on a standards body doesn't mean that you know how to use a web browser. But I don't know how to use Windows, so this is between the two of us we can. This one?
Yeah. I think it's connected now, but
I think that we can do better than the Helsinki City Open Plan. I mean, we are very popular. We're very happy with our public services. Oh, not that one.
So if we need to fill some time, I could ask the audience, how do we make a JavaScript bug better? We console it.
should work. Thank you. All right, let's forget that ever happened and move on. So, perfect. It's working. Hello, everyone. You heard a little bit about me. Hi, I'm Ujjwal. I am working on TC39 as one of the co-chairs with Rob and our colleague Chris. And I'm here to set the stage for the rest of the presentations because do you even know what TC39 is? I mean, it's not the most descriptive name, but let's make this fun. So by a quick show of hands, how many of you know that TC39 exists? Or, okay, that's a few of you. And do you know how it works? Or, okay, so that's nobody. So I hope I can be of some help here. I'll try not to take all of your time, and this can be pretty dry stuff, so I'll try to be not very boring about it, but please feel free to ask me anything for the rest of the day. So moving on, let's talk about the most important thing first. Here's me trying to read the first version of the spec. I'm Ujjwal. I am known by my nickname on the internet. I'm from New Delhi in India, and I live in Coruña, in Galicia. And I am I've been working on open source software for a very long time. I believe the web is one of the most important things, and I'm really glad that all of you are here to preserve it. And yeah, just a bunch of stuff about me. But do any of you know about Igalia? No. A few of you, thank you. But yeah, you could see. I work at Igalia, but what even is Igalia? Igalia is a consultancy that works on open source software and standards. We are working on cooperative, and we have been working across different open source projects, including some of your favorites. I specifically work on the compilers team, where we design programming languages and runtimes, and what's a better language to design than JavaScript? This fun fact, I don't know if any of you knew, but Igalia has a special history with this city. We used to work quite extensively back in the day with Nokia on Mimo, and this is a photo for Helsinki office. But okay, let's get to the point. What even is TC39? And I would say, okay, TC39 is a standards body, but what even is a standards body? Have you even ever come across one? Or have you used the work of any of the standard bodies? I would say probably yes, because there's a few of them. ECMA is the organization that we work with, but you might have used something by Unicode, for example. Pretty important stuff. Or ISO, or W3C, and WOTPEC. So there's all of these different bodies that are mainly in the business of bringing together disparate groups of people and helping them reach standardization and unification. And it helps us all, because once something is available to everyone, it's part of the commons, you can build on top of that rather than alongside it. So TC39 specifically is the 39th TC, Technical Committee of ECMA, and specifically it works on what we call the JavaScript programming language, or more specifically ECMAScript. But, you know, who participates in TC39? You might be able to guess some of them. So there's obviously implementations from different browser teams, but also massive companies that are responsible for maintaining huge JavaScript code bases. Everyone who has some stake in the future of this programming language that we all collectively probably not despise. But the point is that there's so many groups, like academics, like the open source projects, like the OpenJS Foundation, who also form an important part of our process. And we'll get to what it is later, but even beyond this initial set of participants, there's subject matter experts, there's people who represent different communities and projects, as well as people who just contribute to TC39. Everyone is important to the work we achieve in the end. Before we go on with the rest of the presentation, I can quickly go over some of the terms that we're going to use, not just in this presentation, but moving forwards in the other talks. So ECMA, as we talked about, is the standards organization where we work. It doesn't stand for anything. ECMA is not an acronym. I don't know. But it used to stand for something. Fun fact. ECMA 262 is the standard that we write. It specifies the entire JavaScript programming language as well as its standard library. I should be checking these off. And there's more standards like it, but this is the one that you're probably most interested in. Then ECMAScript, that's JavaScript. It's a collection of different standards, including ECMA 262, put together in a runtime. Then there's different task groups that we'll get a bit into later, but there's different task groups. So ECMA, rather than doing everything at the central level, sometimes delegates things to specialized groups of people. And then there's the technical committees, like TC39, but also TC53. OK, so now that we've got that out of the way, how does TC39 even work, right? The most important thing that I'd like you to take from this presentation, if anything, is that ECMA works on a consensus-based model. This means that there's no voting, that nobody is enforcing anything. Please don't talk about that. But most importantly, ECMA works because we all need it to work. The web platform, as it is already very fragmented, and if we didn't work together, nothing would get done. So there's a lot of people from diverse backgrounds in the committee. These may include people who implement JavaScript or people who are purely interested in it from an academic point of view, and everybody in between. Then there's the process where everything is done through consensus, as I said, and there may be objections or concerns, and you have to satisfy each and every single one of them. Now, that sounds very chaotic, and it is, but it is very important. It is important because all of this works because of the social contract, because of the fact that we have to make the programming language work for everyone, the web platform for everyone. So when it actually comes to doing our work, there's 4 different stages of maturity for the proposals. We'll get into that later. And any proposal, which is any change that you propose in the language, goes through these different stages throughout its life cycle. And it receives different kinds of feedback at different stages, and so on. So talking about the task groups that we discussed earlier, TC39 has a few task groups. So first we have TG1, for dealing with the entire specification, the programming language standard. Then we have TG2, which is something that I work on and Shane works on, that you'll hear from him. And it is mainly tasked with internationalization. So all the internationalization APIs and efforts that you see, not only in JavaScript, but in the web, has something to do with the folks in TG2. Then there's TG3 that works on security, especially when it comes to running JavaScript in stricter environments. Then there's TG4 and TG5. These are new task groups, relatively new. And TG4 is in the process of standardizing source maps, which is one of the most interesting things we're doing. And TG5 is a research effort to work on language standardization, to find out how does a programming language standard, which, I mean, it's pretty dry. It's very boring. How do we communicate with you? Because the standard is only as effective as how it relates to the people who use it. So I think that's going to be a very interesting group moving forwards. Talking about where our work gets done, all of it's pretty much on GitHub. Apart from a few meetings here and there, pretty much everything we do reflects back on GitHub, and the easiest way to get involved in most cases is to just start bothering people on GitHub, file some issues, make some changes, and you're in. There's also the spec itself. You can read it. You can try to make any changes to it. And we try to meet each other a few times a year to stay in track, I guess, essentially. So there's the 6 plenary meetings every year. That's the kind of meeting that we're here for. Thank you, by the way, for hosting us. Or some online meetings. And then there's smaller, more focused meetings. These meetings can be more regular. They can be smaller, more focused groups. But the important point is that most of the work that is done is not particularly done in the meetings per se, but rather on GitHub. And the meeting is just a place for people to talk things through, for the most part. Talking about the stage process, I hope you were excited for this one. Everything starts at stage 0. Don't ask me why, it has to, I guess. At this stage, everything is a rough idea. It could be something you wrote down on a napkin, or, I don't know, something you just hallucinated, or a file in a repository somewhere. But everything starts at stage 0. At this point, we call it a straw person proposal. And it starts getting fleshed out. So in order to kick things off, you need to first get it adopted by the committee to begin with, right? Like, for people to recognize that this is an interesting direction to even start considering working in. There's a lot of stage 0 proposals, by the way. If you're interested in any of them, you should probably let it known so people prioritize them sufficiently. But beyond that, things start getting serious. So at stage 1, okay, you had an idea, and it was accepted by the committee. It was not accepted by the committee in that this is exactly what we're going to do, but in that this is an interesting problem space to explore. So stage 1 means that now we can start the actual process of, well, discussing the different things, the syntax, the different facets of this proposal, and see how it's going to work, if at all. So here we start getting close to the shape of a solution. We have a champion, and I know that sounds like very rough, but this just means there's a person who's assigned to communicate between the authors of the proposal as well as the committee. And yeah, this is the time where you can have massive changes, massive rethinking of the proposals, and people start playing with demos and polyfills, and it's one of the fun stages. Signals, for example, a quick show of hands. Any fans of Signal here? Okay, wow, that's very promising. But Signals is a stage 1 proposal at the moment. It's something that we've been discussing very frequently and hope to sort of design in a way that reflects the actual usage. I'll skip the examples because, I don't know, that's not a great use of time, I guess. But Decimal is a stage 1 proposal as well. I don't know if you're excited by it, but I am. The point is that all of these proposals, if you notice, try to address some deficiency of the language and try to address it in a way that works for the large sort of group of stakeholders, which can be quite intimidating. But Decimal, fun. There's a lot other stage 1 proposals that are in the works. Type annotations, for example, you might be interested in, but the point is that there's all these different stages at which different things are, and they slowly evolve. Stage 2 is when things start getting serious. So here we start describing in very clear words, syntactic and semantic details. We are writing down formal spec text here, so things are getting settled. This is, in my opinion, one of the stages at which most of the work gets done, because it is open enough in that a lot of things are moving parts, they're being fleshed out, while it is open-ended enough and serious enough that you have to write the spec text, for instance, and people are starting to think not in terms of like what a solution could look like, but what the solution would look like. So this is, as the slide says, it's almost the stage at which TC39 expects that a feature would be developed in the future. But things are still quite experimental because they're not settled entirely. Deferred evaluation is, spoiler alert, it used to be stage 2 until the beginning of this week. But you might recognize this as something you'd like to do. Basically, it allows you to add a modifier next to the import to change the way your import works and allows it to lazily evaluate things. And which stage did that move to? It moved to stage 2.7. The new stage is stage 2.7. Don't ask me why we named it like that, but it is not confusing at all. But why stage 2.7, right? Because it's closer to 3 than to 2. It is a stage which we recently introduced. And why? Because there's a bit of a disconnect between the way we did things. At stage 3, we basically expect everything to start getting implemented, to start being used at some scale as well. But at the same time, this is before there's any test written. So there's a little bit of a period between the proposal getting to stage 3 and the proposal actually being implemented where there's no tests. And how do you implement something when there's no tests? It's kind of a chicken and egg problem, and we solved it by introducing this new stage. So now you have the 2.7 stage, which is exclusively for writing tests and sort of iterating on that end. And then you go to stage 3, and it has the regular implications of stage 3, that it starts getting implemented in browsers and so on. Still don't use things, though. So this is the stage 2.7 that we were talking about. The tests, now that I mentioned them, are very important. JavaScript is a very complex programming language, and to write appropriate testing for it is one of the most challenging things. But we have a conformance test suite. It's called Test262, and it's one of the, if not the best places to get started and get involved, and it's really fun. I would really recommend getting involved if you'd like to. Talking about stage 2.7 proposals, there's Shadow Realms. Now, that is a very complicated proposal that would probably merit its own presentation, but it's a fun feature. Check it out. And it's being tested right now. And then there's Math Sum Precise. It was just that easy. Thank you. But moving on to the more serious stuff, now we get to stage 3. And stage 3 is pretty massive. It's a pretty important signal, and the signal is, let's start doing this. Let's start implementing this. And at this stage, we are stopping to sort of deal with the weirdly metaphysical issues of how to design something and start getting into how is it being implemented, how is it being used, what is, for example, the amount of extra megabytes that you'd have to ship and so on. So browsers start implementing things. They start shipping things behind a flag so that people don't depend on something just yet. And this is usually the stage at which you get the most hype. You get to hear about things and try them out. Temporal is stage 3. Fans of Temporal here? OK, not enough. But it's a very good proposal. Check it out. But that's stage 3, and it should hopefully be arriving to your JS runtime soon. And then there's stage 4. So stage 4 is when we finally conclude working on something. We decide that we have had all the time we needed to sort of test this proposal, and we have decided that it's a positive feature in the language. It's added to the spec, and it's made part of the next release. Array buffer transfer is a very cool stage 4 proposal. Please check it out. There's also set methods that allows you to have all of these interesting methods on sets. If you're a fan of set theory, then you might be missing them, and now they're here. So there's a lot of stage 4 proposals. We keep adding new ones as we can. But yeah, this is kind of the success case of standardization. Everything that ends up here is, not only added to the language, but has gone through all of this process to make sure that it's done responsibly. And later this month, we're going to publish ECMAScript 2024. I don't know if you care, or you actually just use the ESNext in whatever tool that you use. But we make yearly releases of the spec, and there's going to be one later this month. But before I go on, I would like to say there's so many interesting ways to get involved, and we'd love to have you on board. I think the committee could always use more fresh perspectives, and it could always use more hands. So I implore you to work with us and just ask important questions. I think there's a lot of value in that. But yeah, I hope you feel more empowered to just go in and start yelling than you were in the beginning of this presentation. But thank you.
Okay, thank you, Ujjwal. So you've heard all about how the committee works. So if you're thinking about those questions for later on with the panel, you can go into the lower level details now you've had the committee introduced. Next up, we have Shane Carr, who works at Google on internationalization. He's also a chair of our second task group in TC39, working on the internationalization standard there. And Shane is here today to talk about polyfills in WebAssembly.
Thank you so much. I'm going to do the thing that everyone has done and be like, how does slides work? Let me try this one more time.
Let me know if you need a joke. Okay, so my favorite joke. You know about Boolean type coercions? We always like to see the WAT talks where they're just showing off crazy type coercions. Do you know what, if you try to get a Boolean, and you start with the object wrappers. If you say, give me a new Boolean of false, so you're creating a new Boolean of false, it's very funny. Do you know why it's funny? Because it's true.
And that's perfect timing, because I think I managed to get my slides to show up. So excellent. Thank you, everyone. And thank you for the hosts for bringing everyone together for this awesome event. This is me. My name's Shane Carr. I'm, as Rob and Ujjwal already mentioned, the convener of the TC39 TG2. That's the Internationalization Working Group. I'm also the chair of the IC4X Technical Committee in Unicode. And I work at Internationalization Engineering at Google, but this talk is not on behalf of Google. So without further ado, let's dive right in. So before I came to Finland, this is my first time in this country. I took some Duolingo to learn some key phrases. This is one phrase I learned. Suomi on kaunis maa. Finland is a beautiful country, and I've definitely experienced that. This was my plane arriving at about midnight. I got some of the midnight sun. And I also got to visit Turku a little bit earlier in the week, and I met the statue of this fellow named Mikael Agricola, who turns out to be the one of the founding fathers of the written language in Finland, which really relates to what I do, which is internationalization. Internationalization is I followed by 18 letters followed by N, because as programmers we love to abbreviate things and make them a little bit shorter and smaller. So what is internationalization? This is just an example of the screenshots of this page on YouTube. I have it in English on the left and in Japanese on the right, and you can see how some strings change from the left to the right. One thing that I think is interesting here is large units of numbers. When you do compact decimal notation, like you can see on the right, is in units of 10,000 instead of units of, 4 groups, yeah. Units of 10,000 instead of units of 1,000 when you do, compact decimal notation. So there's a lot of really interesting challenges when it comes to internationalization. Here's a few more examples of internationalization. One thing I love to ask people when I get in conversations with them is name a language, and I'll tell you one thing that's interesting or challenging about it. For Finnish, the thing I'll point out is on the top right, collation. You have the word ä, which is normally would be less than Z, but in this case it's actually greater because of the way the language works, and it's sorted after it in the dictionary. So yeah, these are just all examples of different kinds of things we can do. Let me talk a little bit about how internationalization works. I call this the I to N stack. On the bottom, we've got Unicode, which is a standards organization, kind of like ECMA, but in this case, it's really focused on building these foundational algorithms for things like character sets, for things like scripts, writing systems, and so forth. Sitting on top of Unicode, we've got CLDR, the Common Locale Data Repository, which has data for hundreds of locales, specs, things like message format, person names, keyboards. On top of CLDR, we've got ICU, the international components for Unicode, which implements the algorithms with the data that's found in CLDR. On top of this, we've got the platform API, which is how we take the stuff that's in ICU and make it easy to use in your apps. ECMA 402 is an example of this. Android ICU is another example of this. And then finally, on the very top, we have your app, which can use this whole stack to do the internationalization and make great multilingual applications. So let's talk a little bit about what is ECMA 402. I already got a little bit of an intro to this, so I can go through these slides a little bit faster. But yeah, you already know about ECMA International. You know about ECMAScript. You know about JavaScript. You already learned a little bit about this. But yeah, we're the ECMA 402 task group, the TC39 TG2, where we really focus on reviewing these internationalization proposals. The way we work is we have a monthly call where we look at internationalization specific proposals. We give feedback on those, and then we go to the main TC39 plenary to basically bring forward our recommendations. So we're sort of like the subcommittee that sort of does the work, and then we bring it up to TC39 to get final approval for these new features. So I'll just give you a few examples of the types of features that you can find in internationalization APIs. So this here is until datetime format. It gives an example for how you can use it. I'm sure that many of you, hopefully many people in this room have used until datetime format before, or to locale string. Raise your hand if you've used these functions before. There you go. I love this. I love seeing this. That's almost 2/3 of the audience. So these are the functions that we work on standardizing and making work really well for you. Until segmenter is another example. This is a much newer API that we just added. This supports segmenting of grapheme clusters, which I'll explain a little bit later in the presentation, as well as words and sentences. And this is how you can use that here with an example of hello world. Coming soon is an until duration format. We already talked about how the stage process goes. So until duration format is a stage 3 proposal. This is what it might look like once it's landed. This will allow you to format durations. A much earlier stage proposal is this one, which is a stage 1 proposal. Smart unit preferences, this is what it might look like. This is an API that would allow you to pass in units and pass in quantities in one unit, but then be able to output them in the unit that's most appropriate for the context and the locale. So if you're measuring someone's person height, you can pass in 1.8 meters, but then if you're in the United States, that might get formatted as 5 feet 11 inches. That's some of the cool things that are coming with ECMA 402. Now I'm going to sort of pivot and talk about ICU4X. What is ICU4X? So IC4X, I showed you on the earlier slide. I talked about here's the different layers. I talked about your app. I talked about Unicode. I talked about ECMA 402. And now I want to talk a little bit about ICU and IC4X. So IC4X is an internationalization library that's portable, meaning that it's focused on running on all types of devices and all types of programming languages. It's lightweight, meaning that you can, the way we do that is by using compile time dead code elimination. It also means that it's able to run very efficiently on client-side applications. That's what we're here for. We love front end. We love things to work fast and efficiently on the front end. And then the third thing is that it's secure. We write in Rust, which is a modern memory-safe programming language that allows us to deploy to all these different platforms. So who are we developing IC4X? It's a technical committee within the Unicode consortium. These are the three main companies that have been contributing to the effort. We'd always love to get more involvement as well. So feel free to have your name or your company added to this list. We'd love to grow this project. So IC4X is tiny and fast. I'm just going to give you some pictures, some graphs to demonstrate how the effort that we focused on really building this internationalization library that runs really efficiently on the web platform and on the client side. This is if you need to do basic number formatting. I wrote a little program, IC4C and IC4X, in terms of binary size. And I know this looks very skewed, but I really did try to make this as fair of a comparison as I could. It just turns out that IC4C has a lot of logic because it basically ships a lot of its own code to handle data loading and locale normalization and things like that, which in Rust, a more modern programming language, are sort of handled by the compiler. This gives us a much smaller code size. The performance is also reflective. We are much faster for sort of these core fundamental operations. This here is more performance. This is for the segmenter, the word break segmenter. We get good performance with word break. Another thing that we have is, for example, we've been working a lot with the Skia and CanvasKit team. Raise your hand if you've heard or used Skia or CanvasKit before. A few people raised their hands. So this is basically a library that's written in WebAssembly that is basically a Canvas emulator. It needs to use ICU or IC4X in order to do line wrapping, word breaking, line breaking, in order to lay out text on canvas. ICU for C, which is the older library, had been consuming almost 20% of their entire WASM file, and when adopting IC4X, we were able to cut that almost in half. So that was quite a big accomplishment. It also works on servers. It turns out that a lot of the stuff we do to build really good front-end applications, making things really small, fast, and efficient, also reflects on big data centers. Because if you take a lot of these things that you build to be really, really good, really, really fast, really, really small, and deploy them at scale, you also get big wins in data centers. So this is an example of how that could work. So now I'm going to sort of get to the title of my talk, which is about ECMA 402 polyfills and ECMA 402 ponyfills. So what does this mean? A polyfill is a way that you sort of can patch functionality into the global object, into global this, in order to reflect the behavior that is maybe not yet available in the browsers that you're trying to target with your application. A ponyfill is very similar. It's just that instead of actually patching the global object, you just export it as a module that you use instead. There's a few ways that you can approach polyfills, and traditionally the first one has been very much more popular. Is you just write JavaScript code to do it for you. Like, that makes total sense. It works. You write a native JavaScript. Problem is this: when you take this approach, someone has to maintain this code. Someone has to keep it in sync with the specification, and it's basically a separate piece of code that's separate from what's actually going to end up shipping in the browser. So the other approach, which is what I'm going to focus on here, is can we actually look at taking the code that gets shipped in the browser and actually put that on the front end as your polyfill. So IC4X allows us to do that. One question is, it sounds great, but can we make it fast and efficient? I'm going to be talking about ponyfill because about shipping a separate module and how we can ship a separate module here. So my main sort of thesis of this talk is that IC4X is an ideal ponyfill because it gives the exact same code that's going to be eventually shipping in Chrome, in Firefox, in Safari, in Node.js, and Dino, and bringing that code into your application so that you can use it ahead of time. So this was a picture I showed earlier, the I10N stack. This is where the IC4X polyfill, ponyfill can fit in here. Basically, instead of calling through the platform API, if it's not yet available in your application, you can call ICU directly. So you get the same identical behavior either way. So I'll move right along, talk about an example of how we can use IC4X in JavaScript via WebAssembly. So how does it actually work fundamentally, and how do we actually make this fast and efficient? So IC4X has its own custom WASM bindings written in Rust. We focus really on how can we make this with optimal code size and performance. We went back to the fundamentals. We went back. We stripped out everything, all the machinery that you would normally use to build a WebAssembly application, so that we can focus on what do we actually need. What are the essentials? So we didn't use WASM bindgen, which is a popular library in Rust for doing this. We ended up building our own tool called Diplomat, which builds ergonomic JavaScript wrappers that are built on top of the CFFI. You can read more about it at that link. And if you see a little bit about how this flowchart works, we've got IC4X, which is written in Rust. We wrap that with these symbols in CFFI. This is where we get a little bit more technical. The next few slides are going to be a little technical because I wanted to actually show you how these things work. But yeah, the CFFI symbols are basically extern exported functions. Those get exported into a WASM file. In order to actually use those from WASM, we have a very thin Diplomat JavaScript wrapper on top of those, and then you can use it in your app. I also will point out that Dart is another one of our targets. This is a front-end conference, not specifically a JavaScript conference. So if you use Flutter, which is another really great cross-platform web framework, you can use IC4X to do your internationalization there as well. I gave a lightning talk about this yesterday at the Flutter meetup. You can Google for Intel for X to learn more about that. So, code. We love code. OK, so this is the QR code on the right just brings you to our GitHub repository where I have this code published in case you want to go ahead and look at it later. But this is a code that shows you how we managed to wrap the WebAssembly module into JavaScript code. So this is code that's generated. You never have to touch this code. I just sort of wanted to show it to you so you can see how it works. So WASM is the WebAssembly module. It has various functions. This is the function that we export that allocates memory inside of the WASM linear memory space, which again is not shared with JavaScript. If you don't know how WASM works, it basically is its own separate memory space that works on its own. And in order to read and write from it, you have to use basically array buffer APIs in order to get things back and forth. When we want to call this function, the IC4X grapheme cluster segmenter, in order to create a grapheme cluster segmenter, we have to go ahead and create some space over on the WASM side. We call our function. And then if it was successful, we go ahead and read the data out of the allocation. And then we go ahead and free the allocation and then return it. So this is the extent of the wrapper code so that you don't have to worry about doing this kind of low-level stuff. Here's what you might actually use on your end. So this is the actual code that is available for end users. In this case, I went ahead and exported this class called segmenter impl IC4X from this little package that I made. I give it a little string, and then I set up my segmenter using ECMA 402 APIs. And I go ahead and collect all the segments, and these are the segments I get. There's 3 grapheme clusters. Raise your hand if you know what a grapheme cluster is. 3 people out of the audience know what a grapheme cluster is. It's basically a character that has diacritics associated with it. So for example, in a lot of European languages, you might have an accent or an umlaut or something like that. Those are 2 separate code points, but it's one grapheme cluster. So in a lot of these, like South Asian languages, like this one here, there might actually be 4 or 5 diacritics that create a grapheme cluster, and that's why this is of interest in order to do this kind of calculation. Basically, the effect is that when you hit the arrow key on your keyboard, you will go 1 grapheme cluster to the right or to the left when you hit your arrow key. So that's the application for a grapheme cluster segmenter. So that's how that works. And of course, the reason we spend time doing this is because we look at the numbers. This all sounds great and cool, but does it actually work? These are the performance and the size for this. So when I tested this in Node version 22, and I used ECMAScript directly, I was able to segment a string that was 100,000 graphemes long in about 35 milliseconds. When I used this IC4X code, I did it in 7 milliseconds, which actually surprised me. I wasn't expecting it to be less than the ECMAScript. I'm going to have to investigate that later. I didn't quite figure out why there's such a big differential there, but you know, I think that this does illustrate that, look, WebAssembly is actually fast. Something I hear a lot from people is that, like, well, when I call over the WebAssembly boundary, it's expensive because I have to do this copying in and out of the array buffer all the time, and like that has an impact on my app. I'm kind of afraid to do that because I think it's going to be slow. This is my counterexample. Like, this is a text-heavy API. We're sending over, like, we're sending 100,000 characters over the WASM boundary, and it still gives us really good performance. So I don't know what's wrong with Node 18, but I'm just glad they fixed whatever performance problem that was in Node 20. So I can also show you the code size. So you know, we heard earlier about when you build green applications on the front end, what you want to do is reduce the amount of bytes sent over the wire. That's one of the biggest things you can do to make your app you know, greener and more sustainable. Well, you know, that's why we focus on, can we do this efficiently with as few kilobytes as possible sent over the wire. So these are the sizes for the code and the WASM. Yeah, you know, we always focus on getting these numbers down. I think the point that they're at now, where we're talking, you know, in terms of, you know, single to double digits of kilobytes, is quite respectable when you look at some of these really big, heavy frameworks that a lot of people are using on the front end. So, you know, we always look on getting these numbers down, but they're already quite respectable. So, yeah, those are some numbers, and I'll just go ahead and, with a couple of minutes here, give you a little live demo, hopefully. So I have my code checked out in this little project here, and I can go ahead and run my code. Yeah, clear their console. I'll go ahead and run Node with my code. And I took this string, which fortunately my terminal doesn't show it very well, but there actually are 3 characters there, and it shows you those same breakpoints that you saw on the previous screen. It also reproduces the performance characteristics that you just saw. Just to demonstrate how that works, I'll go ahead and also go ahead and here's the actual code. I'll go ahead and change the string. So instead of using this string, I'll go ahead and do this one. Hello, Finland, right? OK, and then I'll go back to the terminal. I can go ahead and segment that string. In this case, it has more, I'll scroll up a little bit, but it has more breakpoints. In this case, these are just these are 1 code unit apiece, so it just gives us 0, 1, 2, 3, 4, 5, 6, 7. But then when we get to the flag emoji, which again is not rendered very well because it's a terminal, it jumps from 7 to 11. So that's the flag emoji grapheme cluster right there at the end. Cool. OK, let me go back to my slides. I'll get rid of that. I'll get rid of this. And there's my slides. My slides are back. So that's the live demo. So one other slide I'll just show on the screen. You don't have to pay attention to that code. It's not code that I'm proud of. But the point is that it works. But there's pain points when you use WASM. But the pain points are not performance. They're not code size. I already showed you those. But there are some pain points, just to be transparent here. One is that WebAssembly is very asynchronous, which means that, you know, if you use JavaScript, if you use ECMAScript modules, ESM, you end up getting a lot of top-level awaits in your code and things like this. There's some support for it in bundlers, but it's a little bit more limited. If you're using something like Webpack or whatever, like it works, but it's a little bit more limited. It's not super polished. TC39 is working on a proposal to add better ways to include WASM through ESM, but it's not yet implemented, which means that at least right now, hopefully in a year, the 3rd bullet point will go away. But right now, there's not a standard way to include it. You have to have basically ship a blob of code like that on the right. Also, like tooling is optimized for monolith WASM, meaning like if you're shipping multiple polyfills, it's better to have them in a single WASM file than to have like 5 or 6 WASM files separately, just because of the way the memory model works. But hey, it works, and I showed you the code size. Like, we can continue to make this better, and I'm working as much as I can in these standards bodies to make this work better. But it already works, and you can go do it today. You don't have to wait anymore. So This is my last slide by conclusion. These QR codes are my various social if you'd like to follow me on Mastodon or anything like that. But WebAssembly lets us bring real implementation code to the web to support new features. And IC4X is a great option for doing that on Intel proposals. So yeah, thank you all for hosting me. Again, thanks for the host for this beautiful venue. I don't think I've ever given a talk at a venue that's this beautiful before, so really appreciate that, and thank you all.
Thank you, Shane. So next up, we have Daniel Ehrenberg, also known as Little Dan on the internet, here to talk about signals. Dan works at Bloomberg on JavaScript infrastructure and tooling. And whilst he's setting up, I will also just give you a tip. If you want to become a faster TypeScript developer, you just need to code anytime, any place, anywhere. Over to you, Dan.
Hi, everybody. Thanks so much for having me here. So I wanted to talk about standardizing signals in TC39. This is a particular proposal that I'm working on with a number of other colleagues. We have a logo for it even, that you could see, drawn by Anna from the Ember community. So I'm a developer at Bloomberg, previously at companies where Shane and Ujjwal worked, working in the JavaScript infrastructure and tooling team to modernize JavaScript usage in developing the Bloomberg terminal. I've been part of TC39 since 2016, and that gave me the opportunity to work on a number of proposals like BigInt and private fields and methods. I'm also working in ECMA administration, so ECMA International being the body that governs the way that TC39 works at this very high level, allowing it to produce standards, and so helping to make sure that that provides a good support mechanism. And I live in New York City after previously living in coastal Catalonia. That's the very small piece of coastline that my town has. It's sort of triangle-shaped. The Bloomberg terminal is a piece of software that lets financial industry professionals get information about financial markets to help facilitate decision-making. It has a very complex UI, and internally, it's based on Chromium. So even though it's not a website, a lot of these important web front-end techniques are still relevant. And the core of these techniques, many of them, if you're maintaining a front-end application with a UI framework, is to keep the DOM up to date with the data. So we have all these big graphs and charts and tables, and how do we make sure that as the data is delivered, it can be put on the screen? And the answer provided by typical modern UI frameworks is to make sure that the view, the stuff on the screen, is a pure function of the model. So model view controller, kind of the old way to talk about this stuff, but it's representing the state. So if it's a function that's what translates from the data to the screen, how do we evaluate that function? There are two basic techniques. One is traditionally called immediate mode, sometimes used to render video games, where each frame, each time the screen is going to show something, you re-render the whole screen, and then you bleed it onto the screen. You just copy all the information straight to the screen. The other paradigm is retained mode, where by default the screen continues to show what it showed last frame, but then you just change the parts that should change. So the goal of fine-grained pull-based reactivity is to somehow bridge these. We want retained mode performance while having immediate mode semantics. We want it to be that you program in terms of what is the function from the state to the DOM, and then instead it only reevaluates and changes the little parts of it that are relevant to change. And signals are a mechanism that we're proposing to do this. Signals consist of these little cells of data. So instead of just dealing with variables, you deal with a signal so that it can help track what's changing. Signals in this API that we're proposing in TC39 have a constructor and a get method. In computed signals have a constructor where you pass a function, and then you can get it, and getting it just calls that function. And then there's a watcher, which allows you to watch changes to computed or state signal. So I'm going to go through an example of how this can be used to build a UI. The thing about having signals as part of a shared standard is that now the model can be independent of the view. We want to enable model-view separation, and once they're independent, they should also be independent of frameworks as well. So here's an example of a simple reactive data structure. We have a counter, and you can get the counter or increment the counter, or see whether it's even or odd. So by calculating some of these things in computed signals, this information is cached so that it can be updated on the screen only when necessary. And it could be integrated into different frameworks like Preact and Vue, which do already have sort of signal-based rendering models, just into their existing template systems. So these templating systems make it a declarative functional way to show what your UI contains just by filling in the blanks. And it makes it so that when you click the button, the right piece is the UI update. But for example, if we made a +2 button, we incremented it twice, it would leave the parity in place once it can calculate that the is-even thing didn't change. It doesn't even need to recalculate parity because the caching can recognize the similarity. So there are a number of different algorithms that you can use to evaluate signals. In particular, why is it an algorithm at all? Because you might think, okay, I update seconds, and then that goes to the two things that use it and updates them, and then recursively. So then that should make sure everything is updated. But this algorithm is actually broken. So in the naive, eager, push-based algorithm, if you have your state, which is seconds, and then you go to the things that use it, which is this G and T. And this example is just from a very well-written Wikipedia article on reactivity. If you update G first, because you're just going to visit the children in arbitrary order, then it's actually going to see, after the first evaluation, so this gets initialized to 1, and then this becomes initialized to true. But if you update seconds, so it becomes 1 and 1, then G becomes false momentarily until later it updates T. So this is called a glitch because the program gets into an inconsistent state. And the solution is to use pull-based evaluation and topological sorting of dependencies. So instead of recalculating when we write to seconds, instead it recalculates when someone tries to read G. And it does this by looking at all the dependencies, recursing upward, and then topologically sorting them so that nothing is used before it's recalculated. That ensures that the consistency problems are solved. To do this, you have to be able to track invalidation. And there are a couple different algorithms for tracking invalidation. One is to use generation numbers. So every time something changes, you kind of count up on a global counter. And you can see if something is invalid, a computed signal is invalid, if it depends on something that's newer than it. Another algorithm is to kind of push dirtiness through these forward edges. So if you change A, and then these various other things depend on it, then that could mark C and B dirty, and the subsequent things might be dirty, depending on whether C or B evaluates to new values. And then when reading F, it will gradually iterate through the graph, reevaluating things until everything is understood. The important thing is there are multiple algorithms, but they have the same observable behavior. When I say observable, I mean in those computed signals, there are JavaScript callbacks, and those JavaScript callbacks get run in the same order and the same number of times at the same time, regardless of which algorithm is used. So ultimately, we have a situation where many frameworks independently reinvented this, and it's sort of like the natural phenomenon of carnicization, which is where many different crustaceans independently evolved a similar body plan to crabs because it works well for certain lifestyles. And many frameworks independently arrived at signals. They were all trying to solve this problem that I described at the beginning, how to make sure that the view is a function of the model without reevaluating that function every single time. And as they encountered problems like the glitch problem and how to accurately maintain the invalidation of signals to figure out what to recompute, fixing different bugs over time, this took people a long time to figure out, but eventually people came to really the same or very similar common answers. So we all got together to standardize the result, to share our common answer. So what does it mean to standardize signals? There was a project more than 10 years ago at this point called Promises A+. And that project was about standardizing promises. So how many people here have heard of promises? Okay, everybody, or almost. So great. Promises are ubiquitous in JavaScript because anything you want to do asynchronously returns a promise. In the old days, you had a callback that was passed in, but this becomes kind of unwieldy, becomes this callback hell people talked about. And so people wanted to, instead of having a callback that's called with a result, have a value that represents this pending result. And many different frameworks independently invented their own kind of promise. But they had somewhat similar APIs. They all had this then method to chain the results on. So the Promises A+ was a community standard to unify all the promise interfaces and make them compatible with each other. It was finding both a common interface and common meaning. And this was used, this was deployed with everybody converging even before it became part of the language. And then it became obvious if we want promises in JavaScript, we should align with that. But with signals, we're really focusing on having common algorithms for this underlying reactivity graph. So different frameworks do have different ways of looking at things, but it's important that everyone can use this same model underneath, and then they can put different skins on top, and it's actually okay to differ. So the changes that engineers will need to apply when adopting standard signals will be nothing. Migration will be transparently handled by frameworks. And we're doing this effort through TC39. The JavaScript Standards Committee is part of ECMA. Earlier, we heard from Ujwal about how TC39 works. So just in April, I worked with people from Jatin, from Google, and Yehuda from Heroku on presenting signals to the JavaScript Standards Committee. And it achieved stage 1. So at this point, signals are on the table as something under discussion, but they're still very early discussion. So at this early stage, we're focusing on prototyping implementations of signals in order to figure out what to do, to see what we can get right or wrong about it. For example, we have a signal polyfill. We have an implementation of signals in JavaScript. This isn't a kind of a normal polyfill that's put onto the global object, but it's just a library that you can use that implements the signal API. And yeah, I worked on it with some colleagues at Bloomberg based on the Angular signals implementation. It's just kind of a wrapper around Angular signals. But we're encouraging more experimentation with other kinds of polyfills as well. You can play with it on NPM if you want, but please don't use it in production. It is buggy and unstable, and the API will change in the future. There are also libraries that can be built on top of signals. For the signals util library lets you, for example, decorate a field, even a private field, with TC39 standard decorators, and make it so that when you read or write that field, it's underneath a signal. So we don't actually want you to write .get and .set all around your code. There are various different abstractions that could be used, and this is just one of many possibilities for that. Or you could use a reactive object. This is common in many frameworks today that you, like ref in Vue. You can make an object which becomes a proxy, such that when you read or write properties, those are tracked as signals. So due to the auto-tracking mechanism, as we call it, within signals, there doesn't have to be explicit threading through of the fact that there are signals, but the system just watches, and it can see that it's writing to a signal here when you write to a property of something that is a signal object. So signal utils you could also download and play with from NPM. And the other side of the coin is integrating signals into frameworks. So frameworks being things like Vue or Preact that help you render to HTML, to the DOM, your state. One experiment was done with integrating signals into Ember, but experiments have also been done with Vue and Lit and several other frameworks. And they found, actually part of the polyfill was very slow. The part that I wrote, actually. So here's some graphs showing that. And also it's buggy, so there's room for improvement. You can work around these bugs, though. So yeah, this crab is kind of cooked. It's not in the perfect state, but we can improve things. We can. There's a lot to do, and I would encourage any of you who are interested to join the effort. Whether it is in terms of trying to use signals, working on the polyfill or the tests, giving feedback on anything. There's many different possible coding tasks or documentation tasks if anyone wants to join this open source project. So if you're interested, please join the Discord or Matrix channels that we have in a pinned issue on the repository. You can also join ECMA and TC39 to participate, though you don't need to be a member of ECMA to participate. And please come talk to me if you're interested in getting involved. So thank you, everyone.
Thank you, Dan. All right, please stay on the stage. It is now time for the TC39 panel. So you'll see some familiar faces. We have Ujwal, we have Shane, we have Dan, and also coming up on stage right now, we have Michael. Michael is a distinguished engineer at Shape Security, which is part of F5. And he's been working on TC39 for a long time now. So I'll be asking the questions today. And so I think we've heard a lot about how the committee works. I hope everyone has the link to the Slido, because that's where I'll be sourcing questions from. So I've got that up here. And I can see you're already voting on these questions, which is good. I guess, first of all, just start off so you can lead in. Which proposals that are currently active in committee are you most excited about?
Well, aside from signals, I'm very excited about the pattern matching proposal. Pattern matching will bring the ability of JavaScript to destructure data structures, and it's a common feature in functional programming that just makes a lot of normal, everyday data structure manipulation cleaner and simpler.
Yeah, I'd say I'm very excited about the temporal proposal. This is bringing a new datetime API into the ECMAScript ecosystem. I've worked extensively as a champion on this proposal to make it very install-friendly, ITNN friendly, and I think it's really going to solve a huge gap that we currently have in ECMAScript by bringing a really good, solid datetime handling library.
Yeah, I'm personally very excited about message format. It's a new, relatively effort in that it has only been, 5 years in the making? No, but more seriously, it is in many ways the final boss of internationalization proposals. We've spent many years building the building blocks, and it's a full-blown internationalization system, and I'm very happy that we're standardizing it.
For me, if I'm allowed to say my own proposals, then it would be iterator helpers, a bunch of methods added to iterator.prototype. But if I don't, I would say it's probably base64 encoding and decoding. Very excited about that.
Feel free to whoop and cheer when you hear your favorite proposals. I cannot guarantee it will help them advance, but it cannot hurt.
You can also boo if you hear a proposal that you don't like.
We do like feedback, yes. All right, so just going to the crowdsourced questions. So, Shane, I think this might be going to you, or at least, which is that people are asking, temporal, people have waited for this for a long time. It's been stuck at stage 3 for years and years, and it's still not standardized. Isn't it about time?
Yeah, I'm really excited to see temporal land, as I'm sure many of you are as well. There's been a lot of progress actually just in the last several months. As the champions group, we've gotten feedback from browsers that the requirements that we as the champions gave in the proposal that reached stage 3 were just were very difficult for them to implement. So what we just did just this last week was put forward some changes to the temporal proposal to simplify the API. We simplified it by about 20%. We still have just about all the functionality that we had before, but we made some changes that make it much easier for browsers to implement. I know that Jason in the audience has also been very active in this effort, as well as getting some implementations in Rust and C++. I had talked earlier about how IC4X is a really good polyfill for Intel proposals. We also are working on one that will work for temporal as well. This will allow browsers to more easily link a pre-existing native library into the browsers that we can also maybe even use as a polyfill as well. So once all these pieces are put together, I think that you're going to start seeing this shipping, because we're definitely very actively working on how can we make it more feasible for browsers to land. So that's the status that we're in at stage 3.
Great. Anything more to add on temporal?
Well, I think one of the important things when it comes to temporal is to just think about the kind of progress we had made. I mean, temporal started with a very simple but powerful idea of fixing date. I think we've gone well beyond that, where we are doing some things that are truly unique in that we had to go back and fix the timestamp format. Among other things, I think the fact that temporal allows you to use any non-Gregorian calendar, most of the CLDR supported calendars, I think that's pretty powerful, and it's taking a while because it's one of the most complex things we've done in a long time.
Yeah, I think in lines of spec text, temporal is similar in size to all of ES6. So it's a big deal. Okay, thank you. All right, so on to spicy questions. What features or designs does TC39 regret? Which I guess we're asking individually, because these are individual opinions. Who would like to go first? Michael?
Well, I can start with the easy answer there, which is that the committee has actually been recently reaching agreement a number of times on some API design design decisions that we've been consistent about in the past, but are now breaking with. In particular, we don't want some implicit conversions to be happening when you pass in values of unexpected types into built-in APIs. So yeah, we've now started a document on our normative conventions, which you can look at. Again, all of our work is in the open, so you can go look at that on our GitHub. And we're starting to make a break from those patterns that were problematic, that we were following only for consistency purposes, but really were hurting the community more than helping.
I agree. I think all of the type coercion stuff is useful for a certain scale of applications, but for most practical JavaScript code bases, just gets very confusing. I think the way we're designing APIs these days makes it sort of cleaner and easier to reason about.
One thing that continues to annoy me is how the date.parse is just a complete, it's completely seems random how it works in different browsers. It's not really a very consistent way. I think that temporal is going to move us very much in the right direction here. But yeah, the fact that like basically date.parse in every browser works completely differently is definitely a pain point that I wish we could clean up.
So aside from the type coercions, for example, any JavaScript value like undefined becoming nan when you try to use it in arithmetic rather than throwing an exception, I would say one thing I don't like so much was added in ES6, which was symbol species. Many of the array methods were retrofitted with this capability to produce other sorts of types that are not arrays in a way that's very complicated to implement. And I think one of the things that we've decided more recently is that new features going forward won't have symbol species. So we're able to reverse these decisions only partially because we can only do so with respect to new features usually due to our need to maintain compatibility with the web, which we call web compatibility. We can break some things sometimes as long as the web, whatever that means, doesn't depend on it too much. But usually that means just keeping existing things the same.
I have one more. Well, I have many more, but I have one more I do really want to mention, which is another one that we've actually recently kind of come to consensus on within committee, which is the default iterability of strings. This causes so many problems, and really was a bad idea from the get-go. As Shane saw with Segmenter, there's many different ways you could like split up strings and iterate over parts of it, and we just chose one, code points, as the default, and oftentimes that's not what you want. So we really wish we could undo that one.
So we've heard there is still some hope, so long as we don't break the web. That's the slogan. All right. Next up. Well, this is a related topic. Since JavaScript has to stay backwards compatible, is there a chance of a new web language being created from the standards instead of fixing JavaScript?
I don't think that will happen anytime soon. You can't never say never, but there was this hope that Dart would become that future web language, and before that, the VB scripts supported on the web in Internet Explorer, even though it was dominant at the time, it did not catch on. I think JavaScript is, I think it's a good programming language, or definitely at least good enough. So for another language to catch on, it would have to solve some problem that JavaScript doesn't solve well enough. So it's hard for me to see why that would happen.
One thing I'll add there is, we have WebAssembly, as I was just showing, which basically allows any programming language to be deployed on the web. So I think that this is an approach that a lot of the engines have sort of settled on as like how we can get more languages to be able to be deployed here. In terms of like the native scripting language, I think JavaScript has really shown over the last a couple decades that it's a really solid language that it has its flaws, but like it gets the job done. And I think that WebAssembly is sort of the alternative that allows you to basically deploy anything you want on the web platform.
Yeah, I think that this possibility is very remote and getting more every day. I think JavaScript developers have more or less accepted the fact that despite writing JavaScript, the JavaScript they run is maybe not the JavaScript they're writing, and I think this makes us, not care as much about replacing JavaScript. We can always write on top of it, and it's a solid language for the web, and the ecosystem benefits are just so strong that why would you switch to something from scratch?
All right, thank you.
I want to mention that this wasn't inevitable that JavaScript remain such a strong language. It's the combination of DC39 beginning to advance again with ES6 and later editions, as well as TypeScript, which make JavaScript a vibrant enough language that the sort of competitors in this space, like CoffeeScript, have somewhat fallen away over time. And so we have to keep up progress in order to maintain the relevance of JavaScript. Also, when Ujjwal talks about ecosystem, I think there's just a lot of benefits to many people using the same programming language. There's a lot of cost to introducing another language.
Thank you. So, Shane, I think you've been doing a good selling job in your talk, because we've got a specific question already of, should I use ICU for X to do my React application translations?
That's a good question. So I'll take a step back first and say that in the TC39 TG2, which is the standards body that we have, we try to attract stakeholders from many different platforms, and we've had some people from React as well as many other web frameworks join our calls. I'll also use this as an opportunity to extend the invitation. One type of stakeholder that we don't have enough of in our TG2 conversations are actual users, like all of you. So this is an open invitation if you want to get more involved. All you have to do is go to the ECMA 402 GitHub page, and there's instructions on how you can personally get more involved here. Working with the different web frameworks, has definitely been a focus for our work in ECMA 402. Given that IC4X targets on building a compatible API with ECMA 402, that does mean that it's a very natural choice. I know that there's also other approaches, JavaScript-only approaches that could work. But definitely IC4X is a very viable option, especially if you need to do some of the things that I was showing on the slides.
If you're interested in translating React app, I'm assuming that means localizing it into various locales. I would suggest you to explore message format instead as well. Message format is a relatively new feature I think it's being worked on right now in ICU4X, but we have a JavaScript polyfill for it ready, and we are working on different popular translation libraries like the one that you might be using at the moment to add support for it, but it's a higher level of abstraction that would allow you to have this format, and the underlying tool might be ICU4X or some JavaScript library.
One other thing I'll just add there is if you are looking at using IC4X in your projects or at your company, we're very open and hopefully friendly. Just please contact anyone from the IC4X team, and we always love to learn more about how people are using this library in the wild.
I also wanted to mention that ICU4X is maybe the best for advanced cases, but for a lot of well-established APIs, we have the Intel library that's built into JavaScript that you can use without installing anything, with an even smaller download size. So if that meets your needs, then it's probably best to start with the platform solution and then expand to additional libraries where needed. Also, consider ecosystem libraries like Format.js, which build off of these Intel libraries and provide a higher level interface.
Thank you. So we're back to a spicy question. Do you have to manage pressure from commercial interests, e.g. Google V8, Apple with JSC? And how do you do that in the standards process? Who would like to take that one?
I can say a little bit, I guess, which is that, you know, I sort of, you know, like I work at this company called Google, but I'm also not on the V8 team. I'm on the internationalization team. So, like, you know, a lot of the times, like, you know, the things that I'm trying to get out of proposals, making them better for global multilingual users are not necessarily the things like, you know, like even at V8 that, you know, V8 is looking for things that are small and efficient and things like that. So there's definitely a lot of, you know, trade-offs that go into any of these proposals. I think we see with ECMAScript, or sorry, with temporal and ECMAScript. With ECMAScript temporal, we've seen how, like, you know, the ideal way that we would like to do datetime formatting ended up being sort of challenging for browsers to implement, and I think that sort of drove, you know, it's a lot of these changes that we just saw this week. But I do think that all the browsers are very cooperative. With the body, are very active in TC39, and, you know, understand that, you know, there's not a single stakeholder who really gets to make these decisions.
I'll just add that you know, it is an inherently difficult problem because everybody has different motivation, but our process has been developed over, you know, the course of many years to, you know, tackle this specific problem, and, you know, it allows us to iteratively approach you know, a solution that is agreeable to everyone involved.
Right. I'd also add our process is very conservative. In particular, because we need consensus to add things to JavaScript, as Ujwal explained, and because changes need to be web compatible, there's quite a high bar to changing JavaScript. And this means that the only way that you can work on a committee is to be a rigorous technical professional. So this is kind of common across standards in general, that although people come from different organizations, it's not like you forget who they work for, but you try to leave it aside and try to focus on the common technical project. And I think we do a pretty good job of that in TC39.
Yeah, the benefits of consensus. You cannot whip the vote when there is no vote. Yeah. All right. Next up. Why do you keep calling JavaScript ECMAScript? What's the deal with that?
There may or may not be a trademark for JavaScript. I mean, Oracle claims they have a trademark on it, and we'll see. For now, ECMA has the trademark on ECMAScript. So as long as JavaScript has been standardized, it was always the ECMAScript standard. And I think it's a fair reminder that ECMA has a constructive role in JavaScript.
Thank you, Dan. Juho, yes.
Yes, thank you. So I have a little commercial announcement about the miracle of horizontal scaling. It's the moment. So in your back, now you have 2 sticks. You can make the sticks much stronger when you combine them. So if you find glue or tape or whatever, now it's twice as good. So if you want to make a twice as good thing for yourself, or stick, twice as strong stick, you can get them from our info desk. And the next point is that, because some people, I know you want coffee. If you want coffee, you can go out. If you want to stay here and enjoy the panel, you can stay here. So now go for your coffee or stay here.
We will not be offended if you choose coffee. That would be very understandable. I heard that Finns drink the most coffee in the world. This is not a joke. This is just a fact that it's like 12 kilograms of coffee beans per person per year. So we understand that you enjoy it.
I've been very impressed by the quality of coffee while visiting Finland. The normal drip coffee.
Yep. Okay, for those of you who wish to stay, we shall continue with the questions. So, another Shane-inspired question. What suggestions do you have as to what kind of things I should write as a polyfill with WebAssembly and use them in JS.
Yeah, I promise I didn't plant any questions. I really didn't. But yeah, I think that's some of these heavier library features that we're adding, like Intel Segmenter, was sort of like the perfect example for where WebAssembly makes a lot of sense, right? Because it's very data heavy of an algorithm to implement. I think that some of these other libraries that we're adding, maybe perhaps duration formats is another one we're adding. I think message format is one that could be compelling to have implemented in IC4X. I think that there's also some counterexamples. Like I think probably signals probably makes sense to have a JavaScript direct implementation. I wouldn't say that there's a one-size-fits-all solution here. The purpose of my presentation was to show that look, this is a thing that I think that people haven't done enough on the web platform, which is really try to integrate ECMAScript and WebAssembly together, because they really can work together in harmony. And I think that's something that people haven't done enough of. And I'm just sort of showing an example for how this actually can get the job done when it's the right tool for the job.
Actually, with the WebAssembly GC support, I think WebAssembly would be a great way to implement signals, and would encourage anyone who wants to contribute a signal polyfill in WebAssembly. I want to emphasize part of what Shane said. ICU4X is looking for an implementation of message format. If you want to learn Rust and WebAssembly, this would be a great project to get started on. There are many strong, they're very good at mentoring people and supporting efforts like this.
Okay, thank you. All right, a question around task groups. What determines when and what task groups are created? For example, why was a task group created for source maps?
So I worked on creating the source maps task group with John Cooperman here.
John, please stand up and wave.
Kind of co-convening the group. And all it takes is the committee TC39 to agree, yes, we want to start a task group, and then there's the task group. And for source maps, we decided to create a separate group because we thought that it is just a separate thread of investigation. So TG4 for source maps works a little bit differently from TG2 in that we're doing our development completely separately, and then we're working on bringing the final result to TC39 plenary. TG2, which I worked on setting up some years ago before Shane took over, is, with this model of working on something and then proposing it to TC39. I think both models work well, and ultimately task groups can allow TC39 to scale its behavior to more projects than would be capable of doing if everything had to happen in plenary.
I heard that JavaScript developers kept getting lost, so we thought we'll give them a map to find their source. Moving on.
Yeah, that's why we convened TG4, yes. But by the way, it's also possible and quite common that we work in what you could consider ad hoc groups. They're just people who get together and talk about things. And most of the meetings on that calendar were ad hoc meetings rather than task groups. Task groups are more appropriate if you have sort of a long-standing program of work that you're going to continue among a set of people.
So a question about our process in general. What is the average time it takes for a proposal to pass all the stages?
I think there's no good answer to that. I think, they're all over the place. It really depends on the proposal and the kind of, the cast that it brings together to sort of, be focused on. There's certain proposals that have been small to medium size and have really blazed through. There's many reasons for that. It could be that it's quite straightforward what the problem space is and what the solution needs to be. And other times there's proposals like Temporal or Decorators, which are quite complex problem spaces, and it's difficult for us to get clarity on how exactly it should be defined. Maybe there's not a whole lot of agreement among the committee, and then we have to work on building that kind of consensus from the ground up. So I think it really depends on the proposal, and there's no like generalized answer that I can give.
Just to give an idea, though, so that we can work with like concrete numbers. Yeah, the smallest possible proposals with like a very direct, very obvious solution space is probably 6 months at the fastest. Whereas the longest proposals we work on, I mean, I've only been with committee 10 years, so I'm not sure. I'm not sure how long they could possibly last, but maybe like 7 years or so. But a medium-sized proposal, you're probably looking at like 2 to 3 years through the whole process from beginning to end.
Yeah, and the reason it's so hard to characterize the answer is because it's not like you submit a proposal and then a timer starts and then it becomes a standard. It all depends on, first, whether it's actually a good idea that we can have consensus on. So imagining it as a timer implies that it will eventually happen, but maybe we shouldn't do it. Or maybe the people in the group who started the proposal are busy with other things and they don't bring it back to committee until someone else comes and picks it up or until they find time again. There are all sorts of reasons for things taking different amounts of time. For example, we're considering decimal in TC39 now, and that was under consideration at the beginning of this century. It was considered for ES4 or even earlier than that, and we're still considering it. So there's no time limit. We're not saying no to decimal just because it's been taking a while, but it also wasn't even under continuous development.
All right, and on that subject of things that may not happen, we have a question. What happens when some browsers decide not to implement a feature?
Well, usually before a feature would even get to stage 3, which is the kind of stage at which you start expecting them to implement it, they have a lot of different areas, a lot of different venues to voice their concerns. I think the fact that we work very closely with our colleagues in different browser teams makes it kind of impossible. I mean, hypothetically it's possible, but we work very closely with them to address their concerns. And even within stage 3, we reserve this, like we were talking about what happened with Temporal, with us simplifying the proposal a bit. We reserve the ability to improve on proposals during stage 3 as well, listening to their concerns. So I think there's, no kind of, the process avoids this from ever happening.
Right. I think we have a good flow these days where if browsers are not interested in eventually implementing it, then they won't agree to stage 3. That is the ideal path and way of working together, and I think we've been delivering on that recently. One of the things that we started doing more recently is looking through our past proposals that are at stage 3 or 2 or 1 and checking in on where they are. There's maybe one stage 3 proposal that hasn't yet gotten much interest from browsers, and so we'll eventually be reconsidering, should it still be at stage 3? Is that an accurate way to consider its status? But we take these decisions slowly and carefully, and it would be an exceptional case.
All right, so I think we're nearly ready to wrap up. Maybe one last question. I think this is provoked by your talk, Dan. And the question is the signal reactive model always more efficient than the virtual DOM? Or are there trade-offs?
There may be trade-offs. In particular, when running the code for the first time, you have to do this auto-tracking and construct the signal graph. So traditionally, people have said, that takes too long, and virtual DOM should have a faster initial render. However, these days, people are thinking more in terms of SSR, where you have, it initially ships HTML, then it hydrates, or maybe it's presumability, but I think that's incremental hydration. So ultimately, the initial render should be handled by something like that, and hydration techniques have been developed for both signal-based systems and VDOM-based systems. So in general, there is cost to computed nodes and their caching, and sometimes it does make sense to recompute more things. This trade-off exists in React as well, with the React compiler now making certain decisions about which things to memoize and which things to not memoize. And I think it's subtle, but I still am optimistic that signal-based rendering is a good way to go about things.
All right, thank you, Dan. So yeah, let's wrap it up. Yeah, and I'll say thank you to our panelists here, Dan, Shane, Ujwal, and Michael.
if it works, let me also. The,
Hello. Bye. Bye. Bye, 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 bye.
Yes. Okay. Yeah. Please, Rachel. We are not formal about these things. You know, we're all friends. We can share a stage. Okay. People, it is a bittersweet moment. We're going to our last session of this conference, which at least for me is sad because it is my favorite conference of the year, and now I need to wait another year to come back here and do this all over again. But we've saved some really good stuff for last. I wouldn't say best for last because it's been wonderful as it is, but depending on your taste, you might find this one the most interesting session. We have another two people of the great London coding scene here. We have Rachel and Steve. And first off, I would like to introduce you to Rachel Neighbors. Let's give it up for Rachel.
Let me just see if this is connecting correctly, because I can't actually see my slides yet. Give it a minute, fingers crossed. Technical difficulties. Hang on a minute. That's all right. While he does that, I'm going to remove the earrings so that you don't have to hear the clacketing. Oh no, I used the wrong cord.
Yeah, that happens.
Classic me. Yeah, that was a USB cord, not an HDMI cord. All right, and yes, it's working. Yes. All right, thank you. Thank you so much for that introduction, Yanni. Yanni is a really cool dude. I moved to London, I met him, and I was like, that guy is really cool, and I want to know him. And then the pandemic happened, so we only got to sit down and have a real conversation at the speaker dinner a few nights ago. So thank you. This has been a great trip. I'm going to go home now. Finally got to chat with Yanni. I'm kidding. I'm curious, while you're enjoying your lovely coffees and such, how many of you use animation in your work? Oh, that's a good number. How many of you are using an animation library like GreenSock or Framer Motion? Okay, thank you. And how many of you would never do that? You're CSS purists, or you only use the Web Animation API? Oh yeah, we should hang out. Let's get some drinks together. Okay, I've wanted to come to this conference for quite some time. You may have heard me mention the pandemic. I attended remotely, I believe in, I think it was 2021. I was so sad that I missed out on coming to Finland and enjoying sauna. I bought a fake sauna, and I sat on the back porch in London and steamed myself after the conference. I did my best, but it was lacking. I'm Rachel Neighbors, and you might remember me from such pandemic projects as React.dev. That was how I spent my pandemic, working with the React team. Pardon me a minute. I feel like it's trying to make me eat the microphone, and I don't want to. Bad touch. Come on, there, that better? I don't know. I'm having the troubles. Okay. Is that still good? Can you still hear me all right? Anyway, a bit higher. That might be better. No. I apologize for this. It is true that sometimes there are issues with the mic. All right, this should do better. Anyway, I'm not going to skip a beat on this one. You might remember me from React.dev, but before that, I worked on web animation tools and APIs with our good friends at Mozilla, including DevTools Challenger, which walked people through how to use Firefox's animation tooling. That was probably the most fun I've ever had on a project where I got to work with illustrators and create this little game. I wrote a book on UI animation as well. If you're interested in buying that book, the publisher is going out of business, so you might step on it. But before all of that, I used to be an award-winning cartoonist. I made comics for teenage girls, but I always wanted to tell those comics in an interactive way. Unfortunately, Flash had died by the time I got around to web development. I still loved web standards, though. I was a big fan of CSS, and I wanted to make really cool things with CSS. So I teamed up about 10 years ago with Adobe Inspire to create Alice in Videoland, which would show designers that they could still create really cool things with CSS and JavaScript. They would just need to learn a little bit of coding. And it turned out that this was kind of popular. It used CSS animations and jQuery. jQuery for reasons you'll understand shortly. I got so into it, I made character sheets. You can see these from the original talk at that URL. I made everything in HTML and CSS. It was a popular thing to do. 4 years after that, I made a web animations API spinoff to go along, once again, with Mozilla Developer Network, with the development of the web animations API. How many of you know what the W3C is? Okay, well, the W3C, for those of you who don't know, it's like the CSS and HTML equivalent of TC39. So whenever browsers are coming up with like a new CSS rule or a new component for HTML, it goes through the W3C, and the W3C was working on an API for animating DOM elements. I worked a little bit with them on that, and I made this really cool demo to show people how they could use the web animations API to replace JavaScript request animation frame-based animation libraries. It has been a while since I've worked with Alice. When I was working on the React team and with AWS Amplify, I noticed that engineers had like a boilerplate app or a product that they were constantly building, and whenever they'd see a new product, they would try that product with their pet app. And I was like, well, I don't have a pet to-do list or pet photo app or anything like that. What's my pet app? And I realized Alice is my pet app. Alice is the thing that I use to test drive new specs and new libraries. So let's take a look at how this holds up now, 10 years later. I mean, back at the time, CSS animations were not well supported, so I had fallbacks in case CSS wasn't supported. You could still, for instance, see the rabbit standing in one place. So it was this was actually really useful because now I just translate those styles over for prefers reduced motion. When people might not want to see animations, I use that same story that can tell itself without being animated. I also used image replacement techniques to create a story that can be read aloud by screen readers. If you use the print style sheets by hitting Command-P, you'll see a completely written version. This is not the original text, by the way. This is a retelling, just like the book. So there's a lot more context. I wanted to create a new Alice for a new generation, which is why she doesn't look like a pretty blonde, blue-eyed girl in a blue dress. There's always like at least 2 of those components in any Alice, even like a couple of like gothic Alices. Still blue eyes, still blue dress. This Alice is very, very modern Alice. So all the stuff that I used is no longer being maintained, except for jQuery. I used Modernizer for feature detection and dependency loading, and jQuery for DOM manipulation and plugins. I wanted to actually just use vanilla JS, but the things I wanted to show people doing with JavaScript weren't possible in vanilla JS at the time, or they were possible a lot more accessibly to designers using jQuery plugins. So I went with jQuery. I used Hammer.js for touch and gesture support on iOS Safari because Safari didn't support touch events at the time. That's changed in 10 years. jQuery visible to detect when elements are on screen. And let's see, oh yeah. Waypoints to execute functions when that element has been scrolled in or out of screen. And of course, scroller for parallax, because parallax was popular back then, moving some things at different rates. And lastly, debounced resize to throttle, because I had to this is the problem when you're using jQuery plugins on interactive things that need to be in view. Every time like a font size changes or the browser is resized, you gotta recalculate all of those listeners. Oh, it was pretty brutal. It was pretty heavy. It had a lot of CSS animations and transitions, which were mostly managed by adding and removing classes. I kept this, even though there's an even more fun way of doing that today, using just scroll timelines, because it's simple to think about. If the thing is in view, add the class to trigger the animation. People use state management libraries to handle this today. I still think this is probably one of the more lightweight ways to handle scrolling interactions. So all the stuff I use no longer being maintained. This includes also some of the Sass things that I was using. For CSS, I used Sass for organizing the styles and adding vendor prefixes, which we don't use anymore. Compass, does anyone remember Compass? Oh, definitely going drinking tonight. I loved Compass. Compass generates sprite sheets so well, and I use sprite sheets heavily for the image replacement. Sprite sheets were a big deal because I do sprite-based animations, and also because they streamline downloading image assets. They made the loading process a lot faster. Instead of a bunch of little images, just be one large, fully optimized sheet. And of course, I made my own animation plugin for handling those sprite animations using the steps timing function. I am not going to refactor the SCSS yet, because it still compiles. I had to go back and install an older version of Compass and Sass, but it still works. And I love the fact that I can just go in and put in all the gems from my lock file, and boom, it's still alive. It still compiles. But I wanted to refactor at least the JavaScript side of things. I wanted to update her to modern standards because last year, when I was at CSS Day in the Netherlands, a couple of new standards dropped, which actually completely remove the need for any of those plugins I mentioned and make it much lighter and more performant. So this is my pet project that I'm working on during the season of layoffs. All right. I actually had a lot of fun. I did this on Twitch. I've learned about Twitch. This is another fun thing I am learning in time off. It's like the closest thing to pair coding and body doubling that you can have when you don't have an office to go to. Have some regular people who would come in and hang out with me. And I learned that actually a lot of people don't know about these new features and were surprised to know that they exist. So I'm going to tell them to you here. So you know the old stack, but what are you going to learn about in the new stack? In the revised edition, we're going to be using prefers reduced motion. Does anyone not know what that is? Okay, that's good. We're going to talk about it. Okay, yeah, oh, Ben, hey, you know, like even the people you respect sometimes don't have your niche knowledge. That's why we come here to share. We can all learn from each other. Intersection observer to find out when things are intersecting with the viewport. True story, this particular API was not introduced for interaction designers like myself. It was introduced to reduce the load size of ad bundles. Oh, standards still being influenced by data collection and advertising. CSS5 animations, because in the Netherlands, I just learned that scroll timelines fall into the CSS5 category. And the web animations API, of course, because we love you. And this includes scroll and view timelines and view transitions. Okay, all right, sweet. I hope you're excited about all those things, because I know I am. Oh, thank you, thank you. All right, now let's get in there. Wait, yes, this is right. I'm going forward in the right direction. Prefers reduced motion. Some people have vestibular disorders. They might get nauseated when they see things moving at different rates across the screen. And that's why operating systems ship with this ability. Apple is the one that started it as part of their accessibility initiative to allow people to say, I want you to reduce motion in the things that I see. And you can respect this with a media query in CSS that will basically say, does this person have this setting set or not? And you can say, well, if they have it set, do this. If they don't have it set, do that. Here, this is I made a little helper function, is reduced, and I can use that to determine whether or not the animations are running or included at all. In this case, I say, you know, if it's reduced, I use the match media query here, pause the animation on Alice's emotions. Okay. And you can also use it just in CSS. This one shows, for instance, if the query has been set, this one makes the bunny going down the hill perfectly invisible by keeping its opacity off. Okay, next up, intersection observer. So the book consists of scenes and pages. And let's see what we got here. Yes, each scene has a queue, which I'm pointing to. And when it's in view, it gets a class of Q. And the Q basically says it's OK to do any animations and assign any event listeners that are necessary at this time, or even to expose an entire group of its children, pages. And pages, basically, they get a class of InView when they're in viewed, or viewed when they've been viewed. And this way, animations only run if the page has in view on it. This saves computational costs. Because believe it or not, if you don't tell them to stop, the animations just keep running in the background because you might scroll back to it at any given moment and be upset if it's not still running. The browser doesn't know what you're doing. All right. Love it. OK, so here's the intersection observer. I was disappointed by the clunkiness of intersection observers API. I'm sorry if anyone worked on that. It should be easier than this, but it can be done. It can be done. I had help on Twitch. I passed in all the scenes, and then I ran a for each on them. And if the scenes are intersecting, you give it and its style opacity is 1. Don't ask. It's a part of how it works. Give it the class of Q, and then unobserve it, because we're not going to call Q on any of these again. So you remove that listener, free up some memory. Sweet. And I did the same thing, well, yes, and this is how I actually ran it across all of the scenes. Whew. Did the same thing with pages, only in this case, I added a little extra shenaniganry to change it between in view and viewed. Nothing particularly spectacular going there. And I made it a smaller threshold too, so it's a little bit more delicate. I really feel like a cinematographer calling out cues left and right. I even have a really nice cut function for giving us fade to black and then fading in a new scene, so you don't necessarily see me revealing it and scrolling it into place behind the scenes. It's pretty cool. Spring easings. Now, do you use springs? Have you ever had to make something bounce and then realized the only way to do it was to chain a bunch of CSS animations together or to install a JavaScript library? Yes, it's very painful. But now you no longer need to worry about that because, well, I mean, this is what it looks like. And in the old days, you really had to install a library like GreenSock to start creating springs, things that have multiple bounces or multiple shifts forward and backwards in their timeline. But there is now the very peculiarly named linear easing function. Now, if you know the linear timing property, it just means a constant rate of change in a straight line, which is very useful if you just want to have something have a very mechanical change. But now you can pass it a series of coordinates that you can actually chart across a curve like the one we just saw, and it will approximate the path so well that the human eye cannot detect it. So it's more of a polygonal line easing function. And if that sounds complicated, oh yeah, hang on. This is it when you're passing it to the animations API, and this is it when you're using it in CSS. So it's the same syntax, 2 places. And here's how that looks. I wanted to add a nice bounce. I didn't do that the first time because it was too difficult. Look at that. It gives it a nice little like thump when she lands at the bottom of the hole. There's this handy tool that I used for creating bouncy easings. You can pass it in SVG if you want to design this bounce in a program like Illustrator, or find it in some old tweening library. All right, so back to web animations. This was my shtick for a very long time. It's been 6 years. I'm going to give you a refresher. Now for me, I often use the Web Animations API whenever I'm doing something interactive, like responding to a user input or information coming on the screen. Because otherwise, I'm probably going to be using JavaScript to listen for that information and add a class, which pokes at the DOM. And like, I'm already using JavaScript to detect that. Why wouldn't I just put the animation, the behavior in the JavaScript? Some people prefer to keep their CSS, et cetera, in this, their animations in their CSS. But for me, if it's in interaction, there are a couple of reasons that are very wise for doing it, including chaining animations, which you're going to see, where one animation's endpoint triggers another animation to begin. That's not possible in CSS, where you just end up making a bunch of delays and putting a bunch of animations one after the other, and you can't interrupt them because it will throw off the delays. Web Animations API takes a few more kicks and can do a few more things for you. So how you think about it is you get this animation object, and it's kind of like a DVD player. I know we're all old enough to remember what those are. I won't make you raise your hands. But the important part is this animation object, it takes a keyframe effect object. You put it in there. It also has a timing object that it takes, but you stick it in there, and you essentially hit play or pause, and you can play it forward to the end, or you can back it up to the beginning. It's pretty clunky. But it works. It does the thing. So this is what that keyframe effect object looks like. It's very similar to CSS. You got to remember this powers CSS under the hood. You pass the DOM element that you want to animate into the new keyframe effect, and then you pass an array of the CSS properties you want to animate to and from. This is a little bit more complicated in the spec, but all you need to know is to and from, and the timing object. This says we want it to run twice. We want each of those iterations to last for a second and a half. And we're going to use the steps timing function. Unlike linear, which would ease us through this change slowly, steps just kind of goes chunk, chunk, chunk. It'll jump us to each of these locations. And that's what gives us that lovely, lovely effect. Now, here's how we stick it into the player. We make a new animation, we pass it the keyframes effect, and we pass it the document timeline. Now, for 6 years, the only timeline available in any browser tab was the document timeline, which starts as soon as that tab is open and runs forever. And every animation starts at a point on that timeline and ends at a point on this timeline. If you can imagine, that makes debugging kind of hell. Also, how many animations can you think of that would like to use a different timeline? Maybe you could attach animations to some other inputs, for instance, the length of the document or the scroll area, and then the playhead could be aligned proportionally to wherever the person was in that viewport. And that is exactly what scrolling timelines do. All right, but anyway, and yes, you hit play with this method. All right, I'm so excited to show you this. This is the sweet stuff. This is the performance enhancement. So the Web Animation API is based on 2 models, which I think of as the timing model, the animation model, or the when and the what. Whereas we just got to know them timelines and keyframe objects. We only had one timeline until now, but now we have 2 new ones. The father, scroll timeline, and its little son, view timeline, which we'll talk about in a minute. But for now, we're going to meet this one. The end-to-end documentation about these features, well, I didn't write it. So I will go explain it a little bit more. What exactly is a scroll progress timeline? I think showing is probably the best way to get here. This is just the scroll timeline. As you can see, the scroll bar on the right is correlated with where Alice's position is as you scroll down the page. She's got a position sticky, another nice thing we have, which I won't go into, stuck on her so that she will only stay within this scrolling area. And this is what that looks like on the DOM. It's just a div with an ID of tunnel and a little Alice div inside it for people who really don't believe that divs should exist without containing information. I made you a printable storybook, go home. And this is what it looks like. This is the keyframes. There's nothing special going on in here. She's just being translated up and down as you hear, going from being halfway off the screen to halfway on it. Now here's where the magic happens. Instead of, here's where the magic happens. We create a new scroll timeline. And we add it in instead of the document timeline in the animation object. The scroll timeline basically looks at the thing that you're running the animation on and looks for the nearest scrollable parent. That is, it doesn't have overflow hidden or scroll none on it. It looks for that nearest scrollable object. In this case, it's the tunnel. And then you hit play, which means anytime that element comes into scrollable vision, that animation starts running. All right, here's what this looks like in CSS. For folks who are like, yeah, I'm not going to write JavaScript for that. Here you can see I've wrapped everything inside a supports rule, so that you can see that it's a if animation timeline scroll is supported, then you make this animation. We have her falling at a linear rate. It's handy, it happens. And we pass animation timeline. This is a new property, and we just say scroll. And you can define different scroll animations for different objects on the page as well. So you could be passing different scroll timelines. I'm not going to go into that there because we've got a lot of ground to cover. But this is all you need to create a scroll-based animation with CSS. Now, let's talk about view-driven animations. It took me a moment to understand the difference between these two, but I'll get into it in case you're also a little fuzzy. Let's see. There we go. Now, it looks a little like scroll animation, so I turned off the scroll animation for this one. You'll notice that this time, as we're scrolling her sticky position down the page, she's just staying at the top. That's how the CSS is supposed to work. But as we scroll her down the page, her background position is changing to a different part of the sprite. So her animation is timed with how long she's in view. When she's out of view, the animation isn't running. When she's in view, it is. Technically, you could do this with a scroll-driven animation, which is why they're closely related. But the difference is that the view timeline only applies to the object as long as it's literally in view. All right, here's the keyframes. I just told you how they work. But here's how we actually make it with the view timeline. So we make a new view timeline with the handy new view timeline creator. We pass it a subject. This is where it gets a little different. You might say, why a subject? Because it's literally following Alice. As long as that document, that element is in vision, this can run. So it has to know what it's being assigned to. And the inset is a way that I'm offsetting the animation, so it doesn't start running immediately, and we get a little bit of a lead time and drag time, so that the full animation runs a little bit before she's off screen. I had to twiddle around with it a bit. And once again, you pass them both to a new animation, your keyframes in that timeline, and you hit play. Yeah, I do that whenever the page is loaded. Or when the element has come into view. So here's what that looks like in CSS. In this case, I am using prefers reduced motion, no preference, to indicate that this change should only happen in that situation when people have said that they don't mind animations running. And make sure that it supports the animation timeline view, not scroll, but view. And here is that beautiful new property animation timeline, and you pass the offsets as an argument. Whew. The difference. Scroll timeline is, well, it's based on scroll length of the element's nearest scrollable parent. That's how long the timeline is. That's how long the animation is spread over. And with view timeline, it's based on the visibility of the subject inside the screen or the viewport. Scroll timeline, the playhead, or the current location of the animation, is 100% tied to your scroll position, where your scroll bar is. There's a horizontal version as well as a vertical version. It can get really fun. Whereas the playhead with the view timeline, or your current timeline, is more to do with the subject's position, not you, but the document element. And lastly, duration for scroll timeline, directly proportional to the scrollable element's dimensions, whereas the duration for view timeline is directly proportional to the subject's trajectory inside the viewport. Whew. So this is why I used the Web Animations API for this, because I did some complicated chaining here. Alice's frightened animation, it plays, when it finishes, we play the emotions animation. This ensures that Alice is kind of like for 2 loops of that animation, just as the tunnels come into view. But then, when they've finished cycling twice, that's when her other emotions come into play. So there's a loop, but then there's a steady progression through her emotions. Additionally, when the animations for her emotions have finished, I call that cut function I told you about. It goes to Wonderland and it plays jiggle on it. just a fancy thing that I use to put the cue on something that isn't in view. And then I hit play on the falling animation and play on the frightened animation. They both start at the same time. And this way, they all occur in a certain way, and all their callbacks are chained together as well. This way, I'm ensured that the animations play a certain time. This is how it all looks together. It's a little different from the original. There you go. That goes twice. Now as we start scrolling, we're going to go through her other emotions. And when we get to the very bottom, that is to say the emotions stop playing, we cut to the next scene and we play the jiggle. There we go. Nice. But wait, there's more. There is a handy polyfill, because this only works on Chromium. Safari and Firefox aren't into it. The polyfill's actually pretty cool. It just, takes a measurement of the length of the nearest scrollable parent and, devises a timeline, then on scroll it updates it. I basically built the same polyfill for another demo, but this has way better resizing logic, so just use the polyfill and you can't go wrong. I really feel I can wholeheartedly recommend using these two timelines. They are ready to go. You can use them today. It's likely they're going to be supported because the idea has been around for 6 years. Now, there's also this handy tool created by Bramis on the Chrome developer advocacy team that will let you debug them because these scroll-driven animations haven't quite made their way into the developer tools in Chromium yet. So this is really handy. Well, here's the fun part. Everything you just saw was reviewed and approved and given lots of feedback in the Netherlands at CSS Day by the people who worked on the specs. So they all got to see this already. But I told them I was saving this for Finland. This part is just special for you all. The Netherlands meetups may have seen it, but this is for you guys. And this is exciting. So in CSS5, we have another spec for view transitions. And in this case, I wanted to show how to do multi-page app view transitions. Now, I should warn you, view transitions, when it first came out as a spec, which was almost 10 years ago, maybe more like 6, it came out. I looked at it and I was like, ugh, no, don't like it. But it has come such a long way. I'm going to show you a very simple use case that you can use today to navigate between pages on a multi-page app. But you can also use it you can use it in JavaScript or CSS, but you can use it in JavaScript as well for single-page app navigation animations. So that's pretty handy. I, of course, already built those with Cut and a couple of other things, so I'm just going to show you the CSS base case today. All right. Now, keep in mind, what I'm about to show you only works in Chromium 126+. So Safari and Firefox, they don't have polyfills. I didn't know this at first, and I beat my head against a rock for a little bit. But fortunately, Bramis bought me a clue, and it turned out I was on 125. So I have an experience with this, but I can say the good news is that means for people who aren't using the latest version of Chrome, they're going to get a fallback to just regular page navigation. They won't get the fancy animations for this particular method, but they will be able to still navigate from one page to the other. So yay for progressive enhancement. I wanted to take the second part of Alice's story, the one that I made 4 years later. I guess I didn't say this, but because of my cartooning background, everything you've been seeing, I drew it. I drew it all myself. And I also wanted to share this again, precisely because I put so much time and love into this. And I just wanted to be able to bring Alice out. So this was the second demo I made. The first one was trying to show you what could be. But the second one is showing you just how the Web Animations API works. It has an entire talk, but I'm not giving that talk here. But what you need to know is that this one was less ambitious. So I didn't start with this one. I started with the one that was doing all the things, all the scroll timelines and the showing and the hiding and the animations with the sprites. I wanted to try to make that one, my Hello World app, work with modern specs, and it did. It worked really well. But I also wanted to add part 2. I also wanted to bring the second part of the animation story in line with the first. And so I reevaluated the experience. I sketched out how the different demos work together, the long scrolling timeline, and then the very short bursts of web animation API. And I decided that it made sense to take the bottom part of the scrolling animation where she lands in the tunnels. It made sense to cut that off and put it on a second page that features her hiding out in the tunnel, drinking and getting up to things kids shouldn't be doing, I guess. Basically getting smaller and bigger in that little mini game. So I reorganized it. All you need to know, I wanted to transition, by the way, at the bottom of that scroll timeline to this new page with these view transitions. So this is how you opt in your CSS, at view transition, navigation auto. That's it. It's going to default to a fade. And this is what it looks like. Come on, Alice, wake up. I mean, it's nothing to write home about, but it does the thing. It faded to the other page. And then here we are, it's another page, and we bounce in. So, like I said, the fallback is still navigable, progressive enhancement, yay. But I wanted to make it look a little cooler than just a fade out. I wanted to make that fade kind of a slide. So here, I created some keyframes. Fade, I made the fade a little different, and I added a little bit of a slide so that it could look like she was sliding out of the way as the other page was sliding in. And you get these lovely new pseudo elements with view transitions. View transition old and view transition new. And you can run animations on them that will run when they exist. It's a little quirky. It's interesting spec to read. But you can think of old as a snapshot of the thing you're navigating from, snapshot of that page, and new as a snapshot of the thing you're navigating to. And here's what it looks like now. So we go down, and there's a little fade up. I don't know if you could see that. Let's run it again. Wow, come on, there we go. Little fade up. You can see it's small, it's small. But the point is, you can get really granular here. I can heartily recommend this when it has a little bit better support and docs. I will probably switch over to using the JavaScript version and port all of my cut functions over to using it. The great news is you can use it for single-page apps or multi-page apps. You can run it using CSS or JavaScript, depending on whether you're using a declarative style or an interactive style of coding. You can animate the whole page, or you can animate individual pieces. That will require a deeper dive. There are many amazing tutorials about that, which I'll link to shortly. The one thing I was frustrated about is that there are many amazing, ambitious demos out there, but the MDN documentation is a bit spotty because a lot of these things are bleeding edge in Chrome, and some of the demos I found that were on the simpler end, like mine, simply didn't work anymore. So heads up, if you're curious about playing with this, you want to head over to the Chrome's blog post and not MDN, just to get a better idea of which direction the Chrome team that's doing the work on this is thinking. All right, so why use CSS3, 5, and web animations APIs over your favorite animation library? Well, it's easy to respect user preferences. You can use those media queries all your heart's desire. Graceful degradation and polyfills. You can still use view transitions even if they aren't polyfilled and the polyfills are performant. You do get better performance by using the native animation functions in the browser because they tend to be piped directly over to the GPU, the graphics processing unit, whereas JavaScript-based animation libraries tend to rely on the GPU. It's a more expensive, less performant process. So, this also results in a lighter code bundle because you're not loading an additional library. CSS animations in the web are green, not great, but they're green. Just to follow up on what Ben was talking about, because these run so close to the wire, they consume less energy and they look better. So despite disappearing down the rabbit hole of big tech for the better part of 8 years, I still love telling stories and perfecting user interactions. I was really glad to have the chance to come back and play with Alice. And I got to thank the organizers for this conference for giving me that opportunity. About a year ago, they said, well, what would you want to talk about? And I was like, I had just come back from CSS Day and seeing the specs for scroll timelines, and I was like, I think that's their way of saying leave. Be patient. I'm one slide away, okay? Anyway, and I said, I want to do something with these. Just let me come and show the world how to do it. And they did. So anyway, I'm still hanging out. You can find me at nearestneighbors.com. I'm writing a book on surviving your tech career at my Substack. And most importantly, if you want to check out some of the source code, I'm so sorry, you can go check it out on GitHub. It's still in progress. It's far from being finished, but I have some ideas for how I might want to extract it in the future. Thank you so much for giving me the opportunity to share Alice with you. It was really great to work with her again, and it was great to meet all of you.
Thank you very much, Rachel. And I'm so sorry about the technical difficulties you had to experience. And also, I believe this might be yours. Yep, there we go. All right. In order to avoid any unnecessary time spent with technical difficulties, we'll invite Steve here up on the stage while let him set up while I introduce him. So yeah, at this point, probably there's no point reminding you, but just to let you know that we will be doing a Q&A after this session, so we'll have Rachel back on the stage. So you can go to Slido, and use the code FF2024 to ask those questions. Now I'm going to ask you a question, and I hope Steve wasn't going to ask this question himself. Who here has seen Steve and TL Draw tweet these wild AI demos over the last few months? Amazing. So good that we have a warm audience, but also good that we have some people who have absolutely no idea what to expect. And I am sure that at least a few people are going to experience the same thing I experienced the first time I saw the first of these demos, which is a mixture of disbelief, a kind of like a wild gaggling laughter, and then fear for my future as a software engineer. So hopefully with these words and these emotions, we are ready to let Steve loose on the stage. Give it up for Steve Ruiz.
Hey, hey. All right. Let's see. Hey, I am Steve Ruiz, and I need to make this full screen. I was tempted just to do this entire talk on Twitter, but I'm not going to do that. I'll come back to this guy later. He's kind of fun. Cool. So my talk is called Make Real TLDraw's Accidental AI Play. I'm Steve Ruiz, founder of TLDraw. TLDraw is, well, let's talk about me first. I'm a designer turned developer, and before that I was a fine artist. So I only got into this scene sort of when I was 30, which was 8 years ago. So a lot of things happened kind of fast for this. I live in London. The team is mostly based in London. TLDraw it's a venture-backed startup. Came out of my open source work, which I was doing in public. And one of those things that I was doing, which was kind of like an open source whiteboard SDK, ended up getting really popular. I had done some work on digital ink and pressure sensitive lines, like variable width lines. I integrated it into Excalidraw, if you know Excalidraw. I built a couple of different apps that use this sort of zoomable canvas stuff, and I'm like, I want to build something that is basically I just don't ever want to build this stuff ever again. It's really complicated, it's mostly undifferentiated. I was just going to have my own little starter thing. I used the whiteboard, basically like Excaladraw's tool set, or feature set is like a demo, essentially, of the SDK. And it turned out that the SDK got really popular, and it also turned out that TLDraw.com got really popular. So a couple of interesting things. If you don't know TLDraw, I'm telling myself I should do a sizzle reel. It looks like this. This is whatever, random stuff. You can use it to draw. You can use it to draw whatever you want. It is the TLDraw.com, the demo that I mentioned, has a whiteboard with multiple pages. You could share that. I won't because I've learned that you don't do that on stage. And yeah, it has a lot of like care and craft, I would say. I'm kind of obsessive on the details. So for example, our arrows are like, they should be pretty perfect. Even if I like rotate this guy, they're going to be just right. I'll even do, come on, I'll do this. I'll turn this into a heart, which is new. I'll do this into a star. I'll even make the dashes. And I don't know if you can tell. See how the dashes are like in the corner? Like they're just right. It's part of the SVG 2 spec or something like that. But like this sort of balanced dashes, definitely had to do that ourselves. But yeah, and now it even works with the heart. It's like perfect. If you can figure out how that works, let me know. I wrote it, but I forgot. Anyway, yeah, use it. It's good. It's free. There's no login, so there's yeah, it's a demo. I do a lot of public stuff. I do a lot of tweeting about my work. I do a lot of like this kind of thing, I guess, now. I love sharing my work in progress. I used to be an artist. We do that all the time. We invite people over to like do studio visits. Twitter just became my studio visit endlessly. So I was putting out tweets right from the beginning, and that's part of like what led to the visibility and whatever the success of the early success of the company. It is also like, because it's a hackable SDK and it's really meant to be hackable, it has all the kind of primitives that you would need in order to build whatever you want. People have built games, people have built whatever. I saw someone was doing like shadow casting, and I'm like, wait a second, I have a geometry inside of TLDraw. Like we have a, I'll show you it just because it's kind of cool. Where are we? Geometry, debug geometry, there we go. Hide shapes. Like the editor itself has an idea of like what all the shapes look like or where they are that's separate from like how they render, right? And I should say while I'm here, since it is kind of like a webby front end, our canvas itself is a big React app. It's a React DOM app. I don't know what's on my clipboard, but you can put, that was a risky paste. I don't know what that was. You can put YouTube videos on it. You could put code editors on it. It's a normal website. There's every shape on the thing is its own React component with an SVG in it or whatever. But yeah, since we had the geometry for it, you can do things like physics engines. You can do things like shadow casting, whatever you want. It's very, very, very hackable. Well, I'm going to just cut right to the end. Last year, around November, it got ridiculously popular.
Take our job. This is TLDraw. They rolled out this button called Make Real, where you just put your things on the canvas as you want. And then I made a compound interest calculator. Let's select it.
I really like the
button
laugh.
called Make Real. It's supposed to give you HTML, CSS, and JavaScript out the other end. Let's click on Make Real. Let's see what we got here. Give it a sec to generate. I had to put my own OpenAI API key in to make it work.
Thank you, Wes.
I don't know. Is it gonna? Some of the demos I've seen is pretty impressive.
It's a good laugh.
So this is not a PNG. This is actual code working here.
TLDraw suddenly got like super popular. There's like shit tons of TikToks and stuff, like each with hundreds of thousands of views. There's a weird one with like. This is about TLDraw. This is about my little JavaScript library. Where they could draw a little box like this and the.
小学生でも書けそうですね。そしてちょっとした魔法のように英語で指示を出してみます。Rotate the cube. 立方体を回転させてという意味です。見てください。動きました。これ。
We also ended up getting incredibly popular. This is a 7-day analytic report for our Twitter. That's like Kanye West. Those are huge numbers, 13 million. Jesus. All right. So how did this happen and when did this happen? Well, it started Monday. November 6th, 2023, and I'll kind of give you a picture of where we were at the moment on there. I was in the middle of trying to raise an extension for TealDraw. So again, we raised a seed about 2 years ago. This is last year, last November. And I'm still pitching the story that, like, look, it's important to have this type of primitive. We have primitives for text editors, we have primitives for maps and data grids, but we don't have anything for infinite canvas. If you want to build something like Miro for teachers, you have to build Miro, and then you get to build the for teachers part, right? Like, there was tons of undifferentiated feature set that if we build it, like, people will build with it, and that's the pitch. And we had a lot of adoption, early stuff, but like nothing had really hit yet. Yeah, we had like 9 months of runway left, so there was kind of like our all right, we need an extension to keep this thing going. We had also shipped, let's see if I put a slide here. No, we had also built and shipped almost a SaaS product around tealdraw.com that let you log in and have your files and your teammates and pay me $8 per head. It wasn't really good enough, so I decided not to ship it. It was kind of a sad moment a little bit for the team. There was this months of work, and I'm just like, this thing sucks, let's get rid of it. So we were kind of in the doldrums between this big project that we had worked on, trying to raise money, and then deciding what's next for the company, and like kind of doubling down on this SDK, but we're not exactly sure what that meant. We still hadn't taken it to market. It was, I don't know, if you worked at a startup, there are these kind of like becalmed water moments in the midst of all the other activity. This was one of those. As I'm pitching the fund that would end up leading that extension, the November OpenAI event was happening. Same day, November, 6th. And this was the one where they released the Vision API into public, right? This had been around, you could use it in the ChatGPT app, but now developers could use it too. It was super limited. You could only do like 30 requests per day, but it was out there in the wild. And we had done some experiments with that, but like, again, because it was like it was only in ChatGPT so far, like we would just be taking screenshots and putting it in there and saying like, hey, what is this? And having it describe like, okay, this is a flow chart, this is how it works and stuff. So we knew that it worked with diagrams as the input. We knew that it could actually work very well with this type of content as the input. But we hadn't tried it ourselves. Oh yeah, that's that SaaS product that it was good. I shouldn't say it sucks, it was good, but we didn't ship it. So that was that day. Big announcement from OpenAI. Sounded cool to me. Tuesday, November 7th, a designer or developer at Figma named Sawyer Hood dropped this tweet where he had taken TealDraw and used it as the input to GPT-4. And the way that this worked was that you would draw a UI, you'd click a button, and it would send it to GPT-4, to OpenAI, saying like, hey, you're a developer, you're a Tailwind expert, and you just got this low fidelity design from your designers, come back with like a working HTML prototype. And it did. The GPT-4 can write HTML pretty well. Now it could work off of designs, and it was super popular. You could see this got like a ton of visibility, and we were so excited because A, it was using TealDraw, not Figma, and B, like it was, what Sawyer had done, as amazing as it was like only a little bit of the way along, like what we could see was like a longer journey. Like this could get way better, and so that's what we kind of started doing. His code was up on GitHub. It's a great little repo. We forked that, and we started working on it too. I should actually probably skip to the end just to show you how this actually works. I think I'm running, yeah, here we go. Okay, so this is Make Real, just a local version of Make Real, but it works the same. You draw something, you select it, you click a button that says Make Real, and you get back some UI, right? These days we stream it in. This is a normal website because our canvas, although it looks a lot like Figma, Miro, et cetera, is a normal website stuff. It's all HTML, CSS, DOM, all the way down. So I can draw on top of it. This is an iframe. I can still rotate it, resize it, whatever, but it is a website. So I can double click into it. Now I'm interacting inside of the thing, and now I can click buttons, click start, stop, and hooray, it actually works. Now, GPT-4 has gotten a lot smarter. This is using like 4.0, so it's a newer model. When it first started out, it didn't actually work right just using the UI as the input. So we just give it more than just a UI. Like you could give it anything as the input. That's the fun part of the canvas, is that you're really just composing you're just giving it an image, ultimately. It's like kind of the universal interface is like the screenshot, and for us that's pretty much the case. So in this case, I'm actually telling it this is how I want it to work, but I could, and ironically now that doesn't work. Good demo, Steve. We'll keep going. You could do a lot more. Like this is like a little Zelda style, like chicken catcher type of an app, where I want to chickens move in random directions. You control the player with the keyboard. Again, this is kind of like it's as close as you can get to live coding without the code. Well, let's see, does it work? Oh, yep. Hey, there we go. Chickens are moving very slowly, but they are moving. And now I can pick this one up, and move it around. Sorry, chicken. I'll let it go again, and now it's moving around. Again, it's not putting anyone out of work here, but I just did that by drawing a picture. There's more to it though. Like it turns out that the type of images that you would create for other developers work really well for Make Real. In other words, my past experiences like a UX engineer, designer, or whatever, where I would make these type of specifications. Now, I also coded them myself. I mean, that was sort of my thing. But like, this is the type of thing that you would make to describe how an interaction would feel or should behave. Well, it turns out that those things. Again, this is live. Oh, come on! Just give me it. Give me it. This is the other cool thing. I don't know. All right, if this works, then I'll be really lucky. Oh, it didn't. Wow. All right. Wait, what? Okay. You can annotate. You can write on top of the websites that it gave back to you and use that as the new input. I'll use maybe a better example here. This is iPad second generation. In my opinion, the finest of all iPad generations. And again, let's see what it can come up with. I could take the entire hour just doing these demos, so I'll try and finish the story before we get up. But yeah, it's like, this is how I want it to do it. I don't think it's going to do it, but like, these are what the buttons should look like. And again, I'm using this, in this way, I'm using these like figures. Like it's really good. I think it looked at tons and tons of patents or something like that. So this type of like figure A, figure B, figure C, like it can assemble them really, really well. So here's what it came up with. Let's see if I can drag. All right, no, I can't drag, but I can apparently select album number 1, and I can use this to move around. Not the craziest demo, but again, I just drew some pictures. Here's where it kind of gets crazy, is that you can, in addition to writing stuff, you can just give it anything. And it's really good with text. It's really good with images, like OCR and stuff. So in this case, I'm saying, hey, I want you to generate some ASCII art. I'm going to type some text over here. You're going to give me a result over here. But that's not really something that a little local one-page HTML file can do. But it is something that GPT-4 can do. So I'm going to give it a little function, and I'm going to give it my API key and say, like, this is how you get a text prompt into ASCII art. And I'm just going to load that in there and see if it see if it works. So again, this is using AI, and this one better work because it has worked pretty reliably in the past. And of course, we're streaming in the result, the HTML result. So here we go. Let's try this. I want a dog. No, come on. You're killing me. You're killing me. Add event. No, oh man. Hold on a second. Let's try again. It's worth it if it does work. Otherwise, I'll just have to regret it. Do I have that here? I may. No. Wait. I think I do. Yeah. Okay. This is my. And out of the oven comes the finished product. Dog. Hey. Hey. All right. My favorite part of all of this is that this is like the shittiest looking website, and I'm at a modern front ends type of conference, and I get the applause for that. I don't know, ice cream cone. I'll take an audience recommendation. Yeah. And this is it's not being generous. It's actually hitting OpenAI with the dumbest possible request. I don't know what Finland is. Come on. Did I type that right? Yeah, that's Finland. All right, whatever. I must have hit my my maximum there. But yeah, it works. It's pretty cool. Yeah, whatever. That is not Finland, but maybe it is. Hold on a second. What? That is ASCII art, but what is that? What the fuck? Right? I'm squinting at it, do you see that? It's what? That's very strange. Oh, that's a good one, by the way. Self-portrait. Let's see what it comes up with. Okay. Have no fear. The Shoggoth actually looks like this, so there we go. Wonderful. Yeah, and kind of like what I said before, you can annotate on top of this. You can iterate, essentially. That's one of the things that I'll talk about in a second. But I'll go back to the story. You see, it's pretty cool. If you haven't played with it, you should. And there's some things maybe on this screen that are strange, and we can talk about those as well. But yeah, boop, 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 whatever. We started working with this immediately, and we hadn't released anything. We were just forking the Sawyer's stuff. This is all Tuesday or something, Tuesday, Wednesday, Wednesday, Thursday probably actually. But you could these are all iterations where I'm saying no, make the icons look like this. All of those little iPods are websites. And I'm just drawing on top of it and using it as the input again. Because what we found was that you can basically just give it an empty rectangle and say hey, this is the thing that you made before. It's not part of the image, but here's all the HTML and CSS. Here's the file that you used to fill this. And somehow it even interpreted correctly arrows pointing to empty spaces in that white rectangle on the image to say oh, he must be talking about this particular button in the HTML, which is really weird. So we spent a week just tweeting, basically, building the stuff. And then on Wednesday, November 15th, I noticed that other people were starting to realize just what the opportunity here was. This stuff was really starting to snowball in terms of Twitter. There was some other media that was being created around it. Someone put up took Sawyer's work and basically bought a domain and said coming soon, draw the production version of Draw My UI. There can be no production version of this. The Vision API again only let you do 30 requests per day. So it was impossible for anyone else to actually productionize this. But I'm like, you know what? We got to put a flag in the ground. Let's do it anyway. So I put up like makereal.tldraw.com. I stayed late on the Wednesday and put it out there. This is a big tweet. Immediately, it broke because again, you get 30 requests per minute, and so like the responses were like, cool. This is broken. This is broken. This is broken. And like, why is this not working? Finally, it was this guy, Fabio, who was like, hey, you could just let people set their own API key. And I'm like, well, not like you shouldn't do that, but I'm like, fuck it, let's go. And I did it, and it looked like this. It still looks like this. It's just a text box, and I swear I'm not stealing your API key, but do whatever you want. I needed to somehow signal that this is like, don't do this, but also just do this if you want. So risky but cool is the phrase. If you ever need to do this for a user, go for it. Later in the week, I was talking to like the folks at OpenAI, and they're like, how is this happening, by the way? Like we like throttle the hell out of these API keys. Like, are you doing account sharding? Account sharding is where you spin up multiple accounts in order to get around rate limits. And I'm like, no, but kind of, like, because every user is kind of like bringing their own API. And we spent so much time supporting non-technical people on how to create an API key for OpenAI. It was the worst possible UX that you could imagine. Like this little button, the question mark, just opened like a little dialogue, that said, here's how to do this. But you can't even like copy and paste out of a dialogue. It's bad. So Thursday, 16th, now it started to really go viral. Kevin Cannon, sorry, I don't have the videos. We'll see them. Made a little like color picker or slider. It just worked with TLDraw. He posted this. This got huge. Someone posted that on Hacker News. It got huge on Hacker News. Greg Brockman from OpenAI like retweeted us. That was huge. I'm starting to get inbound from everyone. All of the VCs who didn't participate in my extension start calling me again. And I'm like, oh, I don't know, guys. It's kind of full. But no, it was great. It was definitely like the eye of the storm as just folks were, again, sharing their work and trying to figure out like how to use this thing and like what it's capable of. And like we were figuring it out, like the whole, figure 1, figure 2, how does it do animations? Can I give it like an easing curve and will it respect it? Like that type of stuff. It was just this great social discovery kind of experience. Now, the thing that a couple of people were asking is like, are you just gonna like productionize, like just make a product around this? This seems fun, people love it. And maybe. I have this kind of theory, this kind of feeling around AI products that like, it's really hard to turn them into like products that people pay for right now. Mostly because like they're all pretty much following the same pattern, which is that they're like bad, but amazing. They're like, they look like, like junk, but they're like the most fascinating thing that I've ever seen. And I've seen a lot of like AI startups, put a SaaS product around something, it just gets replaced in 2 months anyway. So I was like, I don't really want to do that. But for us, we commercialize the canvas. We sell licenses to use this thing in a commercial product. I want as many people as possible using TLDraw in as many ways as possible. Not exactly what I wanted, but at least they got the animation curve right. And so we put out a starter kit. Essentially, like, here's all of our source code. It was always open source, but like, here's the code that you can use in order to create your own Make Real. It's a template. We went through the whole thread because we wanted folks to be using this not just to be building websites, but like, I don't have an example, but it turns out you could just take like an entity relationship diagram, and I think that's what you call it, and say like, hey, make the migration or whatever, make the queries that I need in order to build this. And then it would say, here you go. And then you could say like, actually, you know what, I don't like this table, cross it out. Say like, give me a migration that'll change it now in order to reflect that change. And it's like, sure, I can do all that. So the idea of using this pattern of taking the teal draw canvas, drawing something, and then having an AI turn that into something else, and putting it back on the canvas, and then iterating on it, it didn't feel like a product. It felt like a pattern. It felt like something that my kids are going to be doing in 10 years. Maybe not with my canvas, hopefully with my canvas, but like we're going to be just drawing and using AIs, basically using canvases as an input to language models. So this was the starter. It was pretty popular. It still is pretty popular. It definitely inspired a couple of customers. It also inspired a couple of customers who were already interested in using TealDraw, and then now they're suddenly like, oh, you know what? This is actually aligned with our company's AI initiatives, so I'm going to have an easier time selling this internally, which is great. I put out a blog post on Saturday, so this is only like a couple days. I mean, we put out the makereal.com on Wednesday. This is now Saturday. I put out a blog post basically describing all of the things that had happened and that were still happening, and all the GIFs. The question is like kind of like what happened? You know, like what did we learn? I don't know why I put these like low, slow little transitions, but we're going to have to deal with them. This is the traffic spike for MakeReal. It went from nothing to like 40,000 users, and then kind of just trailed off from there. It looks terrible, but this is still actually like a decent amount of traffic for a small website like this. Tealdraw.com also got that same big old spike. Only people stuck around there longer, which is really exciting. Like when you compare these two, and be like, all right, people came for the make real, but they stayed for the whiteboard, and I'm very happy about that. It also, juiced other numbers here, and it showed us that like, oh boy, there's money in the AI piggy bank. If we want to show people like, here's our canvas, you can use it for anything. It turns out that some of these new language models or diffusion models like this are a really good way of doing that. So we started playing around. This is like latent consistency models, where it's just spitting out an image as fast as possible. And this is, I think, a little bit sped up, but I think right now it is basically this fast. Like you're getting essentially like a streaming video back as you're drawing. If you want to see this, let me know. I'll fire it up. We also did some like collaborative experiments. This is one where, is this the right one? Yeah, let me show you. Where it was also doing the LCM stuff, but with a collaborative, infinitely scrolling drawing app, where as you were drawing, it was just sort of incorporating that into the artwork itself. And this was collaborative, so it was like just a ton of people just all drawing at the same time. Luckily, all the kind of 30 pictures just turned into flowers or something like that. It was incredible. It was amazing. This thing was like running off of a laptop in my living room, being the like the server for it. But this is just fascinating to use these two types of technology together. And this is like right about when people started getting bored of chat, and like that every app was adding chat. We have continued just leveraging like oh, you could do anything with this thing. It turns out that I can say that, but it doesn't actually mean anything to anyone. Like this is a primitive. It's like it's you do anything with it. You have to show, and we really have learned that showing is much better than telling with regard to a library like this. So this is a TL Cart multiplayer. So these are other players running around. Physics engine, whatever. It's just the web. It's just JavaScript. Most recently, this is like yesterday, where the Apple Math Notes thing came out, and we're like, we can do that, So this is Lou Wilson, who is also goes by Toad Pond, the wonderful YouTube channel, if you want. But they were instrumental in a lot of this, the AI work around Make Real. It was, props to Lou. And they have this week been doing fantastic work with this type of TealDraw as an interactive calculator that can work with just about anything, not just text and stuff. Do you see what's going on here? It's crazy. Yeah. So takeaways, if you're a library creator, you can get a lot of mileage out of sharing the story of something being built. And that was the first 2 years of TealDraw. It was just like the building story. And that story worked really well. It built a community of people who really cared about this thing. It also just introduced me to people. I mean, the whole company is basically built in this room. Like Rachel introduced me to Yanni, who introduced me to David, who joined the team. And like, it's very, very, there's no shortage of benefit for sharing that builder story. But once you built it, you really got to share the like, what can you build with it story, especially if that's the thing that you want people to do with it. Also, like AI is kind of fun and silly, and it can be. And again, I don't think that I'm putting anyone out of work with regard to like generating awful little apps like this. But it is really interesting to think about how these tools are going to be part of our, the way that we use software, but also the way that we make software, potentially. So yeah, that's TealDraw. These are the slowest animations. TealDraw.com is the free whiteboard. It's multiplayer, it's free, it's really fun. TealDraw.dev is the SDK. And yeah, I'm Steve Ruiz, still tweeting. And you can follow us at TealDraw on Twitter as well. So thank you. We'll see.
All right. Steve, please stay on stage. Rachel, would you like to join us again? Do you have a microphone? Should we get you a mic, maybe? All right, let's get you a mic. Those demos, I've seen them 100 times before, and they still continue to amaze and inspire.
Thank you.
Rachel, please take a seat. You can be the first one to sit in the first seats. And there we go.
I'll stand.
Let's move a little forward. Yeah, sorry. Is this good? Yes, perfect. Thank you.
Awesome.
We do everything here by ourselves at Future Frontend Finland. We don't have technical staff. The organizer and the person who takes the most care and personal risk is also the guy who carries the chairs. So this is also how you, Steve, run your office, I believe.
It's a startup. Everyone does everything.
That's right.
All hands on all pumps.
All right, so we do have a bunch of questions, but while I wait for more questions to stream in, I have a question for both of you. There's one thing that you have in common, which not most people in this room have in common, is that you both have an arts background. You come from a different world, and then you've entered technology. And I really like the lens through which both of you see the world. But like, what are some things that you miss from your previous life in the world and the people in it that we should see more in tech?
That's a good question. I'm biased because it's a point I was just made 10 seconds ago or something. But one thing that every artist does is invite other people over to their studio to look at their work. And you drink a beer, you have a conversation about it. It's a very different type of conversation than the type of conversation you would have with a collector or even curator. But it's sort of the craftsperson conversation. Talk about the work, but you also talk about the craft. Yeah, I do wish that was more part. I think with Build in Public, it kind of is increasingly part of like the habitus of a developer to sort of be social with their work. But yeah, I love seeing what people are working on. I love hearing those builder stories. And yeah, sometimes I miss it.
Rachel?
I got to admit that this is probably like a more fanciful wish. I firsthand know that in order to get paid in life, you have to make things that other people want. But in the past 10 years, I feel like when I started in the industry, people were making more things that were different on the web. And increasingly, what I see is like, how all songs start to sound the same year over year as we progress towards whatever whatever singularity the human race is progressing towards. I see web design starts to look the same more and more, and it's like you got a landing page with a call to action button and a secondary action button, and it will have one of 3 themes that's popular right now, and you can pretty much copy paste this anywhere, and though, look, here's an app that will do that for you. The creativity has just kind of left, and I'm always so delighted when I find somebody out there like Nikki Case or this guy's team that's making something different or unusual. Maybe it looks different, it works different, tells a different story, does a different thing. Then here's a site, give us money. Call to action 1, call to action 2, and the same colors you saw last week. I just love seeing new and creative things because the web's the most expressive thing I've ever gotten to work with, and I'd love to see more people expressing themselves with it.
Nice. That's actually one of the questions has a cool idea in form of a question for you, Rachel. A person is asking, could you hook the animations into, for example, an audio input and events derived from it? Like, could we animate something to the beat of the music using the CSS Animations API?
This is something I always really wanted to do, like to build music videos using the Web Audio API. But the CSS Animations API is very declarative, so it's not very good at responding to things. You could hack it, though. Like, you could hack it up a bit. But I feel like in the end, you'd probably just end up using like the Canvas API and drawing to it in response to the Web Audio API. They have slightly different models.
Nice. Rachel, I'll batch these a little bit, so I'll do another question for about your talk as well. Like, how do you design those spring animations for the linear easing function? Like, is there a tool that you recommend for, sort of designing the Bezier curve other than using Make Real, of course, and having AI do it very expensively?
I don't know if you missed it, but there is a tool that I linked to that you can like edit the spring in it directly. It was created by one of the Chrome DevRel, and you can also, like, for instance, you could draw a curve using any SVG editor, and then you could copy pasta it into there, and it would come out with the cubic Bezier. It would translate it into the, pardon, not cubic Bezier. It would translate it into the coordinates needed to pass to linear.
Nice. All right. I'll throw a couple of Steve-specific questions, and then we'll get back to like common topics. I think, Steve, this is something that I also wish that I would have heard more in your talk. So maybe, what were the key sort of technical learnings that you gained from in your work in TLDraw and as particularly also the Make Real project?
Oof, lots and lots and lots. First is that it's possible to do this type of thing in the browser, in JavaScript, and rendering using like the DOM as a target. It wasn't entirely clear that that was possible when I started. Some of the biggest problems were related to reactive data. In TLDraw, you can basically have like parents that are rotated or moved around, transformed. They have children which are also rotated and moved around. That can be very, very deep, infinitely deep. And so you need to know when something's transform has changed based on like its hierarchy parent transform. Just picking like one example here. That is actually a really hard problem to solve. React solves it by pushing all that through the component model, but that's too slow to do for something like TLDraw. And so we needed to have this sort of basically signals, as was presented before. This was David Sheldrick's implementation of signals, which has worked really well for us. And that type of data reactivity, it's like all over the place. Some random menu button needs to know whether there's 2 shapes selected and whether one of them is an image. And like your selection is changing all the time, and you really need to like laser that data into the right place. There was that. Technical learnings around multiplayer. Synchronization is a super hard problem. I'm wearing a hat from the Local First conference from a few weeks ago in Berlin. It is an unsolved problem. We had to solve it for TLDraw, and I think we solved it very well for TLDraw. But that was like, big old chunk of work. And yeah, we're still learning more in terms of performance, in terms of like leveraging different APIs or browser APIs. I think one of the most interesting things that I learned with Make Real is just how easy it is to make something that is incredibly impressive using browser APIs. So like a couple of weeks ago, I was like, you know what? I bet this thing can use the camera. And so I drew a little box and drew a dumb smiley face in the middle of it and put a little red button there. And I'm like, yeah, I want a photo booth app, right? I never told it I wanted a photo booth app, but it figured it out. And yeah, it just worked. Like, just here's me, thumbs up, press the red button, and then it'll save the image out. And yeah, I feel like we're only scratching the surface in terms of making that kind of thing work well in the browser.
Nice. And how much sort of additional prompt engineering and or sort of like architecture do you need to do for specific demos? Or is it all just like one prompt and you just lean on the capabilities of the model?
With Make Real, we've twisted and tweaked and gone back and forth on the prompt constantly. Like, I think this is using a local, branch, and I tweaked the prompt there to, One of the fun things is that if you look up on GitHub the string, you love your designers and want them to be happy, you'll get like dozens of responses, which are all people who've just copied my prompt from Make Real. That was just one of the lines in there, and somehow it just made it that much better to say, like, you're working with your designers. You love them. The happier they are, the better your score will be, or something like that. I think at one point we also had that the AI is like, you are a 12,000-year-old web developer using eons of experience and wisdom in order to create prototypes for your designers who send you wireframes. All that stuff is, it's magic, but it doesn't really move the needle that much. The basic idea that like you get designs you can use unpackaged for JavaScript libraries. You can make sure your script tag is module unless there's something like asynchronous. Like, once you have that, the rest is kind of just window dressing. What's interesting, just one last thing, is that like for the other people who use the same pattern in their app, they're able to bring in like, here's who the user is. Like, here's what kind of app this is. It doesn't build anything, it builds like specific types of things. That's when you get actually like really good results, when you just can know more about what it is you're doing and who's doing that. So, yeah.
All right, there's a small chance that this next question is actually social engineering hacking, but I'll have to ask it since it's the most upvoted question. How well does TLDraw filter out malicious prompts in Make Real? Like, how abusable is it?
That's a really good question. Well, it's your API key. It's not mine.
Yeah, I think the person's interest just flattened, when they realized.
The models themselves do a pretty good job at policing themselves. We do sandbox the code in a way that prevents it from affecting our servers such as they are. We're also just guarded by the fact that there's not a lot of information around. It's basically like the only API key is yours, and that's the only unique piece of information in the system. So like, yeah, go nuts. But yeah.
Nice. All right, so we have like a whole bunch of questions for both of you that are very sort of nitty-gritty. But as we're coming to the end of the day, I figure instead of talking about like the very specifics of, for example, the CSS API, let's finish with something sort of like a future, forward, and something that is I think that we can have a conversation about. Rachel, you're looking at Steve's demo, and you're creative, you're an artist, you're a person who, is also a programmer, like there's a lot of these things which this thing does very badly currently, but it does it better than any machine before. How does that make you feel, and sort of, what future do you either, foresee or forebode?
Well, on the one hand, everything is a remix. So I'm not too intimidated by it. I mean, I hear my friends from my days as a cartoonist, they definitely don't like people being able to create things in their style. There's definitely a feeling of being being threatened for illustrators out there, as now anybody can get illustrations of reasonably good quality. Why would you ever hire someone to draw something again? Yep. That's real, but over in programming, I've looked at the code. It's all right. I think it's a dream that people will one day not have to deal with us as engineers, and they can just, like wouldn't engineers love to not have to deal with designers? Wouldn't designers love to not have to deal with stakeholders? We all just don't want to deal with each other as humans. But the interesting thing is that this is a machine, and it's also not very good at dealing with humans. So it might make a good collaborator for now, but I'm not too worried about it taking my job.
Yeah, I saw this great quote by a Polish artist, I believe. It was something like, I don't want a robot that does arts and music for me so I can have more time to do dishes and laundry. I want a robot that does dishes and laundry for me so I have more time to do music and arts. Does this resonate?
I don't know. So this type of discourse was already something that I'm really familiar with just because I have a background in art, and you see it happen where, like any craft, the commodity form of that craft disappears over time or is replaced by technology. Like there was a time where like having your little miniature painted was like a normal thing that people in a certain class did, and there were people who just were miniature painters. They weren't, like you won't find them in museums because they just weren't very good. They weren't like important. They weren't cultural contributions. They were commodity, right?
They were the medieval selfie?
Yeah, basically. And, like bassoonist used to be like a career, So that's just going to happen. That's like, you can't really like shed too many tears about it because that's just going to happen. Like, there's a certain level of anime art that's just going to be created by robots. Sad for the anime artist, but it's just sort of whatever. And the question is whether front-end development or just web development or just software development is, what part of that is commodity work that is inevitably going to be replaced, and what part isn't. You could probably look at like outsourcing for identifying which parts of a project, like are just like, well, let's just do this as cheap as possible, and which parts aren't. And yeah, I don't know, like Cognition, the Devon, if you saw the Devon videos and all that stuff, like they just raised like $200 million or something ridiculous. Like there's definitely a hunger for replacing that labor. I think, yeah, hard to feel good or bad about it, but it's definitely a trend.
Yeah, I mean, like it's weird because this has been the implicit logic of the marketplace for the longest time, is that we understand that making software is too expensive. So, we have developer tooling companies that, for example, try to make, making certain kinds of software easier. We have libraries, frameworks that, like make the, improve our output and the quality of our work. And then this just seems to be following the same like logic of the marketplace. But the one question that I feel like we're not asking is that, if we are making software, cheaper and easier to create, is who does it enable to create software that couldn't previously, build software, and for what problems can we now start to even think about solving that previously just wasn't financially feasible? And so in this world, do you have any sort of like optimistic visions, for the future?
Absolutely. That's the part of the fun of, when these commodity forms are replaced, right? Like, there's not as many professional bassoonists, but like, we probably hear more music now than we've ever heard before. And the idea that like the ability to generate software for weird niche cases is going to be a popular, it's going to be an option for hundreds of millions of people who right now just don't have access to software for their niche case. Maggie just gave a great talk on this, Barefoot developers, also at the same conference. Yeah, I mean, like most of the developers that I know got into this because they were making like a website for their band or something, or maybe they're like Halo
or
clan,
their comic,
or a fan page or something like that, right? And those types of things are, yeah, you don't, you only get them if you have the people who can do it. But I expect a lot more of that type of thing. I don't know.
Wow, I think you pointed out something. You said it was very powerful. You said, what are the problems that these resources free us up to tackle that were too big in the past? Like React and React Native, for instance, it's not just one tiny team working on it. It's multiple teams from like Microsoft and from Meta, and there's like an open source component with like partnerships with Vercel and Expo, so that people who aren't part of a 1,000-people company can still build meaningful things. And the only way that those things could be built, because no one company would make that kind of investment in that platform, would be for people to operate together, engineers and companies, in open source. And the only reason we can use AI the way we're using it today, or LLMs in this case, is because we've just hit the peak for computing power. The human race has some really big problems facing it right now. I don't know, this climate change thing, squabbling over resources. You beg a really good question. If resourcing is such a problem, why are we afraid that we've suddenly freed up a bunch of resources when we have these pressing problems? Isn't there something better we can do with our time than keep designing the same landing page with the 2 buttons over and over again? That sounds automatable to me.
Yeah, I mean, just to answer, my point of view on that question, I mean, I think the problem is that the logic of the marketplace only cares about profitable problems. And so, when we can free up those resources, I mean, that's a cost. These people need to be paid and fed and clothed and all of those things. Ideally, for the people who benefit from this, they wouldn't want to do any of that. And I think this is, and we're not going to go too deeply in this, but all of the things that you, for example, Rachel, just talked about, React Native, these are corporate-sponsored projects, but they are still in open source, and they're freely available for everybody to use. I know that there are some open source models currently available in the AI in that space, but fundamentally, we are, using, like a paid-for corporate, products. We're kind of ceding control to those black boxes that, we previously, could have sort of done without in this previous world. So how do you see, for example, in your line of business, you're a startup founder, do you see space for free open source software building on top of AI, or does everybody now need to go raise a seed round in order to build anything meaningful?
I don't know. For example, we've been pretty insistent about not training models or fine-tuning models. I don't think we've spent more than $100 on OpenAI credits or something like that. And I guess for us, that's part of the fun, is to sort of be surfing on the publicly available models and to try and trick these things into doing what we want, and also to kind of explore their own kind of tendencies rather than teach them exactly what we want from those models. But yeah, I don't know. I think my hope is that if you are in the business of using LLMs at scale for something interesting, that needs to be actually useful, which is very different than, for example, crypto or something where you can spin a lot of GPUs for that as well. But I think that sooner or later with LLMs, it's just yeah, you have to have something that you're actually doing with this technology. I don't know as to whether it's just given the resources needed to train these models and stuff. Open source is probably the closest thing. Corporate-backed open source is probably the closest thing to something that doesn't really make you uncomfortable from using sending profits to stakeholders or something. I don't know, or shareholders. Yeah.
Yeah, and Rachel, you've spent the last few years in big tech. That's kind of the opposite in a way what Steve is doing. Is there a perspective, there?
Honestly, I was just blanking out for a minute thinking, I wonder when people who have the most money in the world, pardon me for saying this, the Elon Musks and the Bezoses and the Zuckerbergs will realize that solving these really big problems is long-term profitable and start dumping that investment money into I don't know, carbon sequestration. That was where my head was wandering. It's I wonder when that tipping point is coming.
Well, we are getting on with the afternoon, so maybe everybody's starting to drift off. So I'm going to finish with the one final question. This is a question, is currently the most upvoted, and it's for you, Rachel, but I'm going to kind of modify the question, so both of you get to answer. So Rachel, the question for you is, what is next for Alice, and then what is next by proxy for Rachel? And Steve, same for you in a minute.
You're bringing existential angst with that question. I'm taking some time. I guess it's the spirit of layoffs, and I decided I'd nerd out and be a little bit of an artist for a bit. I'd like to get Alice into shape so that she can go forth and teach people the fun things I shared with you today. I'll probably do some more upgrading of my older demos. I've got like Sleeping Beauty in Space and a couple of others. I'm working on that book on how to survive your tech career. After this, I'm not sure. I'm not sure what's up. I'll figure it out. Might go back to engineering. Might found a developer influencer agency. If you have ideas, talk to me at the after party.
Teal draw. It's really the story hasn't changed. It's just gotten more interesting. We have an SDK on the market. I do way more sales-related stuff than I ever thought I would, but it's working. It's surprisingly working. I think some of the core theses that we had about this and the value that a primitive for this could offer are being done. So I'm just doing the startup thing. I think we're going to continue finding ways for this thing to be useful, and there are no shortage of kind of ideas, especially, I have a very creative team, and they have a lot of creative ideas. We have 2 people whose basically full-time job is just to play with this thing, see what it can do, and tweet about it. Those are the jobs that I'm envious of myself. But yeah, we should be doing, we finally have a landing page coming, so we should be doing, yeah, you don't need those. You don't, the whole, you don't need to program them. You don't even need to have them. It'll be fine. But yeah, we should be looking a little bit more like a company by the end of the year.
Nice. Well, my sort of narrativizing brain also drifted off, started to think a little bit about the themes of this conference, the 2 days that we've just had. And one of the things that I think both of you embody, and quite a few of our talks actually embody, is making things. You're both sort of makers and creators. And I think this is not going to be a question. This is just maybe me sort of musing and trying to bring this into a harbor. Is I feel now feels like a season of making. It feels we've now entered. We are maybe going from the React era into a new library framework era where there's so much space for open source creators to sort of do new experiments and fill needs and fill holes. And we have all this boom of new technologies in AI. We have new browser capabilities. We have all of these things, but there's every time you sort of open up new land, you make space to grow something. So I feel like this is the year that we can make something, and so hopefully many of you will go and make something and present it here on this stage in a year's time. So with that, let's wrap up the conference and let's give it up for our panelists. And I am going to hand the microphone to Juho, who will have a few, I am sure, erudite words to share with us. So let's get off the stage and give it up for Juho.
Thank you. All right, so I'm Juho Wepselainen, and I'm the director of the conference. I think I was doing some counting. I think it's the 7th conference I'm directing. So you can see the iteration speed is quite slow. So it takes, you cannot learn everything at once. And I think I would need 100 iterations to be good at it. But you know how it goes. Just a little bit about background of Future Frontend. So you might know that we had something called React Finland, but then we understood that we are at a dead end. It was not a very interesting conference for us anymore. So last year we did a pivot called Future Frontend. This is the 2nd iteration of this conference. And what's the point of Future Frontend? Well, that is to, I wrote this mission. I actually forgot the exact formulation, but the point was to combine the Finnish developers with the world in a way. So we want to bring the world here to learn from you. And in addition, we want to provide inspiration for you. So when you go home, or your office, or wherever you work, that you have something new in your mind. You know what's coming, what's possible. So that's sort of the gist of it, or what's the conference about. And I hope you had 2 great days in Helsinki. So in a way, it's also like selling Finland. So we want that people come to our little country here at not center of Europe, but at the at the edge of Europe. But anyway, this kind of conference, it will be, you could do it without sponsors, but then you will not have food, you will not have after party, you will lose a lot of things. So that's why I want to first give great thanks to our sponsors. Main sponsor, Digia. Silver sponsors, Evidec Solutions and UpCloud. Bronze sponsors, Toddle, Alma, Knowit, and Columbia Road. So thank you for helping us to make this conference even better. So you lifted the level of the conference by a magnitude. So thank you for that. And if you were here last year, then you know that I'm trying to get a new hat. So I'm in this doctoral program. So I'm pretty close to done. I'm like 2 papers short. You know how it goes. But yeah, I didn't want to tell too much about myself. I wanted to do research on you. Because the point is, if I send you a query after the conference, nobody will answer. So now I will try to get some quantitative data out of you. We do qualitative studies at the after party. So now, let's see how this works. It's actually first, I'm testing this live. If you can go to Slido, so if it's FF2024, maybe you could try to, fill this up. Because then we can get some data, and then we can see what actually happened during the 2 days. I have to see if I can get this visible. It's present. Yeah, I think you're supposed to fill it now. So let's see. You can still fill. Yeah, that's good information for me. So this means that most of you are here for the first time. So actually, maybe that was one of the problems. So we didn't sell enough to these people that came last year. But yeah, maybe poor conclusion. Let's see. First visit to Finland. So 38%. For me, that's a lot. I think it tells that we have other people than Finns here. And then how will you rate Finland? So I use this emoji scale, which is really scientific. But it seems like many people seem to like Finland, which is good, of course. You don't have to lie. Remember that. Yeah, pretty good. I'm like between 4 and 5 as well. Conference food. Yeah, you like the fish? Yeah, okay. And cauliflower if you don't eat fish. Content, yeah, that's good, between 4 and 5. That's the target. We want to go for 4 or 5. We cannot do complete 5 because, that's impossible. How likely are you to recommend the conference to a friend? Yeah, that's a good figure because it means we might get, other people coming later on. And how would you describe the conference? Well, I think that looks good to me because our target here was to inspire people. So that's exactly in the middle. I think that's it for this part. As I told you, I will do the rest of the study at the after party. About sticks and stones. I don't know if you know the story, but 1 year I decided now we give stones to our speakers. And what happened, I didn't read the numbers online like close enough. So what we got this 1 kilo stones. It was RF 2019 or something, you remember that. And then people had to go through customs and then they are asking like, what's this? So we didn't want to repeat that this time. So that's why we went with this wooden gift, because it's less suspicious. So for this reason, I would like to get our speakers on stage and the box. And now we have to improvise and figure out how this find the. I take this one, and now we have to share. Yeah, they have names. Yeah. Jari? Samuel. So, yeah, sorry, it takes a while. Steve. I got you. Okay. Yeah. Now it's the difficult part. Yeah, this part. So now we have to take a, wait a minute. Actually, I think I want organizers on stage, volunteers on stage, and then we try to take a photo, a big group photo. Yeah, and now it's a sorting problem. So do we go from highest to smallest or what?
We could do some more small people.
Yeah.
Don't be afraid. Come stand.
Yeah, okay, let's give it a go. I think we're done. If you want, you can leave the stage. You can also stay if you want. All right, so this after party thing, I think it was maybe one of the most challenging parts of this year, because we have a little bit, let's say, limited capacity, but we have Finns, so we figured out, and programmers, so we do some buffering. So if you explicitly, if you're registered for the after party, you can get in. If you're not registered, we will figure out the solution. So you should show up at UpCloud headquarters, opposite of Mummotunneli. If you know a Finn, or if you don't know a Finn, you should make a new friend and ask them about that word. I won't tell it on stage. But anyway, it's a short walk. Maybe you go to hotel. Don't be too early, maybe 15 minutes to 6 or close to 6. And then we can, there's some food and things you have at after party. Yeah. But that's it for me. I hope that I see some of you next year. And I don't know how to end a conference. Let's say it's like kiitos. I think that's a good way to do it. So kiitos.